Check, 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 1, 2, check, check.
Hello, hello.
All, welcome to the two-day workshop on full depth reclamation technology organized by KSCSTE National Transportation Planning and Research Center NATPAC in association with Kerala Infrastructure Investment Fund Board KIIFB. The workshop is packed with a schedule of informative presentations and discussions lined up that will explore various aspects of full depth reclamation from design and construction to maintenance and durability. Let us take this opportunity to learn from each other, gain insights into latest developments in the field, and explore ways to implement full depth reclamation more visual and engagements.
To begin the technical talks, we are privileged to have with us Sri UK Guruvitar, who will be handling the session on the topic FDR for low volume roads. To introduce the speaker, I would like to welcome Sri Shahim, Principal Scientist, NATPAC.
Very good morning to all. Say a warm welcome to all the delegates and experts present here for the 2 days workshop on full depth reclamation technology. I would take this opportunity to welcome Sri UK Guru Vittal, who has retired as a chief scientist from CSIR's Central Road Research Institute, New Delhi. He was the head of the Geotechnical Engineering Division in CRRI. He has more than 35 years of experience in R&D activities in various topics related to highway engineering, such as the use of industrial wastes and marginal materials, rural roads, ground improvement monitoring, quality audit of roadworks, etc. He has published and presented more than 100 R&D papers in various national and international journals, conferences and seminars, and authored over 75 technical reports. We welcome you, sir, for the presentation. Thank you, sir.
Thank you. Very warm welcome to all of you. I am to be here. I thank NATPAC for inviting me. Glad to meet my academic friends, Sunita ji, Suresh, and Dubey ji from UP, and industry friends and professionals. So this first lecture is with regard to this, how this FDR technology is to be applied for low volume roads, S5 roads. We'll move to the next one. No, that is okay, but they are not able to see any slide now. If I do it, it will be for me, not for them. So, but Fine, fine, fine. But this will not go. This will,
Okay, still operates.
this will not go. And if pointer is to be used, we have to use the mouse there. Okay, go you are there. So as you all know that we have two types of payments, rigid and flexible, and flexible payment may be either a granular payment or the bound payment, and due to reasons like traffic loading and environment, mainly the drainage and aging of bitumen, etc., the distress occurs. When the pavement has very much distressed beyond maintenance levels, when it is no more economical to maintain it, we have to go for rehabilitation. There are different options available for rehabilitations. We can go for a thick overlay. We can go for a removal and replacement entirely, and we can go for full depth reclamation. The first two options are not environmentally sustainable. They are not economical. And that's why we have adopted the third option, full depth reclamation, for this rehabilitation of PMGSY roads. So what is FDR, full depth reclamation, that I have written in next there? It is recycling the entirely distressed bituminous pavement into a new base layer by excavating and pulverizing it and adding with a binder. There are several advantages you all very well know. Mainly, FDR is active nowadays because it is a sustainable technology. It's a sustainable technology. The definition of the FDR process I have given there. As I told, we have to it can be cement plus lime, it can be cement plus lime plus fly ash, it can be cement plus some commercial stabilizer, and even a bituminous emulsion also, bituminous emulsion, foam bitumen also. Of course, bituminous additive, it will be costlier. So that's why we in India, we have largely adopted cementitious additives. I have written one point, there's upgrade inclusion. At some locations, it has, because the existing pavement thick the grade with the existing pavement layer before it is placed. So the addition of a upgrade, of course, as you can very well foresee, it will bring down the strength properties. So that's why is not it's some we have to discuss it. Economical process worldwide in which the similar kind of processes, but it is different also because whatever the stabilization, whenever we do, we refer it to the stabilizing a natural material, but FDR is a, we are recycling the existing pavement, that's the man-made material. Next one. So for FDR process, invariably, for the this machine, it pulverizes the existing pavement, it excavates and pulverizes the existing pavement. And whether it will break the existing stones also, maybe to some extent, but not exactly. Because if it is, if the existing pavement is having soft grade aggregates, maybe laterite, maybe brick bats like that, there is a chance that such aggregates will be broken. But if it is having very hard stones, like what we normally encounter in the south, maybe granite or such type of hard stones, igneous rocks, stones made of igneous rocks, definitely it will not be feasible for this reclaimer to break it, authorize it, but synonyms and suitable, this reclaimer machine is a must for our process. Without that, we cannot do this process. Next one. So there are many limitations of FDR also that must understand while applying. Wherever the failure is due to the subgrade, poor quality subgrade, or failure is due to the drainage problem. In such situations, this of course, wherever the rehabilitation is to be done, the distress is too heavy, we go for FDR, no issues. But before that, whatever the situation, whatever the condition is there, the payment condition is there, it is to be studied. And if the failure is due to poor soil, poor subgrade soil, and the lack of drainage, that situation has to be rectified. It has to be corrected first, and then only FDR has to be done. How that is to be done? No way. There is no other go. We have to excavate the pavement, keep it aside, attend to that drainage issue, attend to that subgrade issue, and it has been rectified. Then only we have to bring back the pavement material and do the FDR. Otherwise, it will fail. And of course, the next limitation is that, like a stabilized layer, FDR layer is also a bound layer. It will develop cracks eventually. These cracks are not supposed to get reflected on the wearing surface. So that's why we need a crack arresting layer. It may be a SAMI layer, it may be an aggregate crack arresting layer also. Most of the places they have used a SAMI layer, but few places, as I have come to know, like Maharashtra, they have used this aggregate interlayer also as a relief layer. You can choose what are technically and economically feasible for you. Traffic should not, FDR layer is gaining its strength. That is when it is new, it has to harden, just like any concrete pavement. So impact of FDR layer on pavement drainage, that's the next very important factor, because whatever the existing granular pavement is there, that we will be converting it into a bound layer, cement bound layer, cementish bound layer. So what will happen and how it is we have to ensure the pavement drainage? This is a very big question. Intra-pavement drainage, whatever the water that enters into the pavement, that has to be taken out. It should not be allowed to go into the subgrade soil. So how do we ensure that? That's a big question. Of course, worldwide, we have been using FDR technology, FDR process, and it is working. But a amount of research is required in this section. The roads, low volume roads are suitable for FDR. Recently, everyone is implementing this way. So this, as you know, the flexible payments in the roads, they are designed to complete the service life. When existing payment has more than 50% distressed area. So if the distressed area is less than 50%, it is not wise to adopt FDR process. It will be little bit costlier. If it's less than 50%, you can go for maintenance measures. Maintain the road and let us get the serviceability of that particular pavement for a few more years, maybe 2-3 more years. Maintain it properly, and then we have to go for FDR process only when the distressed area is more than 50%. And even if the road pavement is made up of low-grade materials like that, after which need to be replaced, there is no need. So we can directly go for FDR process in such type of payments. As I already told, condition survey is a First requisite, we have to visit the site, we have to examine the pavement condition, we have to see what is the reasons for the failure, how much is the failure, then only we should go ahead with the FDR process. Identify the road sections having the distress due to poor subgrade or inadequate drainage for separate treatment. Of course, the poor subgradation, especially drainage, may not be prevalent in the entire of the road, entire stretch of the rural road. So wherever that drainage problem is there, those sections only they have to be identified, and they so what are the candidate roads for this FDR process? First one, of course, you know, it's the pavement has black topping has almost disappeared. Raveling, aggregates coming out, extensive cracking, potholes, etc. So this kind of a situation, it warrants adoption of FDR process. Next one. These are some of the roads where, of course, the pavement is very much distressed, but we cannot directly adopt FDR process. The first one, of course, it's a hill road. Due to slope stability, the failure has happened. So unless and until you correct that slope stability, instability problem, if you adopt FDR process, once again the pavement will fail you. So that's why, first of all, the slope instability problem has to be addressed by properly providing some maybe in a masonry or a type of this retaining works, and then we can go for FDR. The second one in that, of course, is having a deep cracking and settlement throughout. You can see it is running throughout the pavement. That's also once again a slope instability problem, because near the road for taking the soil for the embankment works. That's why when the water filled up in that whatever trench they had made, the instability, because of that instability, it has failed. So these kind of situations have to be rectified. The third one is a drainage issue. You can very well see. And of course, wherever the fourth one is when the groundwater table is very high. When the groundwater table is very high, of course, the subgrade will be and the subgrade density will be very low. That has to be rectified. Otherwise, even if you provide not just FDR, any type of payment on such type of situation, it is going to fail. Next one. Project selection criteria, condition survey is to be made. That I have just told you. Existing road is to be divided into 100 to 250 meter section length, and groundwater depth is to be noted. No scarification and disposal of blacktop layer is required. That is also to be recycled. Cement concrete pavement design life is 20 years. So that's why it's not advocated to include cement concrete pavement also in the FDR process. Of course, not good. The equipment manufacturers will be able to tell whether their machine can pulverize CC pavement also. So these kind of issues are there. That's why we don't advocate having FDR process in the CC pavement section. Next one. Many locations we go for intermediate lane construction, that is widening of the existing single lane road. So where we should adopt this intermediate lane, that's very well clear in IRC guidelines. So IRC 64, it gives whatever the capacity that's required. That is given by the single lane as well as intermediate lane. So we do the traffic survey to find out how much PCU is there, how much traffic is there per day, and depending on that, we can easily decide. Next one. Now, whenever we go ahead with this road works, we adopt the first step. Of course, it's DPR preparation. You all know the DPR template. NRIDA has given. We follow the DPR template for PMGs works. There are 21 DPR template, and same template we can adopt it for FDR works also, but little bit of modifications will be required. So what are those modifications? So in the chapter 4, which deals with soil and material survey, the payment condition survey has to be included. And we have to give the details of that, whatever payment condition survey we have done, type and extent of distress. And regarding the tests that are to be done on the existing payment, so details to be given. And most importantly, the mixed design using whatever type of cement and whatever type of stabilizer you are using. So that is to be included, especially bringing out the 7-day strength and the durability test results, etc. Then in the chapter 9, of course, the payment design chapter, you will be designing it as a bound layer using KSCSTE-72. Chapter 14, road since the road will be under reconstruction, reconstruction situation, what type of traffic you will be adopting, because we can see traffic, what version we'll be providing, that we'll have to discuss. Specifications for FDR will come in chapter 15, next one. In chapter 17, which deals with the climate resilient and carbon reduction strategies, definitely they enrich the chapter using the salient features of this FDR. Chapter 18, it's a technology, FDR technology. So these details are to be highlighted. The 19 deals with the rate analysis for your FDR process. And the 21 will deal with construction program, what the contractor proposes to adopt. That will be brought out. Material testing. So coming to different aspects of material, these are all, of course, already spelled out in IRCSP 72, and you are very well aware. The same procedure, whatever you have been adopting for conventional road construction, adopted similar manner to FDR process also. So and the field moisture content, that's the collection details are even there. One important factor is that we must collect adequate quantity of the pavement layer materials for test, because in the coming slides I will tell you some of the material we will have to reject, well, means it will not be usable. So that's why in the beginning itself we must ensure that adequate quantity, 450, 500 kgs of sample, maybe even if we bring 600 also, that will be better, of the pavement layer sample is to be brought, and that is to be taken out by making suitable number. So this is a quartering technique of making the pits, how we the sample. So these are the tests. Layers starting with grade index and CBR, that's including the subgrade, including the base course, and of course base course is mixed and would be better, because we will be adopting heavy compactor. Field compactors will be using. So that's why the we have advantage. They don't come here. Let's make use of such a situation and let us try to achieve it. Result in better performance. So that's why heavy compaction. Cube strength, that will say as per I6, 15 centimeter cube molds we have to use, and we can compact those molds. The size is also higher. So the better thing is that to have a 15 centimeter is there for the and 4.5 MPa, that's what we normally following. That should be our target strength for which we will be determining the optimum percentage of additive. Additional cube samples are to be made for durability test. Next one. And durability test, as I already told you, please adopt method 2 in Kerala. This is the gradation. Of course, the first gradation is whatever you are familiar, it's in MORD specification for cement stabilization. But that gradation is not very much suited for FDR process, because in we will be having WBM G3, WBM G2, as well as GSB, which will be having bigger size particles. So until and unless you accommodate those bigger size particles, you will have to manually remove those stone aggregates and all, which is impossible. So that's why different gradation I have put it there, and it's having only force usages also. And most importantly, 75 micron. The cement stabilization gradation, whatever that's given there in the MORD specification, is having a maximum percentage permissible is only 10%. However, the GSB material is already having 15% fines as per MORD specification. And during the service life, the percentage of fines may increase a little bit also. So that's why, keeping these points in view, we have to adopt a practical gradation. Next one. Whatever the gradation I showed you is whatever I have seen, the gradation adopted in US and abroad. It's not that I have given it like that. So I just saw their references, whatever guidelines they are following. Based on that only I have given. Pavement designed to be as per IRC SP72. Design traffic, if it is more than 0.3 MSA, crack relief layer is required. Otherwise, we can just go for this surface dressing layer. Aggregate crack relief layer, it may be two types, either a WMM layer or a WBM layer or a SAMI layer. And if we adopt it depends, take no economic feasibility. If your aggregate crack relief layer is better suited, definitely you can go for that. FDR to be used as a bound base for the flexible pavement. Next one. Subgrade strength evaluation in terms of CBR. Of course, these are the steps. Transformation survey we have to do, and ETC survey if it is more than 1 MSA. A design life is taken as 10 years. We calculate the ESCL, and then of course the required thickness we work it out using the IRC SP72. Next. Whatever the template of IRC SP72 for bound layers, they have given it separately for sub base and base. They have to be combined. When we are going for FDR layer, they have to be combined, and the combined thickness is to be provided. Restricting the recycling to base course alone will limit the thickness of FDR layer. There are some apprehensions about why we should go, recycle even the GSB layer also, because otherwise the drainage, how we can ensure, especially in a high rainfall area like this. Unfortunately, if we restrict FDR process only to base course layer, thickness will be very little, very small, and we'll have to go for addition of new aggregates. That's not advocated. So we have to judiciously take the decision regarding this, how much thickness we are going to recycle. Thickness of the cement base course and all for 2 MSA traffic, I have given it there. And when it exceeds 2 MSA traffic, we have to go for, we refer to IRC 37. And the last point, whatever the existing pavement thickness is there, when we go for FDR process, the existing pavement thickness may little bit reduce. This may seem to be strange for you, but that's because the heavy compaction will be there, and the existing pavement may be by 10%, it may get reduced. Next one. This is what I have taken from IRC SP 89, and it shows the aggregate crack relief layer on the top, and that layer because the base and sub-base will now be will be converted into a bound layer. Whatever the top aggregate crack relief layer is there, that can act as a drainage layer. And suitably, we can modify the wet mix macadam gradation, bring down the fines content. The range is there, so adopt the lower one, bring down the fines content, and we can use it as a crack relief layer. That's one thing what I have in mind, but of course it's not proven in the field. My friends can take it up as a R&D work. Next one. Construction and specification. FDR work is machinery intensive. A large number of machineries will be required. It's similar to cement stabilization. In situ operation is to excavate and pulverize the existing pavement, mix it with cement and water and compact it. All the operations will be carried out in situ. FDR process will be carried out in situ. So whatever the different equipments are required for this FDR process, I have listed it there. And cement spreader to distribute cement in dry form or in a slurry. We normally adopt the dry form. In abroad, a few projects they take it, they do it in the slurry form also. But for our rural roads, we can very well adopt the manual spreading also. That's also because I've not done FDR using manual spreading, but I have done projects in stabilization, cement as well as lime, using this manual spreading process. So manual spreading will also be equally efficient, and hardly in a day, we may do 400 meters, 500 meters of maximum of the stretch, and that can be manually easily done. Simultaneously, during execution and pulverization, water is mixed, water tanker is required, because whatever the reclaimer is there, it is not having a water tank. So water tanker is to be attached to the reclaimer. Next one. So this is the manual spreading. Of course, it's not for FDR process. That is manual spreading for cement stabilization. I have shown there. We calculate how many bags are required, and we keep it at equal distances. That's that we call it as spotting. And then we spread it. And after spreading, open it and spread it. And then, of course, the machine is operated to mix it. So actually, if you do the manual spreading, it will be easier for the quality control aspects also, because instead of spreading it by a machine and then measuring how much cement has been spread per square meter area, calculating the number of bags required, and first of all, ensuring that so many number of bags have been placed there, that will be an easier process. And, this milling drum for that FDR machine, it is having a teeth made up of tungsten carbide, very hard material. Next one. So many reclaimers are there, so many companies are there for the reclaimer, for supplying the reclaimer machine. Unfortunately, all of them are imported. And most probably, if it is made in India, that would be better, bring down the cost also. And most importantly, whatever the width of recycling is there, is not, they do it. It is as per that requirements, as per the conditions in abroad. And so if we have to do the recycling of entire 3.75 meter in one go, so it would be better to have our own machine, or maybe half. So 1.8 meter, 1.75 meter, that width of this recycling. If we can tailor make our own FDR machine, that would be the best one. Next one. The output of that machine, of course, this is what the machine suppliers had told me. Reclaimer can be operated in single pass or in two pass. In single pass, it will excavate, pulverize, mix with the additive and water, and of course, lay it also. That's what everywhere is adopted because of economy. But if we are not able to mix properly, it's better to go for two passes. In the first pass, it will excavate and pulverize. In the second pass, it will mix with the additive. The drum rotates backwards when the machine moves forwards. Okay. Pulverization depends on the speed of the reclaimer, the drum rotation speed, etc. These are all the mechanical engineering aspects. Definitely by doing it in the field, you will be able to get expertise in that. FDR layer is to be compacted in one lift So that's why high thickness of the compacted FDR layer is there. Very heavy compaction machineries are required. Next one. Different types of rollers are to be adopted. Tamping foot roller, vibratory foot roller for breakdown rolling, smooth wheeled single drum roller for that, or maybe pneumatic also for intermediate, and tandem roller for finishing rolling. So this breakdown rolling, you are very well aware. It's similar to whatever the breakdown, intermediate, and finishing terms we use in bituminous layer. So here also similar aspects. So we have to bring the material nearer. We have to break that whatever the existing structure is there. And intermediate rolling, it adds to the density, and finishing rolling, it gives the smooth surface. Roller passes to have 50% overlap. It's a granular material, so that's why higher overlap is required. The grader is required after rolling. Compaction to be completed within 2 hours of mixing water with cement. Utilities to be identified and protected. Okay, curing for 7 days by sprinkling water. This is very important aspect and most often neglected aspect, curing. The curing has to be done properly. Curing need not be done by ponding, that's not required. If you spread this wet jute cloth, wet hessian over this surface, FDR surface, finished FDR surface, and keep it wet, keep it moist for 7 days, that's what is required. It's similar to the whatever the curing we do for cement concrete pavements. So, and that's a very essential process. Trial stretch is to be first of all made and finalize. We have to finalize our construction process. Next one. So these are the machinery sequences. I have shown the spreader first, of course. As I told you, it's an option to you. If you, because along with the spreader, you will have to use the bulker also. The spreader cannot be filled with cement by itself. So we need one more machinery. So investing so much money on this spreader and bulker, personally, I would feel that instead of that, if we go for this manual spreading, it will give employment opportunities in rural areas also. Anyway, then of course, the reclaimer, most important machine, which we cannot do away with. Then that has to be attached with the water tanker, and then different types of rollers, grader, etc. Okay, next one. These are some photographs, different states. The process of constructing, you are also very well aware. Okay, next one. These are some machinery which we should not adopt for this FDR process, like a ripper is there, the pug mill is there. So this we cannot adopt. And the reclaimer is the machine, a proper machine for pulverizing as well as mixing. Next one. Quality control test. Once the construction process is familiar to you, we have to know the quality control tests that are to be done. For the rural roads, as you are aware, the quality control tests that are to be done, they have been divided in the MORD specification into 2 parts. One is during before construction, one is during construction. Second part is during construction. So before construction, during the DPR preparation, we have to do these tests, existing pavement subgrade and other pavement layers. We have to do the gradation, plasticity, etc. CBR, whatever the specified frequencies has been given. The mix design, most important aspect. Cement type to be reported and additive to be reported. Before construction, what is the, of course, we must test the cement material and water also. Next one. Then during construction, the pulverization of the pavement layers, whether we are achieving the specified gradation or not. Placement moisture content, it should be after as per this heavy compaction test, OMC the plus 2% maybe. Placement moisture, and then quantity of the cement that is being spread. Either you spread it manually, you spread it using a machine. You have to check how much cement is being spread. A layer thickness after compaction, in situ compacted density. Of course, that has to be measured maybe by sand replacement method. Compressive strength of cement admixed mix. We have to make cube molds. Then we should take this cylindrical samples also. We have to extract that cores from the field compaction after 7 days, and those cores are to be tested. Next one. So these are some cores which photographs of the cores of the FDR layer my colleagues had given. The first two represent very good cores extracted from FDR, finished FDR layer. And you can see the thickness, you can almost up to 30 centimeter. They have compacted using these heavy compactors, etc. And no, there is no honeycombing and nothing, and the strength has come very well. The last one, of course, also my friend had given, and it's a core which was broken during the extraction. Many times cores break, of course, that's not a big issue, but this particular one, if you see that, it broke because it's not having the adequate strength, and the problem there was too much of soil particles there. That's what he reported. I don't know, of course, it's a photograph which I have received. So, next. These were some important points which I wanted to discuss with you with regard to this FDR process for the low volume roads. Thank you. And if you have anything to ask me, I would be glad to answer if those questions. Thank you.
The session is open for discussion. If you have any queries, you can ask.
I just wanted to introduce Guru Vittal, who prepared the do-it-yourself document for the PMGS or NRIDA. So he's an authority in FDR technology, especially for the low volume roads. Tomorrow again, he will be giving one more lecture. He'll be here for both the days. And if you want to have more interaction, that is also possible. Maybe some 2 or 3 quick questions probably we can permit.
If there are any questions, can you please raise your hand?
Okay. One question.
Hello.
Any questions?
Sir, good morning. This is Amit Singh from LSR. What I want to know is that can FDR be used as a profile correction layer, sir, by using cut and fill method?
Actually, profile correction. This FDR, as I told you, it is to be used when we go for rehabilitation. So profile correction is normally required during maybe reconstruction also. And of course, when this functional performance is not up to the mark, then also we go for this profile correction. But the layer thickness that is required for the profile correction is very little. FDR process, the entire permit we are recycling. These are 2 different things. FDR is for the rehabilitation of the totally distressed pavement. Of course, during FDR, whatever the profile correction is required, that can also be looked into. That can also be looked into.
No, agreed, sir. But can cut and fill be used while executing FDR, sir?
Cut and fill of what?
Of the existing pavement, sir.
The existing pavement itself is to be recycled, and it has to be used in the FDR layer. So that's the primary requirement.
Exactly my point, sir. So it is settled that we cannot use cut and fill.
You are not using correct technical terms. You are not using correct. I am answering you the profile correction because over this FDR also we will be providing the black topping layer. So if little bit of profile corrections is required, that can be rectified during FDR. But the main purpose of FDR is to rehabilitate having more than 50% distress. In that process, while we adopt this, whatever the profile corrections are required, that can also be incorporated.
Right, sir. Thank you.
But for profile correction as such, it refers to only making equals to only. So that can be addressed during FDR process, but the FDR process is not meant solely for approach.
In some cases where there are two layers by
Increase by first of all, you have to increase by
Thank you for the presentation. Myself, Amrita. Do you really find it relevant for including any cement stabilizers additional than conventional, sorry, not cement stabilizers? Because nowadays, several soil stabilizers are being introduced as strength improvers in FDR layers. But it's a bit from its price point of view. It's relevant to be used.
repeat your question.
Question is not clear.
So beyond binder, nowadays the discussions of using commercial additives are being going on, and we are including that as well. So do you really think it is relevant to be used in FDR layer?
I would leave you your questions to be answered by commercial stabilizer suppliers.
Okay, thank you.
Any more questions? Okay. I would like to take this opportunity to thank Guru sir for having a very informative session on FDR technology on low volume roads. He actually explained about the basics of technology and also the payment design related to low volume roads and also the construction and specification regarding the low volume roads. I once again thank you, sir, for having a wonderful session. Thank you, sir.
Now, I request Professor Dr. Samson Matthew, Director, NATPAC, to hand over the memento to Guru sir as a token of our gratitude and love.
Now we will have a short break for tea and snacks arranged outside the hall. Requesting all to
Requesting all to assemble back at 11 when the inaugural session is being organized. Also, exhibitions are also going on. Okay, you can have a visit. Thank you. Everyone, please be seated. We will be starting our inaugural session soon. We are expecting our honorable MLA.
Please assemble back to the hall and please be seated. The inaugural session is about to begin. Welcome back to the two-day workshop on full depth reclamation technology organized by KSCSTE-NATPAC in association with KIIFB. First, I invite Professor Dr. Samson Matthew, Director, NATPAC, Sri Loknath Behra, MD, KMRL, Professor Dr. A. Veera Raghavan, Retired Professor, IIT Madras, Sri Murali LS, Principal Consultant, KIIFB, to the dais. Let us now begin the program with the innovating song.
जय जय कोमल केरल धरणी जय जय मामक पूजित जननी जय जय पावन भारत हरिणी जय जय धर्म समन्वय रमणी जय जय कोमल केरल धरणी जय जय पावक पूजित जननी जय जय पावन भारत हरिणी जय जय धर्म समन्वय रमणी प्रेमदमागुं प्रमदवनं तान् श्यामल सुन्दरमिन्नुडि राज्यं मलयज सुरभिलमारुदनीर्कुं मलयाळं भामामकराज्यं प्रेमदमागुं प्रमदवनं तान् श्यामल सुन्दरमिन्नुडि राज्यं मलयज सुरभिलमारुदनीर्कुं मलयाळं भामामकराज्यं जय 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 जननी जननी मामक केरल धरणी जय 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 जननी जननी मामक केरल धरणी.
Now, we would like to invite Sri Loknath Behra. I would like to invite Professor Dr. Samson Matthew, Director, KCST-NATPAC, to welcome the gathering.
Good morning, everyone. In fact, we are waiting for the MLA to inaugurate this function. She informed that listener she'll join in 10 to 20 minutes time. It gives me great pleasure to welcome all of you to this two-day workshop on full depth reclamation. This workshop has been organized with the aim of providing you with a platform to learn the latest trends and exchange ideas and practices in full depth reclamation by National Transportation Planning and Research Center with the support of Kerala Infrastructure Investment Fund Board, KIIFB. As we all know, in recent years, there has been an increasing focus on sustainable and innovative practices in road construction to meet the challenges of growing population, increasing urbanization, and changing climate patterns. One of the key challenges in road construction is to reduce the environment impact of construction and operation. This involves using new materials, technologies that are environment friendly and energy efficient, such as recycled materials, bio-based products, and renewable energy sources. As you may be aware, full depth reclamation is a cost-effective and sustainable method of road rehabilitation that involves recycling existing materials to create a new base for the road. This technique has gained significant popularity in recent years due to its many benefits, such as improved durability, reduced construction time, maintenance cost, even including the construction cost also, increased payment life, reduced layer thickness, and reduced environment impact. KIIFB has entrusted NATPAC to prepare and provide project development of 9 roads, prepare 9 roads, which is project execution document preparation for the development of these roads with the technology of FDR. A pilot project has already carried out by KIIFB at Anadi Palkalam stretch very near to Adur for about 5.9 kilometers in the year 2018, and even recent my visit to that particular road also found that one it is sustainable, durable, and it is in good condition. So it proved that the technology is cost effective, and we can use that one as an environmental friendly construction technology in Kerala. But at the same time, constraint in implementation of FDR technology include non-availability of approved schedule of rate. Maybe that may be the the issue which the engineers normally will put forward. SIR is not available, but with the initial discussions taken up by KIIFB with the PWD, KHRI, in which Professor Veeravans are also involved in that one. I was also a member in that one. PWD has introduced that one in the price about the schedule of rates is available now. There is no past recorded experience of failure, success, or the poor performance of these stabilized roads. Probably, other states, they have already started this technology. It is time for Kerala also to do that one, especially when we have the issue of availability of virgin material. Now, we have issue already with the gravel, we have issue with the aggregates, quarry, all those issues are there. And in that case, probably there can be this, another issue in fact, Gurutal was mentioning about the availability of equipment or low-cost equipments in India, lack of experience in FDR works by the contractor. These are all issues. Probably this is one forum which we thought like we can meet together and discuss. We have expertise from academic institutions, research institutions like the CRRI. We have experts from the industry. You would have seen good number of technology providers are here. And we have the practicing engineers are also here. So during these 2 days, we have lined up an exciting program for the engineers and the contractors and the consultants. We have invited a panel of experts from the industry, academic and research institutions, implementing agencies who will be sharing their knowledge, expertise, and lessons learned on a range of topics related to FDR. We have also have in technical and interactive sessions planned where you can engage in discussions as well as you can learn from the people those are already implemented these things. Let me enter into my the duty. Trikagara MLA Madam Uma Thomas Madam സമയത്തും ഇവിടെ പ്രതീക്ഷിക്കുന്നു വരാവുന്ന ഞങ്ങളുടെ ഇൻവിറ്റേഷൻ സ്വീകരിച്ചു ഇവിടെ വരാവുന്ന ഏറ്റിട്ടുണ്ട് വരുമെന്ന് പ്രതീക്ഷിക്കുന്നു ഉടനെ എത്തുന്നതായിരിക്കും മാഡത്തിനെ ഈ പ്രോഗ്രാമിലേക്ക് സ്വാഗതം ക്ഷണിക്കുന്നു. We expect that Greater Cochin Development Authority Chairman Sri Chandramilla sir, till yesterday evening at 9:30 he wanted to come, and even before that also he contacted me. He said he'll be here. Yesterday was the first day after a long medical treatment. He was attended the office yesterday, but after 9:30 he said direct doctors advised him not to move for next 2 days, so he's not here. But again I welcome, because he is with us almost for all activities of NATPAC, especially in Ernakulam region office. Our MD Cochin Metro Rail Limited, Logda Sir, again he is a well-wisher of NATPAC always, and he is motivating our activities. We in NATPAC also is very actively as well as involved in the Cochin Metro activities and all. I welcome you, sir, to this function and your supporters. We have the participants from different road owning agencies. We have engineers from Public Service Department, Roads, National Highway, Kerala Road Fund Board, KIIFB, Rebuild Kerala Initiative, Project Implementation Unit of PMGSY, Kerala State Rural Road Department, Local Self-Government Department, LAD and EW, Kerala Highway Research Institute, then KIIFB, even though they are sponsoring, at the same time they are also here. We have RIC, Road Infrastructure Company Limited, Kerala representatives are here. NHA representatives are here. Rights representatives are here. Consultants and contractors of the road construction agencies are here. Municipality representatives, corporation, smart city, GCDA, and industries are with us. In addition to that one, we have representatives from academic institutes as well as some students, those who are doing the work the work related to the FDR or other material related things are also here. I welcome all of you to this program as well as to this function. We have our resource persons, especially Professor Veera Raghavan, who is a retired professor from IIT Madras. Even though he is retired, but he is not retired in his technical activities, and I found that when he is much more busy than what he was there at IIT Madras. Very difficult to get his date. Of course, in fact, this date was, initially we wanted to have it on 26th and 27th of April, and because in order to get his date only, it was pushed to today, for May 4th and 5th. In fact, 5th and 6th, we again, to accommodate his dates, it is 4th and 5th. Welcome you, Professor, to this function, and he is very much enthusiastic to have this FDR technology, not only in Kerala, all over India, and recently he visited Uttar Pradesh also to learn the failures or the success and other lessons, the the details from the implemented roads from UP. We are expecting Dr. Shyam Nair tomorrow from IIT Kanpur. We have Anjan Kumar also expecting tomorrow from IIT Guwahati. Today we have already Guru Vittal, the retired chief scientist from CRRI is already here. He has already handled one topic in the morning. Tomorrow again he will be continuing. We have Dr. Brijesh Dubey. Here, okay. He is from Uttar Pradesh Rural Road Development Authority. Implemented almost 3,500 kilometers of our plan. Now, the stretches are already implemented. He is also with us to share his experience. We expect that Sandeep KG, CE, and SGD may join today or tomorrow. We have Karan Madappa, Vishwasamudra will be sharing their experience in Kerala. Engineer Srikumar B, KIIFB is also here. And as well as KIIFB and NATPAC lesson, the expert also will be sharing their experience in the FDR. In addition to that one, we invited the other expert from the nearby states again. I have my colleague Dr. V. Sunitha from NIT Trichy, happen to be the State Technical Agency of PMJC Roads in Tamil Nadu and Puducherry. We have Dr. Suresha from NIT Surathkal. He is again State Technical Agency of Karnataka. There again they have already implemented. Dr. Ashalada is with me, and Tushar is also attending today's the program. Tomorrow, Dr. Kunjarapi Isaac, who happened to be a senior most transportation expert again in payment in Kerala and founder vice chancellor of Kerala Technical University, is also will be joining tomorrow. Dr. Anjanelu will be joining tomorrow and all. Anjanelu again ST of Kerala ST of Kerala. So I welcome all of you to this function. This is a good forum in which the expertise from the industry, academia, and the practice engineers are here. We will discuss and we can have a way forward for tomorrow's the future Kerala. We are invited at the press and media here. They are here. I welcome the press and media, and always this is the first program after we started our regional office at Ernakulam. We have one office now at Ernakulam to have more interaction with the activities, especially with the KMRL, KMDA, then GCDA, then we have activities with the smart city, then Cochin Corporation, like that. Listen, we have a regional center here. Press and media should give support to NATPAC regional office and our activities. I would like to take this opportunity to thank our sponsors, without whom this workshop would not have been possible. Their support has been instrumental in bringing together such a diverse and knowledgeable group of participants. We have the platinum sponsors, AVS Infra, as well as LRS Infracon. Diamond sponsors, Vishwasamudra. Global gold sponsors, SEDEX as well as Habok. Silver sponsors, VV Autotest Systems Private Limited, Matter Lab, and DeepBrains. All these agencies, they have put up their stall here. They'll be sharing their experience also through maybe 10 to 20 minutes interaction with you. I welcome the representatives of these sponsors to this function. We have Murali from KIIFB, representing KIIFB. In fact, Vijaydas sir is attending this program online. He is supposed to be here. I welcome Vijaydas as well as Murali to this program as well as to this function. Once again, I welcome all of you to this function and wish you a fruitful section for the next 2 days. Thank you.
Thank you, sir. Now, we would like to invite Sri Loknath Behra, Managing Director, KMRL, to deliver the presidential address.
At the outset, I must apologize for one thing, that I am not an expert like you. So I don't know much about the roads and road technology, like all of you know. But I am a great user of the roads, and I will be using it till the time I actually leave this planet. But so honorable people on the dais and of the dais, my friends, I must say that though, I understand from Dr. Sampson that a large number of people are from outside Kerala who are attending. And for them, I wanted to say one thing. Kochi is one of the most beautiful places in this planet. It is a very unique city because 27% of its area is water. And this particular city has all type of water. We have canals, we have rivers, we have backwaters, we have sea and whatnot. And it is extremely beautiful. If you see aerial view or go in the boat, it's very good. And it has a very cultural legacy of thousands of years. And we have here from Portuguese to British to everybody has come here. And they have, left many of the things behind. So you should enjoy that. And second thing, being the managing director of the metro company, we have recently introduced the water metro. Whoever can get a chance, you can travel. And I can assure you that it is one of the most enjoyable experiences you can ever have, because there is no water metro anywhere in the world. And you can see here how it operates. It is a technology marvel. And I was telling Dr. Sampson, I wish I could have taken all of you together, but it is not possible, because of the now, like a Rajnikant movie being actually released on the first day, there will be serpentine queues. So like that, we have a lot of people now standing in queues for hours to get a ticket to get into the metro. But you can always try, and we'll try to facilitate that. The other part which I wanted to say is that I was wondering that why you actually people are actually assembled here to talk about the roads and some kind of technology. See, if you are talking what Dr. Sampson said, this is a very actually, you have to take it back home and think. You go to actually Chowrangi in Calcutta, or go to the very near to Lal Killa in Delhi. The roads have been laid 300 years back. Nothing has happened. Cobblestone roads I have seen all over the world. You go to Lyons, you go to Paris, you go to London. Nothing happens. It has been laid. It will last for 700, 800,000 years. What's the point in discussing about the technology which will be environment friendly? There are so many things are there. Think about it, because in one of the seminars I attended some time back in London, there was actually a point whether the roads will be required in future. Whether roads will be required. If you see a video which has been become viral, saying that future of transport, nothing is on the road. Either it is in the water or in the sky. So probably this particular discussion on FDR is a stopgap thing. This is my view. Well, to evolve forward, the technology has to be brought in to find out what are the flip sides. The flip sides only give rise to better evolutions in the future. That is how the technology grows. I studied technology all throughout my life. So I worked 36 years in the police. But Technology was very close to my heart and it is still. I always think that what is coming next? So, as you know, if you ask which is the word which has been most searched in Google, you know which is the word? The word is innovation. It is the highest search has been done on that particular word. Now, if you ask what is innovation, I'll give you a small example which Steve Jobs said some time back. He said that I don't ask the customer, what do you want? I don't want to ask him. I say, I will give him what he will want. That means I produce and show it to him, and he will want that. That is innovation. And without innovation, we are nothing. You will be having seminars like this. Go back and relax. If you innovate, then only you will exist. Otherwise, you'll go. In the road technology, that's the same thing. FDR, I'm grateful to my colleague, who was my younger colleague in the police, but he left. He is the CEO of the Vishwasamudra Group, Anil. Yesterday, in fact, I was talking to him. He was talking about this FDR technology. He told me some 1 year back. So when I learned about this technology, I said all my non-motorized transport programs of the Cochin Metro, wherever there is a road to be built, it will be built on FDR. Because it's very good. I really liked it. Because the best thing which attracted me is that the number of vehicles which will be transporting the things will be very reduced. That is a very important thing because they create roadblocks, they cause a lot of carbon emission, there are a lot of problems related to labor, this, that, all kind of things will be there. You do it there, finish it, and the local materials, you do that, and the base is made. And I was told, if the base is good by using this technology, that will last at least for 15 years, if not 25. And best thing I was also told, after the lifespan, that thing also can be recycled again. So that is a good thing. So I thought that is a very good technology. So I get some funds from abroad relating to the NMT programs in the city. I said that let us actually use this technology. So we are making the phase 2 of the metro, which will be connecting this place to the city. We will be using some of these particular things, if not in, like my friend from UP saying that this is that. UP is a different actually ball game because I spent so many years actually doing many of the matters, including Ajodhya demolition case from the CBI. I was that time there, so I traveled quite a bit. I was almost staying in Faizabad. So UP is different because Indo-Gangetic plain, the soil conditions are a little different than what is there in Kerala. Kerala has a peculiar thing because it has so much of rains and the water table is very high. There are laterites in this area. Immediately after this, you go to Ernakulam, the topography immediately changes. I mean, the subsoil and other things are a little different. All these things require a kind of approach that will be not a unified approach can bring the solutions. But I was told the moment you make the base very good, the roads, I have the first experience of a good road, not in India, I'm not talking in abroad. When I was posted to Kolkata in the CBI, there was a road near Maidan, who have been actually accustomed to Kolkata, just in front of the Eastern Command of the army. There is a road. That road, when you go, normally everybody criticizes the road of Calcutta because they are not maintained, this, that, it used to be. But that road, when you actually put your car, it becomes almost soundless. It is just like a tarmac. It is so beautiful. Then I asked the general once I met him, I said, sir, how this road is maintained? This is maintained again by the army. He said, look, this road is been built in a way so that we can land the planes in case of emergency. But today, I'm talking about this is in 1997. But today, when I travel in UP or in Odisha, in some places, the roads are so good that it's like a tarmac. When I used to travel from Bhubaneswar to Puri, Puri is my native place, I used to take 1.5 hours. This is actually 62 kilometers. Today, I am doing in 40 minutes. The road is like a tarmac. And that is credit goes to the engineering fraternity who have come out with this. And lo and behold, I don't know what technology they have used. For last 5 years, no potholes there. And they receive quite a heavy rainfall. This road is good. So whether it is FDR or some other road, I don't know. But what I say as a user, I would like to have a very good road till the time the roads vanishes. If at all the future of technology says that there will be no road. So look, that up to that time, we should have good roads. I'll give a very small example what happened. In 1993, I was the police commissioner here in Cochin. That time, there is a very famous junction here, very near to the to the MG Road. It is called the Madhav Pharmacy Junction. Those people who are from Cochin, they know that. It is a T junction. And every time there used to be, after the rains, there will be a lot of potholes and the traffic will be very jammed. So one day, after coming from Bombay I went to Bombay for something, I found that those roads they are making in concrete roads. So the Honorable Chief Minister, I told him, I was very young, without realizing what is what. I told him, sir, why not we actually make these roads concrete? And I was told these concrete roads will last for 100 years. If it is made, he said, it's good. That time, the Cochin refinery MD was also present, Mr. Kumar. He said that if the government permits, I will make that 1 kilometer stretch of the road concrete. The government will not pay anybody. I will do it. He said, very good, CM said. Then he told me, look, you talk to the PWD minister. So I talked to the PWD minister. He said, oh, yes, this is good. But 1 year, 2 years passed, nothing happened. And it never happened. I don't know why it did not happen because this is not my domain of work. So I want to say that when we discuss matters in this type of seminar or workshop, what is the takeaway? The takeaway actually makes you to bring something good, like a good pizza home. But whether you will eat the pizza, enjoy it, or keep it in the fridge, it is up to you. Likewise, when you discuss these matters, because young engineers are here, whether they will carry and implement it. You know what happens in a organization like mine? The senior people will say, hey, why are you bothered about this such thing? We don't have such precedences like that. We'll go by precedent. We'll do like this. And the younger chap gets disheartened. He said, no, we'll go by the precedents. If you want to actually progress, think in a different way. That's what I wanted to say, because I cannot talk much about the FDR technology, because I was told that this technology is good and cheaper, that the roads are built very quickly and a lot of environmental positives. That's very good. You kindly actually do it, and we are actually doing 3 roads in Kerala right now, 3 or 4 roads. Mr. Sabudra is doing 2 roads. I know that very well. And let it actually be like that. But whether there is anything beyond FDR. Can we think in that particular form? When Sweden implemented the self-charging roads, people were surprised that how actually a road can be actually charge your vehicle when the vehicle, there is nothing to be plugged in. But it is a fact, it is now, it is there in Germany, it is there in Sweden. So it will come. When our electric vehicle population will go up, it will definitely have to be there, this charging. So Dr. Veera Raghavan will be able to tell what he is planning in that particular regard. I am not the person to correct person. When I was always thinking that when the metro trains actually get charged from the side, even the vehicles which are all going on the top of the road, it can get charged. So it is possible. So whether FDR technology will be a boon for that, matter is left to the house. Anyway, I am saying one thing is that if you, one more thing I do not know is if I actually food for thought. You travel in Kerala, you will hate the roads in the cities because sometimes it is clogged, sometimes it has potholes, it's not that, the surface is not good. But travel in the rural areas of Kerala. The roads, I assure it is better than France. How did they make it? Recently, I stay very near to this place. When I actually, my road, the road connecting from the main road to my house, the built by the municipality here, is like a tarmac. But they made it with pavers. They did not put any bituminous thing. Whether that is good or not, I don't know. But I like really, if you say, my always actually thought goes to the cobblestone roads of Kolkata or Lyons or France. And this have stood the time. You can travel with a Mercedes or with a Alto on that, no problem. Of course, you cannot go at the speed of 100 or something, but you can go. Think about it, which are the things to be done. And I wish NATPAC is very close to me. While I was in the police, they did a lot of work for me. Every time they used to caution me that this will be the black spot, you have to do this. Very, very renowned scientists, very dedicated. And KIIFB is a legal entity and they are mandated to develop the infrastructure and they are doing it. Both of them coming as a Jugalbandi and doing it is a good. And with the eminent persons like Dr. Veera Raghavan and others, I'm sure that this particular workshop will be very, very successful. But again, I am telling you the thing that when you go back, just don't think that I visited Kochi. Kochi is a beautiful place and we had good food in the seminar and that's all. Take whatever is that and use it. Lastly, I'll end it with a small story. I always give this story to the IAS professionals, to everybody. How do we live today? I take this particular story from a real life incident which has been filmed. If you have seen a film called Steve Jobs, that is the last scene. Steve Jobs, actually, as you know, was thrown out from the Apple Inc., which he established. At the age of 20, he and his colleague actually built the Macintosh. And at the age of 30, he became a billionaire because of a Macintosh. But he was thrown out by the board. So he left. He went into a depression for 3 months or 4 months. Then he came back. And he actually had the company Nest. And also he developed Pixar, which you are now seeing all the movies. But at one point of time, Apple bought Pixar. So Steve Jobs came back to the company. When he comes back to the company, as a nostalgia, he goes from one room to the other. And he enters a room where a young boy, he was doing something on the table. And the boy gets up and says, "Hi, Steve, you're back?" He said, "Yes, I'm back. What are you doing?" He said, "I'm developing something on music." "Oh, do. God bless you." When he was leaving, the boy asked Steve, "Steve, tell me where I should keep the speakers." Without a wink of his eye, he said, "Keep it inside." And you got the iPod. That is innovation. Thank you.
Thank you, sir. Now, we would like to invite Professor Dr. A. Veeraraghavan, retired professor, IIT Madras, to deliver the special address.
Mr. Loknath Bera, MD, Kochi Metro. Ms. Uma Thomas, who is not here, perhaps she may join soon. Professor Samson Matthew, Mr. Murali, Mr. Burjesh Dupe from UPRRDA, technology providers, student friends, faculty colleagues, and other engineers of the government and other agencies. It's always a pleasure to participate in such events, mainly to learn from you what is new. I think Mr. Behra made a mention about the cobblestones of Rome and Tally and all. Perhaps if we have been walking all to the place, going by bullock cart, hand cart, cycle rickshaws, perhaps that may be adequate. But we are in a different position today where time is money. We want to travel the quickest possible time. We are constructing highways wherein we can travel at 150 kilometers per hour. We are restricted to 120 kilometers per hour. We have high technology cars, which can travel at 200 kilometers or more. With those vehicles to travel fast, we need roads. We cannot avoid having roads. Number one. Number two, constructing road costs money. I think perhaps you know the allotment or fund allocation in the budget for this year is more than 1,50,000 crores. I think government thinks about the importance of roads, and that's why 150 lakh crores is being allocated for the road sector. So now this money has to be utilized. I think perhaps she can talk, I can continue. Huh? Okay. Perhaps we need a good quality roads. Coming to the issue of the construction of the roads, I think unlike other workshops wherein some experts will come, experts will talk, we hear and go back and do the routine. I think this workshop is something different. I think as everyone is aware, India has got the second largest road network in the world with a length of nearly 63 lakh kilometers. Majority of them, nearly 80% of them are low volume roads or other roads. It's not only the construction of the road that matters, the maintenance, rehabilitation of the road also matters. As I was mentioning, when you spend about 150 lakh crores of money on road construction, how will these roads behave? I think we are at the crossroads today, especially in a state like Kerala, where materials are not available, roads are to be maintained, new roads are to be constructed. I think we are at the crossroads here. The roads are generally designed for a life of 15 years or 20 years. So what does it mean? I design the pavement such that it becomes motorable in a good, offer a good, comfortable riding quality for a period of at least 15 to 20 years. Then what? With the next question. What conventionally we have been doing all these years is that put an overlay. So Mr. Behra was mentioning about the good roads, bad roads of urban areas. So there again, I find that there are a lot of limitations in the specification that is being followed. Perhaps even Kerala is also needs to upgrade its specifications. I found that many of the states, few states are in particular, are following the ministry specification even for the state roads. Simple. Perhaps Kerala can also simply follow the ministry specification for all the roads. Unfortunately, we have a specification for urban roads, but again, that needs modification. So, but whatever you say as the design of a 15 years or 20 years or 30 years for a concrete road, the roads will eventually will deteriorate. So when the payment deteriorates, what is to be done? Provide an overlay. There are specifications of IRC 81 for Begelman beam, 115 for the falling wave deflectometer for flexible payment, 120. So we have specifications wherein we can do the evaluation and provide an overlay. Is that sustainable? Is the question. The answer is no. We cannot keep on raising the level. There's another reason for the flooding of the urban areas in particular. But what we have been missing all this year is that we have not scientifically investigated why the payment had failed. What we do is that we routinely do an evaluation, find the deflection is more, riding quality is poor, provide a BC40, provide BC50, or provide a BM and a premix carpet. That is what we have been routinely doing without investigation what went wrong. Supposing if there's a problem with the base layer, problem with the subbase, what is to be done? So what I found is that unless you investigate the causes for the deterioration, and if the problem is due to inadequate compaction of the subgrade, subsurface drainage issues, or problem with the base course, even if you put a steel plate, it will not work. So there is a need for scientific investigation for the causes of deterioration and coming out with a solution, number one. Number two, if there's a problem with the base course, whatever you provide will not work. So we don't have material. The problem in particular in Kerala is that we don't have aggregates. We don't have soil quarries. In such cases, how do you rehabilitate this road? How to reconstruct the road? Here comes a solution like a full depth reclamation is one of the technologies, is not the only technology, is one of the technologies that can be adopted to rehabilitate the roads. So by raising the level of the finished road level, we are attributing to the flooding of the adjoining areas. We consume huge quantity of virgin material. Bituminous layers are costly. We have to reduce, recycle, and reuse the material. That is where full depth reclamation comes as a handy tool. So why can't we excavate the pavement up to the layer that has been deteriorated, recycle and lay it back? Yes, we can do that. FDR is one of the technologies. Okay. How should we do this FDR technology? What are the solutions? If we can want to recycle the material, reuse it again, and want to have a better base course, perhaps we have to improve its properties. Suppose in case of PMGSY rural roads, it may have 2 layers of premix carpet or 1 layer of premix carpet. It has developed a lot of cracks, potholes, undulations, maybe due to inadequate subgrade compaction, maybe poor waterborne macadam layers, grade 1 of 10 centimeter, which we were using. What is to be done with that material? Can I provide a BM overlay or a DBM overlay or a BC overlay? These are the issues. No, whatever you provide will not work. In such cases, we have to reuse the material in the construction. Fortunately, we have got many technology providers who are present here. The full depth reclamation is not a new technology. Perhaps it's new in India, but not in the world. Full depth reclamation with cement has been time tested, proved it can be adopted, which will result in reduced thickness of the pavements, reuse of the material, reduced bituminous layer construction, layer thicknesses, and hence more sustainable. But here comes the issue. There are issues and questions which I will pose it tomorrow also. Perhaps we will also learn in the process. What is the dosage of cement? What is the strength that you need? Will the layer crack? How long will it last? What is the life cycle cost? There are many, many questions which are unanswered. There are many technology providers. Should I use only cement? No. There are other technologies available here. So we have assembled here mainly to understand what will work, what is working, what will not work. What the strength that is required, what the gradation to be adopted, what is the life cycle cost, how to predict the performance. Many, many questions are unanswered. Nobody knows in this hall the answer to these questions, even including me. I do not know the answers. So I have come here mainly, even after retirement, I want to learn. And that's why I'm here before you to learn the process, how the technology works, how it will work, what will be the life cycle cost. So we can also, in this case, we can adopt a coal recycling process. We are ensuring a sustainable, long-lasting payment layer, which is expected to perform well. At the same time, we should also know where it will work and where it will not work. It is not a panacea for all types of distresses in the payment. It's like taking a paracetamol for all types of fever. It will not work. Some cases it will work, some cases it may not work. So as an engineer, all of you from the user agency should know FDR will work only for a particular cases of distresses, traffic levels, subgrade support conditions, and the subsurface drainage. If your subgrade is weak, or if the problem with the subsurface drainage, whatever you try to provide will not work. You should know that the limitations of the full depth reclamation as well. So more advantageously is that we can provide a thin bitumen surfacing and thereby we can reduce the cost of construction. So mainly anybody, all the speakers, whoever is going to speak for the next 2 days, will talk about only 4 steps. Spread the cement, spread the stabilizer, mill the material, pulverize it, compact, provide a bituminous layer over. This is what everybody will talk. But what we have to learn is that what is the mechanism it does? How does the strength gain takes place? How long will it take for the layer to obtain the required strength? How will it likely to perform? How do you do the sampling process? How do you do the mix design? There are many unanswered questions here. Simple is that there are different specifications for the full depth reclamation. Some adopt the PMGSY specification. I think Mr. Guruvittal prepared that based on the PCA. There's another which people consider it as a cement treated base. It's not a cement treated base. So what should be the gradation? What should be the strength? What's the dosage of cement? Everything costs money. There are technology providers who say that we have got UCS value of 15, 20. We don't need that. So finally, it comes to the cost economics. More importantly, when you have a higher strength, will the layer crack? Yes, answer is yes. The layer will crack. If it cracks, you should know as an engineer, you should know the layer is likely to crack. If it cracks, what should be the precaution that we should take? How to prevent the crack occurring on the surface and eventually coming up to the top. Once the pavement cracks, water will enter. As everybody says, enemy number 1 to pavement is water. Enemy number 2 is water. Enemy number 3 is water. No pavement will last if there is a stagnant water or the water enters into the pavement layer. Once it cracks, water will enter. So how do you prevent this occurrence of a crack? I think my academic friends should be able to model this, predict the performance, and come out with the cost-effective treatments. Again, when you talk about the crack relieving layer or crack retarding layer, I will call it the crack retarding layer, which will delay the occurrence of cracks. I can provide a SAMI layer. I can provide an aggregate layer. I can provide a crack prevention layer or crack retarding layer. Which will work? Which will not work is something that needs to be studied. The conventional theory of layer theory will not work. It's an inverted payment. So analysis of this has to be different. I think my research friends who are doing research should be able to answer this question, which will work and which will not work. Incidentally, a question also arises. You are adding a cement. You are adding a stabilizer. What is the function of the cement? What is the function of stabilizer? Can this FDR be done with cement alone? Question to be answered. I don't have an answer, but I think you should be able to tell. When you add cement and stabilizer, what the cement does, perhaps it improves the strength. Then what does the stabilizer do? How does it prevent the cracking? Will it prevent a crack? Will it improve the durability? In many cases, many cases, the required durability can be achieved with cement alone. So some are in powdered form, some are in liquid form, some are in white color, some are in brown color. In fact, I visited, thanks to Mr. Dubey, he took me to UP. We visited several sites. So it plays a magic, but this magic has to be understood. Scientifically, it has to be proved. So unlike the other conferences, this conference will enable us to learn. It's a win-win situation. We also learn and you also learn in the process. Perhaps I wish that this session of this 2-day workshop, which is organized by KIIFB and NATPAC, will enable us to discuss thoroughly, learn in the process, adopt FDR in a large scale in Kerala, where materials not available, we have to reduce, recycle, and reuse the material. Finally, FDR is one which has got several advantages over the conventional methods of rehabilitation. It minimizes the transportation costs of large quantity of virgin aggregates. So it also minimizes or eliminates the material that is being milled and thrown out. We can reuse the material. It's a black gold. We cannot, bituminous layers are black gold. We cannot avoid this. It will improve the riding quality. So in many cases, even if you want to convert or widen a road from single lane to intermediate lane or a 2-lane, perhaps we can reuse the material. But again, when we mix the material of different gradation, we need to do a mixed design. Many times the mixed design done in the laboratory based on the sample supplied by the contractor is not the sample at the site. This is a missing gap here. That again will, I think, the next following this, my talk, Mr. Dr. Vishnu will also talk about sampling, and it's important. So many things we have to learn, starting from sampling, gradation, mixed design, construction, quality control, performance prediction, and life cycle cost. So eventually, even though FDR is not new in the world, it's new to India, we have been doing some case of CTSB, cement treated sub-base and cement treated base. But FDR is a different animal. Its performance has to be predicted. Mixed design has to be learnt. So one size fit all design will not work. Again, I will talk about this tomorrow also. There are many questions unanswered in the overall process. So FDR is, even though it's not some innovation, road construction is not innovation, it's not a rocket science. But again, if you do not give importance to the sampling, mixed design, construction, quality control, the amount that we'll be spending in terms of vehicle operating costs will be several thousands, several lakh crores. Unfortunately, we are not talking about the riding quality at all anywhere. And finally, to answer to Mr. Bera, whether you fly, go by rail, go by water, finally, you can reach your home only by a road. Without a road, you cannot fly, you cannot have airports at Kollam, Alapi, Palakkad, Thrissur, everywhere you cannot have airports. You can have metros also. Even in Cochin Metro, it runs in one line, but you have to reach your home, you need a road. But again, the same cobblestone will not work. We have to travel, we need comfort. We have reached a different sophisticated level today. We cannot walk. We don't walk even 100 meters. So with that result, with the growing, even gravel roads are not accepted in PMGSY. We tried a lot. Even surface dressing is not accepted. People want good riding quality. If that is required, if you want a good riding quality, you need a good base course. You need a good sub base. You need a good subgrade. Without different layers constructed well, we will not be able to have a good riding quality and the comfort. Finally, comfort is what matters. You ask anybody, what do you want in a road? They say, I want comfort. That's all one answer they will tell. They are not worried about whether it's FDR or waterborne macadam or wet-mix macadam. They want comfortable road, good riding quality. If you want to have that riding quality, what should be the component layers of the payment? Again, I have the problem of non-availability of material. How should I construct this? So definitely we are in a crossroads. FDR is going to be FDR along with conventional recycling. Can be hot in-place recycling or a cold in-place recycling. Hot central plant recycling or a cold central plant recycling has to be adopted, especially in a state like Kerala, where materials are not available. So again, perhaps Dr. Sampson and Mr. Murali will organize another workshop on recycling, especially of the bituminous layers. I think this is something that again we have to master, we have to develop. I'm sure that by this process, if you try to reduce, recycle, and reuse the material consumption, perhaps when we leave this world, we will leave this world in a better place for the younger generations to live comfortably, safely, and sustainable. I think that is what we are looking forward. So we will try to share our best possible experiences in constructing sustainable, long-lasting, durable road assets, wherein we will be able to ensure traveling a comfort, and traveling on the roads will be a pleasure in the years to come. I'm sure that we will discuss the next 2 years and learn in the process. Thank you very much for the opportunity.
Thank you, sir. Now we would like to invite Professor Dr. Samson Matthew, Director NATPAC, to welcome Srimati Uma Thomas, our Honorable MLA of Trikakara.
ശ്രീമതി ഉമാ തോമസ് തൃക്കാക്കരയുടെ വളരെ പോപ്പുലർ ആയിട്ടുള്ള ഒരു MLA. മാഡം ഞങ്ങളുടെ ക്ഷണം സ്വീകരിച്ചു. 11 മണിക്ക് വരാൻ നേറ്റിരുന്നു. അല്പം താമസിച്ചു മറ്റ് പരിപാടികൾ ഉണ്ടായിരുന്നതിനാൽ. എന്നിരുന്നാലും ഒരു കംപ്ലൈൻറ്റ് എന്നോട് പറഞ്ഞു, നാറ്റ്പാക്ക് തൃക്കാക്കര മണ്ഡലത്തിൽ ഒന്നും ചെയ്യുന്നില്ല എന്ന്. ഞാൻ പറഞ്ഞു, ഞങ്ങളുടെ ഓഫീസ് തന്നെ തൃക്കാക്കര മണ്ഡലത്തിൽ ഞങ്ങളങ്ങ് സ്ഥാപിക്കുകയാണ്. അപ്പം വേണ്ട സഹായം എപ്പോഴും ഉണ്ടായിരിക്കും. നാറ്റ്പാക്കിൻ്റെയും KIIFBയുടെയും പേരിൽ ബഹുമാനപ്പെട്ട തൃക്കാക്കര MLA ഉമാ തോമസിനെ ഈ പ്രോഗ്രാമിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. മാഡം.
I would like to invite all the dignitaries on the dais to come forward and light the lamp to mark the official inauguration.
Thank you all. Now I request Srimati Uma Thomas, Honorable MLA Trikakara, to deliver the inaugural address.
എല്ലാവർക്കും നമസ്കാരം. ഇന്നിവിടെ 2 ദിവസത്തെ വർക്ക്ഷോപ്പിന് വേണ്ടിയിട്ട് എത്തിയിരിക്കുന്ന KIIFBയുടെയും നാറ്റ്പാക്കിൻ്റെയും കൂടിയുള്ള ഫുൾ ഡെപ്ത് റിക്ലമേഷൻ ടെക്നോളജിയുടെ അധ്യക്ഷൻ ഡയറക്ടർ കൂടിയായ KMRLന്റെ പ്രിയപ്പെട്ട മാനേജിംഗ് ഡയറക്ടർ ശ്രീ ലോക്നാഥ് ബെഹ്റ, ഡയറക്ടർ പ്രൊഫസർ സാംസൺ മാത്യു, ഇവിടെ നിങ്ങൾക്കായിട്ട് ക്ലാസ് എടുക്കുവാനായിട്ട് എത്തിയിരിക്കുന്ന പ്രിയപ്പെട്ട പ്രൊഫസർ ശ്രീ A. വീരരാഘവൻ, KIIFBയുടെ പ്രിൻസിപ്പൽ കൺസൾട്ടന്റ് ശ്രീ മുരളി, മറ്റ് ഇവിടെ സന്നിഹിതരായിരിക്കുന്ന വിവിധ ഉദ്യോഗസ്ഥ പ്രമുഖരെ, പ്രിയപ്പെട്ടവരെ, സഹോദരി സഹോദരന്മാരെ, വളരെയധികം സന്തോഷമുണ്ട്. പരിസ്ഥിതിയെ തകർക്കാതെ പാരിസ്ഥിതിക്ക് അനുകൂലമായിട്ടുള്ള ഒരു ശ്രമത്തോടുകൂടി നമ്മൾ പുതിയ രീതിയിലുള്ള നൂതനമായ ഒരു ടെക്നോളജി ഉപയോഗിച്ച വസ്തുക്കൾ തന്നെ റീസൈക്കിൾ ചെയ്തുകൊണ്ട് ഉപയോഗിച്ചുകൊണ്ട് വീണ്ടും നമ്മളുടെ റോഡുകളെല്ലാം നല്ല രീതിയിൽ പൂർവ്വസ്ഥിതിയിൽ വളരെ കുറച്ച് മാത്രം പുതിയ മെറ്റീരിയൽസ് ഉപയോഗിച്ചുകൊണ്ട് പ്രവർത്തിക്കുന്ന ഒരു പുതിയ ടെക്നോളജിയെക്കുറിച്ചുള്ള ഒരു കൂടുതൽ വ്യത്യസ്തമായ രീതിയിലേക്ക് നമ്മൾ നീങ്ങുകയാണ്. അതിൻ്റെ ഒരു കൂടുതൽ നിങ്ങളെ മനസ്സിലാക്കുവാനായിട്ടുള്ള 2 ദിവസത്തെ വർക്ക്ഷോപ്പാണ് ഇവിടെ നടക്കുന്നത് എന്നറിയാൻ കഴിഞ്ഞതിൽ വളരെയധികം സന്തോഷമുണ്ട്. നമ്മളുടെ ഇപ്പോൾ ഇവിടെ നാടുകൾ നോക്കുകയാണെങ്കിൽ റോഡുകളെല്ലാം താറുമാറായി കിടക്കുകയാണ്. അതിനെല്ലാം അതും പലപ്പോഴും നമ്മൾക്ക് ഫണ്ടില്ല എന്നുള്ള കാരണം കൊണ്ടാണ് പല കാര്യങ്ങളും ചെയ്യാൻ സാധിക്കാതെ നീങ്ങുന്നത്. പിന്നെ പലപ്പോഴും PWD സംബന്ധിച്ചാൽ NHന്റെ ആയിരിക്കും, NHന്റെ സംബന്ധിച്ചാൽ മറ്റൊരു കോർപ്പറേഷൻ്റെ ആയിരിക്കും. ഇങ്ങനെ റോഡുകളിൽ തർക്കവും കാര്യവുമെല്ലാം എല്ലാ രീതിയിലും ഇപ്പം നിലവിലുള്ള റോഡുകൾക്കെല്ലാം ഉപയോഗിച്ച മെറ്റീരിയലിനെ ഉപയോഗിക്കുക എന്ന് പറയുമ്പോൾ തന്നെ ഫണ്ടിൻ്റെ കാര്യത്തിൽ വളരെയധികം നമുക്ക് പരിമിതി ഉണ്ടാക്കാൻ സാധിക്കും. കുറച്ച് ഫണ്ട് ഉപയോഗിച്ച് കൂടുതൽ പ്രവർത്തന മേഖലയിലേക്ക് നീങ്ങുന്ന ഈ ആധുനിക ടെക്നോളജിയിലേക്ക് എന്നെ ക്ഷണിച്ചതിന് ഇതിൻ്റെ സംഘാടകർക്ക് പ്രത്യേകം നന്ദി പറയുകയാണ്. നിങ്ങളെല്ലാവരും ഈ വർക്ക്ഷോപ്പിന് ശേഷം പ്രബുദ്ധരാവണം. നമ്മളുടെ നാടിൽ എല്ലായിടത്തും തന്നെ, എൻ്റെ മണ്ഡലത്തിൽ എന്ന പോലെ തന്നെ ഈ കേരളം മുഴുവൻ ഇത് നല്ല രീതിയിൽ പ്രവർത്തിക്കുമാറാകട്ടെ എന്ന് മാത്രം ആശംസിച്ചുകൊണ്ട് എന്നെ ശ്രവിച്ച നിങ്ങൾക്കേവർക്കും നന്ദി പറഞ്ഞുകൊണ്ട് ഈ ചടങ്ങ് ഔപചാരികമായി ഉദ്ഘാടനം ചെയ്തതായി അറിയിച്ചുകൊണ്ട് നിർത്തുന്നു. നന്ദി, നമസ്കാരം.
Dr. Samson Matthew to hand over the memento to the Honorable MLA Srimati Uma Thomas as our gratitude. Now, I request Sri Murali LS, Principal Consultant, KIIFB, to hand over the memento to Sri Loknath Bera Sir as a token of our love and gratitude.
Now I would like to invite Sri Murali LS, Principal Consultant, KIIFB, to deliver the vote of thanks.
Good afternoon to all of you. My responsibility here is to deliver vote of thanks to the dignitaries who have come for the function as well as the people assembled here. But before getting into my responsibility, I just want to mention a few points regarding the session. Like all of you know, KIIFB is the agency, legally formed agency under Government of Kerala, which is funding for infrastructure development in the state of Kerala. And in the effort of developing infrastructure, KIIFB is striving towards utilization of, striving to introduce sustainable technologies which will enable utilization of locally available material as well as possible. That's one of the aims, along with the development of infrastructure. So one of the main problem, what all of you know, with the restrictions in quarrying from our Western Ghat areas, we have seen like the calamities what we have faced in the last few years. With that one, there are a lot of restrictions which have come up in quarrying, and we have a shortage of aggregates. So this is one of the main area which we should consider and think about the technologies, what can be thought about in minimizing the usage of virgin material. So usage of locally available material and environmentally friendly material will be the focus of KIIFB, and this will enable faster construction of infrastructure also. So already we have done pilot project with respect to FDR. We have done a pilot project, and that pilot project was completed 4 years back. It is sustaining good, and with that one, KIIFB has thought about introducing the technology in many other roads in the state. Obviously, any change, there will be resistance from the stakeholders. So that is seen everywhere. Like the change is always not accepted with that ease. So resistance will be there for the change, but with making people more aware about the advantages and how best we can utilize and what it will help in saving our environment and protecting our environment, we have to gradually move towards adopting the technologies which are environment friendly. So with the success of that one pilot project, now KIIFB has already awarded contract for 9 roads in Kollam and Trivandrum districts, and which have just commenced. So it is not that like we are discussing and we are closing there. This is again like we have already started, and to make people more aware and how to utilize this technology more. That is the aim of this workshop, because we want to learn from what others have practiced in other places. And we have academicians who have done the research, we have people who have implemented the technology. We want to hear from them, we want to learn from them, so that like we can improve utilizing the technology in the state. So now the next 2 days, like we listen from people, other people who have already implemented the technology. We'll also like discuss the problems what we have faced or what we are facing in implementing this technology in the state. So see, now other than these 9 roads, NHA is also like implementing FDR technology in some of the roads, and LSGD department is also implementing FDR technology in many of their roads. So I hope that this 2 days session will help us in understanding the issues related with FDR technology, and will be a very fruitful session to evolve the smooth way of implementation of the technology in the state. Now I'll get into my responsibility. At the outset, I would like to thank Honorable MLA Srimati Uma Thomas, who has taken a time out of the busy schedule in joining us and like inaugurating the session. Thank you so much, Madam, for this gesture. Next, I would like to thank Mr. Loknath Behra, who is Managing Director of KMRL. Again, sir has got, all of us know that how much busy schedule with the implementation of the second phase and all. He has got a tremendous busy schedule. Within that one, he has accepted our invitation, and he has spent so much of time with us here. Sir, I would like to thank you on my personal behalf and on behalf of the organizers for attending this session. Next, I would like to thank Professor Veeraraghavan. Though he has not taught me, he is my guru, and I am just associated with him for the last so many years. So Professor Veeraraghavan is not a new person for me. Sir, I would now, as a representative of Kerala coming here, though I interacted with you not as a representative of the state, I would like to thank you for again coming to this session and delivering your knowledge to all of us. Thank you so much, sir. Next, I would like to thank Dr. Samson Matthew. Again, I have long interaction with sir also, like now sir is leading the team of NATPAC, and trying to bring in a lot of changes and bring in a lot of research oriented things in the organization. So I'd like to thank sir for taking this, leading this, organizing this workshop. Next, I would like to thank all the representatives from government organizations, PWD and other government organizations who have assembled here to attend this session. I would like to thank all of you on my personal behalf and as well as on behalf of the organizers to this workshop, for coming to this workshop. Next, I would like to thank the contractors and consultants who have come all the way to attend this session. I thank all of you for coming for this session. Next is the academicians from various institutes, not only in Kerala, from other parts of the country. Some of them are already here, and some of them will be joining in the coming, the next, maybe today afternoon and tomorrow. I thank all of you for accepting our invitation and to be part of this workshop, for sharing your experience in terms of academic research, what you are doing in terms of the FDR technology. Then I would like to invite our dignified representatives from other states like UP, Tamil Nadu, Karnataka, who have all come here to join this session and share their experience. Then next, I would like to thank the sponsors of this program. to make it, their sponsorship has enabled us to make this program a success. And media people have also come here. I would like to thank them also for coming forward and attending this session. And at the end, I would like to thank my friends in NATPAC who have been forefront in organizing the session, as well as my friends from KIIFB who have been interacting and coordinating with NATPAC in making this today's session a success. Thank you so much.
Thank you, sir. With this, the inaugural ceremony has come to an end. Once again, we thank all the dignitaries on the dais for your valuable time. Thank you all.
Seeing Dr. Vishnu, who is actually about to speak on mixed design, construction and quality control. Dr. Vishnu, who is, as you can see, young and dynamic faculty from NIT Warangal. He is currently working in the capacity of an assistant professor in the institute. Of course, his areas, as from the topic itself, you can say like payment materials, payment management systems, design and evaluation. He is a technical member of the World Bank funded project of our own RKI, Rebuild Kerala initiative of our state government. And he is a member of the PMGCSTA in Karnataka, Telangana and AP also for the scrutiny of DPRs. He is a member of several professional bodies. And over to Dr. Vishnu for the topic, sampling, mixed design, construction and quality control.
Hello, 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 hello. No. Hello. 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 No. Time വളരെ കത്തിയാണ് Hello. Hello. Yeah. Hello. 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 Good afternoon, all. Although the time that is allotted to me officially is 1 hour, I'll try to compress it within 45 minutes. Yeah, thank you. Yeah. Say myself, Dr. Vishnu, I work largely in the area of payment materials. So let us straight away go into the topic. Now this rehabilitation technique of full depth reclamation, it started gaining much of what you can say much of notice to many after the state of UP started to implement this technology in a wide level. So we came to know that the state of UP is actually implementing about 5,000 road kilometers. Now subsequently, we were also finding news from other states also. Now, say whatever slides or whatever information which I'm presenting here, it is my perception of this technology, or in accordance or whatever I have learned. Now, I would actually call full depth reclamation as a payment rehabilitation measure in which a predetermined depth of the payment is milled, of the distress payment is milled. Now, I'm not referring that the complete material has to be milled. I actually call this as a technology where a predetermined layer thickness, which actually includes the bituminous layers and a portion of the granular layers. Now, whether to mill the subgrade or not, this is something which we have to discuss and find out. Now, the mill material is basically stabilized using binders. Now, the binders can be a conventional binders. It can be cement, lime cement combination. It can be even fly ash plus any pozzolanic material or any commercial additives also. Now, Guru Vittal sir have detailedly talked about when this is applicable. This technology is basically applicable when the road comes to the fag end, when the condition of the payment of distress, it has actually reached to a very poor PCI condition. Now, the thing is, I think the previous speakers have have actually discussed in detail when this technology is applicable. So let me not spend time on it. Now, if you look at the cementitious FDR technology, we need to understand what are the benefits of this. Now, just because this layer becomes stabilized, the load is actually getting distributed over a wider area. As a result, the stresses which is coming onto the subgrade is significantly reduced. The second thing is, as you are binding the layer, when compared to a conventional granular material, a conventional granular material can actually fail in deformation. But whereas when you cement stabilize this, the material, the mode of failure largely turns into cracking. So you will not find deformation failures in full depth reclamation technology involving cementitious binders. Now, if you see the FDR technology, which is actually involving cementitious binders, the permeability of this material is very less. As the permeability is very less, when you talk about capillary ingress into this layer, it is relatively very less. As a result, you will not have reduction in the strength when it is actually subjected to submergence. Now, there can be different types of full depth reclamation technology. The first one is mechanical stabilization. Now, you mill the material, you increase the strength by enhancing compaction. This is one method. Or you add additional aggregates, you strengthen this. This is mechanical stabilization. Now, the second one is you can actually increase the strength of the mill material by going for a bituminous stabilization. The third method can be a cementitious stabilization, or by using any chemical additives. Now, the choice of additive is very important. Whether you're going for a mechanical stabilization or whether you're going for a bituminous technology, a cementitious technology, or a commercial stabilizers, this is important to understand. Now, before determining what is the depth that we need to cut, it is very important that we make structural assessment of the road. Now, the structural assessment of the road can be made by test pit investigations along with falling weight deflectometer studies. Suppose the length of the road is very large, you can do this by a couple of test pit investigations and also by falling weight deflectometer studies. We'll discuss this in detail. So the topic that was given to me is about sampling, mix design and quality control. Now I have added one more portion in this, which is basically payment design aspect. Now let us try to understand what is the purpose of the test pit investigation. The purpose is basically to understand, to assess the as-built payment layer composition. Now it is not necessary that if you see the previous DPR document of the existing road, the layer thickness need not match with what is being constructed. So it is very important to understand what is the as-built pavement thickness across the length of the road, because basically this is the material that we are going to use. So we need to have an estimate of how much material is going to be reclaimed. So it is important to assess the as-built pavement layer composition. Now, if you see full depth reclamation, it is very important to understand to what depth you are going to cut. So in most of the cases, we need to understand up to what depth your pavement is distressed. Say, for example, if you're talking about rutting failure, you need to understand whether only your bituminous layer has rutted or whether rutting is there in the lower layers also. So if you see this particular photograph, you can actually see the rutting is only confined to bituminous layers. But when you talk about low volume roads, if you find rutting can be because of rutting of lower layers. So when you make test pit investigations or sampling, it is very important to understand up to what depth you have issues. So if you're looking at the gradation of the mill material, say suppose you are carefully removing gradation from each layer, we can try to understand what is the PI of the fines. It can so happen that your granular subbase is contaminated, that it doesn't work as a granular subbase anymore. Okay, so it's very important to understand the nature of distress. It is also important to understand, we need to get careful insights about what has to be the depth of milling. We need to decide this. Now, the mill material has to be assessed for properties such as gradation, and we need to assess the nature of fines to choose the particular stabilizer. Now, it is very important when you go for full depth reclamation technology, it is very important that you assess the property of the underlying layer. Now, we need to understand that when you're going for a cementitious technology, this bound layer is actually sitting above subgrade. So try to understand that when you have a bound layer, when we have loads coming on it, the bound layer will try to flex. So if it tries to flex, depending upon your subgrade support, the layer can flex more or less. So it is very important to understand the property of the underlying layer. Now let us actually look at this picture. Now, if you look at this picture, you can actually find that there is a burrow soil and there is a native soil. Okay. Now, if you look at most of our low volume roads, where we encounter poor subgrades, they would always have a burrow soil. They'll always have a burrow soil, and this burrow soil thickness can actually range from about 200 to 300 mm. Now, when we are actually going for milling of even the subgrade, try to understand that this particular material is being taken away, and your FDR layer would be sitting above the soft subgrade. So it is important to assess. When you make test pits. It is important to assess. It is important that you make full depth pits. Full depth pits even beneath the burrow layer. Now, I have actually put up two figures here. This can be the cross section of most of the low volume roads that you see in Kerala. If you see the first one, where you can find above the subgrade, you may have WBM grade 1 of about 100 mm thickness, and above this you can have WBM grade 2, G2 and G3, each of 75 mm, constituting to about 150 mm, and you will have your 25 mm thickness of your bituminous layer. Over a period of time, we would also have thicker layers of bituminous layers because we have been overlaying it. Now, the second cross section, what you can find is this one. The second cross section is above subgrade. Most of the roads which are constructed by LFGD, you will actually find a WBM G2 or G3 of thickness of 150 mm. These can be the two cross sections that you might be encountering in your low volume roads. Now, over here, it is very important to understand what can be the depth of milling. As Dr. Guru Vital was saying today, now a reclaimer will never pulverize your bigger size boulders. Say, for example, if you see your WBM grade 1, WBM grade 1 is actually having bigger size boulders. Now it is highly questionable whether you need to mill this. Because when you're milling this, you are likely to encounter about, say, aggregates of size 90 mm. Your reclaimer is not going to crush it. So try to understand, when we go for a full depth reclamation technology, it is not necessary that you need to mill the complete material up to the subgrade. Now let us try to understand this. Say I have actually put up a figure here where above your native soil, you're actually having a burrow soil. As I told you, in places where you encounter poor subgrades, it is a usual practice that we bring soil of improved CBR and we construct a compacted layer thickness of about 200 to 300 mm. Now, if you're actually going for a full depth reclamation technology where you are milling a portion of your subgrade, we need to understand that your effective modulus of subgrade would reduce. So I've actually put up a figure here. If your depth of cutting is increasing, this is the way in which your effective modulus would reduce. So try to understand that when you're actually going for full depth reclamation, which is actually involving cementitious binders, when you actually cut your subgrade, you're likely to encounter a scenario where your stiff stabilized layer is sitting above a poor subgrade. Let us see this figure. This is a case where I can actually find clay soil beneath. Now, this is, say, I have added two more figures here. Say, as we increase the depth of cutting, your effective modulus tends to decrease. As a result, your strains coming at the bottom of your FDR layer would tend to increase. As a result, this layer would crack ultimately, would crack prematurely. So it is very important to assess whether our subgrade has to be milled or not. Now, that is why I highlighted here that depending on design traffic and existing groove thickness and foundation support, FDR technology might warrant the utilization of additional virgin materials. Now, when we need to do a mixed design, it is important that we need to collect samples. Now, I've collected this information from the manual which is given by PCA. So over here, you can find there are different methods of sampling. As sir was saying in the morning, when we tend to dug out material using a JCB bucket, you will actually get materials in bigger chunks. Now, this need not represent the pulverized material which is actually getting through a reclaimer. Okay, so there are a couple of ways in which you can take out the material. The first one is auger sampling. Okay, now this is something what we could even manufacture with this tungsten carbide bits. Okay, now the second way is your block sampling. The block sampling, what we are routinely doing. This figure I actually got it from NATPAC. Now another option is you can actually sample by this using a helical auger system, and when you do a sampling, it is very important that, say, suppose you're doing a test fit investigation, you need to collect the material layer wise. You have to understand what is the layer thickness, what is density in these layers, and what is the moisture content. And suppose when you're actually making test fit investigation, collect samples in this way. And if you want to collect materials for mixed design, you can actually go for auger sampling. Now this is a material that is being dug out for mixed design. So you can actually see there is the material is fairly pulverized. Now there is guidelines given by Australian Road Association for the frequency of sampling. Now this frequency of sampling is basically given as a function of from one pit to another pit, what is the distance. For arterial roads, this distance can be of about like 500 meters. And if you're actually comparing from one lane to another lane, this L can be about 250 meters. Now it is very important in cases where you're milling your shoulder portion also, at least 25% of the sampling has to be done from the shoulder area. And 25% of the sampling has to be made from the center bit of the existing carriageway. Now, the second most important thing is we need to assess the strength of the lower layers. Now, the strength of the lower layers can be assessed by using a DCP. Okay, now when you use a DCP, you're trying to understand what is the resistance to penetration when you apply blows. So this information can be used to back calculate the CBR values. Now, there is a different way in which you can do structural assessment of the existing payments. The structural assessment of existing payments can be also be done by FWD studies. FWD actually stands for falling wave deflectometer. From the deflected shape of the payment, we can actually draw inferences of health of different layers. Now, say these studies have not been extended widely to low volume roads. The one information which I've actually put up is basically an information which was done in IIT Madras through some researchers where they tried to assess the structural condition of different layers by carrying out studies on state highways. Now, if you look at the gradation that is given by NRIDA in its manual, you could actually find that this is the gradation given by them. So let us try to understand this gradation. This actually even entertains material of 4.75 even up to, see the range. The range is 25 to 100. So because of this range, this would tend to entertain your reclaimed material from any construction site. So over here you can see that it's a very wide band. It's a very wide band, and this is the gradation that is given in the NRIDA do-it-yourself manual. Now, based on the property of the mill material, gradation as well as your property of your fines, you can assess the choice of stabilizers. Now, if you talk about what kind of soils would be suitable for cement stabilization or cementitious additives, this would be basically non-plastic fines. Your gradation, which is actually having non-plastic fines, would be suitable for cementitious stabilization. Now, IRC SP 89 has also given you guidelines on how to choose additives. Over there, you can actually see the choice of additive can be chosen based on your C5 your gradation analysis, and also based on plasticity index of the fines. So this guideline is there to choose conventional stabilizers. I'm not talking anything about commercial stabilizers. Now, let us try to understand the mixed design procedure here. When you talk about the mixed design procedure involving cementitious technology, involving cementitious binders, this mixed design process basically has got two steps. The first one is a compaction process, and the second one is your strength studies. Now, when you want to determine the optimum cement content, the first process is that you will actually take, say, three different levels of cementitious binders. You will do a modified Proctor test. You will assess what is the moisture content, what is the optimum moisture content for it. Once you assess what is optimum moisture content, you will prepare cubical specimens of 150 mm, and you will assess the strength at each of the cement content. Now, there are guidelines about what has to be the target strength. Now, the cement content which is meeting your target strength is identified as your optimum cement content. Now, this cement content is taken for durability studies. Now, when you talk about durability studies, these durability studies include 12 cycles of wetting and drying. Now, 12 cycles of wetting and drying, what they mean is you will have to keep compacted specimens in a water bath for 5 hours, followed by conditioning the specimen at 71 degrees Celsius. At 71 degrees Celsius. Now, after this, you take out the specimen and you do a wire brushing of this. When you do a wire brushing of this, you will actually look at what is the loss in fines. Now, based on your PI of the soil and based on gradation, there are guidelines given as what has to be the allowable loss in fines. Now, the cement content which actually satisfies your strength and your durability criteria is identified as your optimum cement content. Now, let me bring a point here. You can actually see the strength value of 4.5 MPa is not a global value. If you see the strength criteria that is given by other countries, this is pretty less. This will actually result in lower incorporation of cement. So we need to understand that the value of 4.5 MPa is questionable, and we need to understand whether we need to even target for 4.5 MPa. So you can actually see the specifications from China where they target the UCS value of 3.5 MPa. if you see the specification from US, you can see that for cementitious stabilization, they actually target a UCF strength of about 2.06. Now, when you come to sections incorporating cementitious binders, as I told you before, we need to understand in what mode does they fail. They basically fail in cracking. Now, if they fail in cracking, it is very important that we have to provide crack retarding layers, which will actually prevent the progression of this crack to the top. This is basically what you refer as reflection cracking. Now, this can be done by two ways: by providing an aggregate CRL layer or by providing a SAMI membrane. SAMI actually stands for stress absorbing membrane interlayer. I have photographs, then you will understand it better. So basically, you can have two types of combinations here. The first combination is in FDR sections where you are not milling your complete granular layers. This is the first combination. And the second combination is where you are completely milling your granular layers. This is the second combination. Now, if you see IRC SP 72, there are payment design catalogs already given there. Now, if you tend to adopt these catalogs, this will lead to a very conservative design. This is because your target UCF strength for your CTSB and your CTB, what is considered in IRC SP 72, is much lower. Now, if you look at the target strength, what is recommended for FDR, it is 4.5 MPa. The value of 4.5 MPa is actually even recommended for CTB, which is actually used in highways. Now, when you go to highways, when you actually look at highways CTB layer, this is basically a layer that is prepared with fresh aggregates and cement contents of the order of 5 to 6%. Now, the question is, when you tend to adopt the same criteria for designing FDR, and that too with soil aggregate cement mixtures, the performance of this is questionable. It cannot be the same as that of CTB. So each of the FDR project is unique, and you need to do a payment design. So thickness optimization can be carried out by either by following a mechanistic empirical design, or we can still do it by using an astro payment design. So there are two methods of payment design philosophy what you can adopt. The first one is astro method, which is basically a structural number based method, and the second one is a mechanistic empirical method, which is based on IRC 37. Now the question is, why are we adopting these methods? Now we all know the fact that there is no IRC guideline which is dedicated for full depth reclamation, but we all understand the fact that this is nothing but a stabilized layer. It is nothing but a cement stabilized layer. Which is actually targeted for 4.5 MPa UCS value. So you can actually use your astro payment design philosophy or your IRC 37 mechanistic empirical payment design philosophy for designing your payments. Now, your IRC guideline for low volume roads is developed based on astro 1993 method, which I'll be discussing. And this has been developed, the design templates have been proposed for a drop in payment serviceability index of 2. The second thing is, if you want to follow ME design, IRC 37 2018 have given performance equations at two different reliability levels. They have clearly told for traffic less than 20 MSA, I can adopt the 80% reliability equation. So as I told you, there are two design philosophies what you can adopt. First one is your astro payment design philosophy, and the second one is the mechanistic empirical design philosophy, which is given IRC 37. Now, let me actually put a disclaimer here. The assumptions considered in the development of design catalogs. The subsequent slides, I'll be actually presenting some of the payment layer compositions which I have worked out. For that, I have actually taken some assumptions here. The assumptions considered in the development of design catalogs. Now, the performance equations considered in the design method. I have assumed that this remains valid. Let us try to understand that this is basically soil cement aggregate mixtures. Now, when you try to use IRC 37 fatigue equations for CTB, this has been developed for aggregate cement mixtures. Now, I believe that the same performance equations remains valid. Now, if you're challenging this can be only be better understood by monitoring our FDR sections which have been constructed now. Now, the second assumption is it is possible to achieve material layer coefficients or mode layer values which I have considered and defined. This is the second assumption which I have taken. Let us understand the first one, the first approach, that is ASHO 1983 design philosophy. Now, we understand that every payment from its starting, it tends to deteriorate. Okay, so we have a concept what is known as what is known as present serviceability index. So if you want to define any structure, say whether it's a beam, column, anything, every design has a performance equation, has a performance criteria. Now, when you talk about ASHO payment design, you are trying to find out what is the structural number of the entire payment layers which I need to provide above my compacted subgrade. Okay, so for low volume roads, you consider a drop in PSI of 2. So basically, this is the performance equation that is given in ASHO payment design, and you tend to solve this equation. When you tend to solve this equation, you're trying to find out what is the structural number I have to provide above this, above my compacted subgrade. Now, this is the first approach. Now, once structural number is determined, each of the layer what is used in different payment sections has got a structural layer coefficient and a drainage coefficient. So if I know these two coefficients, first one is structural layer coefficient and the other one is drainage layer coefficient. If I know this, I can actually define the thickness of my FDR layer. Now let us try to understand this. Now for low volume roads, when you talk about low volume roads, ASHO payment design clearly says that you can define this by 50% reliability criteria. When you go for 50% reliability criteria, this is the equation for developing, for designing your roads. When you go for high volume roads, you have to account for your drainage coefficients also. Now, let us understand that there are nomographs which are given in ASHO payment design to determine what is the layer coefficient. Now, let us understand for our FDR layer, which is actually designed for 4.5 MPa, we can identify what is the structural layer coefficient from this chart. I repeat again, if you look at your FDR mix is actually targeted for 4.5 MPa UCS value. So there are relationships given between unconfined compressive strength and layer coefficient, and these layer coefficients are given for cement treated bases. So I can adopt this. Okay. Alternatively, people have actually worked in finding what is the layer coefficient of FDR layers. You can actually see the layer coefficient what is recommended is 0.26, which is actually quite higher than the value what we get from this nomograph. So based on this, I've actually worked out what is the payment composition for different traffic level, and for different subgrade conditions. So you can see here, I developed this for T5 traffic, T7, and for T9, and catalogs have been proposed for payment sections incorporating CRL, that is a crack relief layer, and also for SAMI. One important point what we need to note here is, when you actually move from a payment section that is incorporating SAMI, your thickness of the FDR layer is higher than the composition which is actually including a aggregate crack relief layer. This is because your SAMI or even your crack relief layer, the function is basically for crack retarding. Now this function is not accounted in this design philosophy. Now, as I told you before, the layer coefficient, what I considered in developing these charts was basically 0.2. Now, if I adopt a layer coefficient of 0.26, which has been referenced in literatures, my payment composition thickness again reduces. So what I mean to say is, based on the FDR, based on the payments which are being rehabilitated by FDR technology, it is high time that we collect information and try to understand what is the structural layer coefficient, practically what we are able to achieve in the sites. So if we have this information, we can definitely design our payments using ASHO 1983 design philosophy. Now the second approach. When you come to the second approach, it is by IRC 37. Now we understand that when you go for IRC 37 design philosophy, we have two performance equations. The one for rutting of subgrade, and the second one is fatigue cracking of bituminous layers. Now when you have a cement treated basis also in the picture, you are also worried about fatigue cracking of your bituminous, fatigue cracking of your cementitious layers. So IRC has actually given has given performance equations for two reliability levels. One is for 80% reliability, other one is for 90% reliability. Now the 80% reliability equations can be used for designing for low volume roads. So while I was interacting with NATPAC, I came to know that they're actually designing FDR technology for roads of 5 MSA, 10 MSA. They can very well adopt the 80% reliability equation. Now, let me tell you, when you talk about payments incorporating FDR, which is basically a cementitious base, it is also important that you do a cumulative damage analysis. Now, say for doing a cumulative damage analysis, it is important that you have your your axial load spectrum with you. If you don't have your axial load spectrum with you, you can still adopt this particular criteria, which is given for cemented bases. Now, let us pull our attention here. The modeless value which you can consider for cementitious bases is 5000 MPa. This is the guideline that is given in IRC 37. Now, when you come to cementitious bases, which is incorporating commercial stabilizers, the code restricts the modeless in the range of 1400 to 1700 MPa. The code has clearly restricted this. Now, the thing is, when you design payments incorporating FDR, as of now, I could only utilize this value. Now, if you can do a full depth reclamation technology where you're only using cement as an additive, this is the value that you can adopt. That means you can actually do a rehabilitation, an in situ rehabilitation, where I'm converting my mill material completely into a cement stabilized base. If you are using any stabilizer, this is the modeless value only you can adopt. So as you have a reduced moduli, your layer thickness will tend to increase. Now, your thickness of the crack relief layer. Now, the thickness of the crack relief layer can be considered as 100 mm. This is a guideline given by IRC 37. Now, NRIDA, in the do-it-yourself manual, they recommend a crack relief layer thickness of about 75 mm for traffic for traffic of T9. Now, the second one is what modulus can I consider for my crack relief layer when I do a payment design? Now, the modulus, what you can consider is 450 MPa if my crack relief layer is 100 mm, and if it is only 75 mm, if you work out the modulus, this only comes as in the range of 300 to 350 MPa. Now, these are the catalogs which I designed for different traffic levels and for different different compositions. You can actually see here, I have analyzed this for FDR technology where a portion of the granular is left, and the second one, the complete granular is being milled. So you can see here, if you adopt the IRC 37 method, your stabilized layer thickness are found to be reduced. So it is very important that we try to understand what material layer coefficients of FDR we could really take in design. What material layer coefficients can be considered in design. Now, this is the booklet that is given by NRIDA. Over there, they have clearly given guidelines of about what has to be the surfacing what we can adopt. Over here, you can see here for traffic less than T5 category, 2 coats of surface dressing has been recommended. For traffic greater than T9, 40 mm BC has been recommended. For traffic between T6 to T8, 30 mm bituminous concrete has been recommended. If you look at the surfacings, what has been recommended, you can actually see either surface dressing or dense graded bituminous mix have been recommended. This is basically to prevent the percolation of water inside. Now, we understand the fact that we are not providing a drainage layer in FDR mixes or in payments incorporating FDR technology. So suppose after this, say after fatigue of cementitious bases, this layer is primarily going to be cracked. Now we need to prevent the ingress of water inside. To prevent the ingress of water, the code is actually suggesting you to go for 2 coats of surface dressing or to go for dense graded bituminous mixes which has got reduced permeability. Now let us understand the construction process. Now, when you go to the construction process, say if you're talking about a cementitious stabilization, this actually starts with spreading your cement at your required dosage. Now, after the cement is being spread, now most of the most of this FDR technology are machinery intensive. So once the cement is being spread, your reclaimer would actually start milling the pavement layer to the required thickness. So you can actually see there are water tankers which are actually connected to the reclaimers. Okay, now when I discussed about sampling, I told that your moisture content of the pavement layers have to be assessed accurately. This is because, say, in projects where you have a canal nearby, it is so possible that along the length of the road, your moisture content can vary. Now, it is you will have to do corrections for the moisture content that you're applying, that you're giving. So this is the tungsten carbide bits that you can see for the reclaimer. This is the reclaimer. Over here, you can see there would be cutting edges, and this is the dust prevention system what they have. Now, as we understand that this is a mill material which includes bituminous layer, granular material, and in some cases even subgrade. So it is important that these layers gets compacted to the required density. Now, a conventional static rollers or vibratory rollers alone cannot achieve this density. So if you look at pad foot rollers are having projections, and in most of the cases they'll be using a 20-ton pad foot rollers. So there is higher stresses being applied in the points of contact of this pad foot to the soil. Because of that, there is enhanced compaction. So you see in most of the FDR projects, you see kneading compactors being used initially. Now, as you tend to compact multiple, as you cover multiple passes, you tend to observe walkout phenomena in while you compact. What I mean by walkout is, say, after the layers have got densified, the projected portion of the pad foot will not be able to penetrate inside. This is what is referred as walkout phenomena. Now, once pad foot has run, they use a grader to spread the material uniformly. Now, as I told you, in most of the projects, they actually widen the road from a 3.75 meter to 5.5 meters. So your nearby shoulder area is also being milled. Now it is important that you uniformly mix this. You achieve your final desired camber. So they use a grader to uniformly spread the material. After grading has been done, further compaction is done by a series of rollers, starting with static soil compactors and vibratory rollers. The number of passes of each of these rollers had to be fixed before by carrying out a test track of about, say, 100-meter length. So the number of roller passes has to be determined because you are trying to achieve 100% density of your Proctor value. So it is important that you fix the number of roller passes. This is very important. Now, after the surface is compacted by means of static rollers and vibratory rollers, the finishing compaction is actually given by pneumatic rollers. Now, it is very important that your compacted FDR layer needs curing. Now, this can be done depending upon your climatic conditions. Say the first figure was actually taken way back in during winter times in UP. Now, as summer has picked up, they're actually using moist membrane curing here, using jute bags. So it is very important that until the first 7 days, as the FDR layer gains strength, it is important that you do moist curing. Now, the next one is, say, once your FDR layer is constructed, above that you have to either provide a crack relief layer or you have to provide a SAMI membrane. SAMI actually stands for stress absorbing membrane interlayer. And your crack relief layer is nothing but your unbound wet mix macadam. Now, in the case of SAMI layer, this is basically you initially spread your prime coat. You prime your FDR layer. Once you prime the layer, you provide geosynthetics over the entire width. Now, once the geosynthetics has been spread, this has been tightly, and it has been rolled by pneumatic compactors. Once that has been done, above this, your tack coat is being applied. Now the dosage of tack coat, the dosage of prime coat, say if you ask me what is the dosage of prime coat, this varies from 0.7 to 1 kg per m square. When I'm talking about this 0.7 to 1 kg, this is the weight of the residual bitumen. Now, if you talk about the spreading of tack coat, this varies from 0.27 to 0.3. Now, you can also go for another kind of SAMI application where you spread initially hot bitumen, and above that, you place single size aggregates. When you place single size aggregates, you have to compact this by using static rollers. Now, the different type of SAMI layers which you can use is actually given in section 5 and 7 of MORTH. Now, let us come to the field inspection. Let's talk about the quality control test now. Now, when you come to quality control test now, there are tests which are to be carried out during construction and post construction. Now, as you understand, we need to have a thorough check of what are the factors which actually influence the strength gain. Now, as you understand that this is a cementitious technology, so it is very important that you check what is the dosage of cement that has been spread, whether cement has been spread uniformly. It is very important to see whether moisture content varies across the length of the project. It is very important to see whether your material is thoroughly mixed. So most of your quality control tests is being listed here. The first one is your quality of cement. The second one is your depth of pulverization. Now, say in our DPR, we'll be actually having clear idea about what is the depth that you need to reclaim. Now, let me tell you, your depth of reclamation has to be practically verified in the site. This can be done by using a phenolphthalein indicator test. Now, the next one is thickness of the stabilized layers. This can be verified by taking out cores. Now, as I told you, the strength of the layer largely depends upon the gradation of the mill material, and the gradation of the mill material can actually change along the length of the road. Now, as I told you, it is important to assess the gradation because your JMF, whatever you are providing, it is not a scenario that the same JMF is applicable for the entire length of the road. When you do a sampling, it is important to assess whether your gradation changes along the length of the road significantly. If it varies significantly, a particular FDR project can have maybe more than one JMF. Now, your compacted strength largely depends upon the density that you're trying to achieve. So density can be carried out by using your sand replacement experiment, and the strength of the layers can be assessed by collecting your mill material, which is comprising of your cement and even your commercial additives. So you can collect loose mix from the site, compact to the densities what you have achieved in the field. So that is the last experiment. Now, after construction, it is very important that you verify whether your targeted strengths have been achieved. This can be done by two methods, by taking out cores and checking for UCS value. The second one is by carrying out a falling wave deflectometer studies, but the second one, not in every FDR projects, I've seen people doing this. So this is the first one where you verify your cement dosage. You verify your gradation. The second one is verifying the moisture content. Now, when you spread cement, they actually place trays and they actually take the weight of it. Now, to ensure the uniformity in mixing or your depth of reclamation, you can use phenolphthalein, which is basically a dye. So when you actually add cement, the pH of the soil changes. So the dye being an indicator, it will change in the color. Now, when you come to field testing, it is very important that you compare your densities that you have achieved. Now, please let us understand one thing. It can so happen that the material that you are having while doing your mix design and the material what you really have in the site can be different. So it is important that during construction you collect material and do a Proctor compaction study, so a Proctor compaction test, and evaluate what is the maximum density that you can achieve. With respect to that, you try to quantify what is your degree of compaction. Now, cores would be taken and would be sent to accredited labs for testing its UCS value. Now, alternatively, if you want to test your degree of compaction, you can use non-nuclear density gauges or a see the I have not seen people successfully using non-nuclear density gauge for evaluating the degree of compaction for soil aggregate mixtures. But I think we all are very comfortable in doing our sand replacement experiment for verifying your densities. Now, there are acceptance criteria also given. These guidelines are actually provided in the NRIDA manual, NRIDA do-it-yourself manual. So there are acceptance criteria as how much you would tolerate the deviation of the gradation. Your UCS values, say suppose you collect 3 cores, your average UCS value has to be 4.5 MPa. Your stiffness values, what you back calculate using following the deflectometer. Your degree of compaction have to be 100%, and your tolerance of surface level, this is basically your vertical profile. Now, we have actually tried quantifying the factors which influences actually influences the strength of FDR layers. So we have been trying to assess this by how does the strength of FDR layer varies with respect to change in cement spread because of inherent changes in moisture content, because of inherent changes which can happen in depth of milling. So we can actually see your strength of the layers. Your strength of the layers was actually found to follow a log normal distribution, and your thicknesses were actually found to vary in a normal distribution. Now, the strength of the layers were evaluated by using a lightweight deflectometer. So you could see here for different levels of reliability, how does your fatigue life would change. Now, different reliability levels corresponds to different moduli of the FDR layer, which I'm considering for my mechanistic empirical payment design. My concluding remarks, I think I rushed a lot because the time what was told me as 45 minutes. We need to understand that a test pit investigations is mandate at the selected frequencies. Now, milling depth of subgrade should be carefully determined as reduced foundation strength can result in a speeder consumption of your fatigue life of your bituminous, fatigue life of your stabilized layers. Compared to the cross section of FDR layer incorporating aggregate CRL for the same traffic and subgrade condition, an FDR incorporating SAMI would require higher thickness. The structure layer coefficients and the moduli, what you can adopt. Say this is a very important point. Now, every payment designer tend to be very ambitious, and they tend to take 5,000 MPa into consideration just because there is a clause in IRC 37 that for all cementitious bases you can take 5,000 MPa. It is very important to understand that whether you could really take 5,000 MPa for soil aggregate cement mixtures. So it is important that research has to be carried out in this direction and try to understand what is the structural layer coefficients and layer moduli, what you can practically consider in design. Now, the role of commercial additives, I suppose there are speakers after me, they would clearly tell. Now, as I told you, when you can convert your mill material to a cement stabilized base, where you could comfortably take 5,000 MPa, and as cement is an ease proven technology, we need to really find out what is this special role of this commercial additives. Because if you see the DPR, the nearly about 16 to 18% or even 20% of the cost of the total cost is attributed by the chemical additives. Now, factors affecting variability in the targeted strength need to be identified. This is very important because only if you identify what are the factors affecting strength, we could control it. If you could control if we could identify the factors resulting to the variability, we could try to control and thereby produce produce your FDR layer with minimum variation in the site. These are 2 reference documents what you could look into. Full depth reclamation with cement. This is given by Portland Cement Association. It has been published by Iowa State University. This document is available in the net, and this is the manual which is published by NRIDA. Thank you. I can take up questions. Sorry that I rushed it because I have time constraint.
Yeah, because we have already engrossed our lunch time and we can have two quick questions. First, we start with Arun Babu sir. Sir, please.
Hello. For bound bait layer, IRC 37 states about 5000 MPa, and then IRC SP 89 states about 1400 or 1700. So which one we should consider actually?
So let us have a fair idea that if you look at the cement treated basis of IRC 37, you're actually using crushed aggregates along with cement. There you can be very ambitious and take 5000 MPa. Here you are going for soil cement aggregate mixes, where I personally feel this has to be restricted to 1400 to 1700 MPa. Now, unless and until we carry out sufficient FWD studies and understand what is the layer moduli that is mobilized in the field, only after that we can come to a conclusions. As of now, I would recommend 1400 to 1700 MPa. No. See, I think so the question is IRC 37 2018 for cementitious basis, they give a provision of taking 5000 MPa as a modeless. But whereas when you come to FDR mixes with soil cement aggregate layers, what moduli we can consider? The IRC SP 89, it restricts part 2. It restricts to 1400 to 1700. We would recommend you to use that.
But then in case of cement stabilized plant mixed mixes, we can consider 5000, right?
For fresh aggregates.
Fresh aggregates.
Fresh aggregates, definitely.
Definitely.
So you want
Yeah, one more quick question. I think we can have one question from Raki. Raki is there. Please.
Everything boils down to what is the gradation that you are going to adopt for the FDR layer. Second question is FDR and CTFB are the one and the same. Only then all these questions arise. Yeah, that is a basic question. I think that needs discussion. I think we'll come to the issue of gradation and then come to the issue of strength. What we'll consider. The third question is that are we talking about CTB or FDR for a highway, or are we talking about FDR for a rural road? Which code should be followed? Is the area 37 to the 18 applicable for a rural road? There are many questions that are to be answered. So starting from gradation, I have got a number of questions I have listed down also. I think with tomorrow afternoon session is open for discussion. We can discuss a lot about this. Any other question?
I think we can take one or two questions only. Ragi is
So
there,
one
please.
more question.
So this regarding sampling, sir. Regarding sampling, sir. Assume, sir, we have a 10-kilometer road, sir.
Yeah.
Okay. So what I want to know is that for this 10 kilometers, sir, should I take 10 samples at a distance of kilometer each, go layer by layer, and take out the samples, sir? Once the samples have been taken out, sir, when you are preparing a JMF, sir, based on this, are we mixing all 10 together, or am I getting 10 different samples for each kilometer, sir? And my JMF should be 10 of them for each kilometer. Even if it is that, sir, even if it is that, how will I be sure, sir, that from 500 to 1500, the sample was different, sir? From 1500 to 2500, sample was different. Because on ground, generally the results vary, sir.
Fair. Say the specification what we have presently, for every 500 meters, we can actually have a sample. Now, we are not asking you to do a mixed design for every of the samples what you're taken. You need to make an assessment of how does your gradation and your PI of the fines varies from one pit to another pit. If it varies significantly, then you have to go for multiple JMFs. This is basically an engineering judgment.
To add to what Vishnu has been telling, what we have been missing and what we should do is that there is a methodology called as homogenization of the project road. We should homogenize the sections into different subsections based on soil type, based on traffic, based on distress, based on PA value, based on CBR. So you can test the 10 samples, find out the Atterberg limits, CBR value. Then you can plot a graph, changes versus distress, change versus the A value, CBR. Then you will be able to group into homogeneous section from 0 to 2.3 has got a similar distress, similar soil properties. Then you can take that as one sample. 2.3 to 4.8 can be another based on the distress and soil type. So individual 500 meters, what you are telling is only to know what the property of the soil at every chainage. Later homogenization will decide what the homogeneous section and what should be the JMF for that section. Yeah, there is one.
Yeah, please, please. Yeah. Yeah, true. Sir, say your FDR is actually recommended above the stabilized layer. We are actually recommending to be kept above a subgrade having a CBR more than 5. Now, when you're actually consuming your burrow soil, you'll actually landing up in keeping it above a very soft subgrade. This would actually result in more strains at the bottom of your cementitious layer. So I would recommend if you actually have your native soil is also pretty good, and if you're yeah, so if you're consuming your burrow soil, your effective subgrade, your effective CBR reduces. So you should not be even touching it. Say I have can you connect? Waiting.
If your subgrade soil is weak, then don't go for FDR.
Yeah. So give me a minute. I think I have a valid point. Yeah, please. Yeah. Yeah. Sir, it is basically your same FDR mix which is being extended to the widened portion also. You have stabilized mix itself. So say it is your say you're gonna mill your shoulders also, and ultimately using a grader you're gonna mix it also.
Hello, sir. I have 3 questions.
I think let me complete this. Yeah. You could see here when you increase your depth of cutting, your modulus, your effective modulus of subgrade tends to reduce. So if you're actually landing up in a scenario where your effective modulus goes below 50, then you should not be even thinking about cutting up to that depth. Yeah. Over here. Okay. Sir, okay. Your question is if you're actually cutting only up to just above your burrow. Okay. Now, sir, your cementitious FDI technology, you expect to have lower permeability. Okay. So you cannot place a granular subbase there. Okay. It is having lower permeability, so there will be lower capillary ingress.
I have 3 questions.
Please.
My first question is, what are the geometrical parameters to be taken into account while doing FDR surface? That is first. Second one is, you talked about SAMI layer. How many days after FDR surface should SAMI layer be laid? If there is delay in laying the SAMI layer, what are the after effects? And my third question is, Suppose if we have to add additional material, what impact will it bring to FDR surface? Suppose if there is predefined FRL to be achieved, sometimes additional material will be mandatory. So how does it affect FDR surface?
You are from KIIFB?
KRFP.
KRFB. Yeah, possibly you have issues with your geometric levels, your vertical profile correction.
Of course.
I think this requires a larger discussion. This requires a larger discussion.
If you could give some points.
All these questions will be answered tomorrow between 2 to 4 p.m.
Yeah, exactly.
Okay, we very well understand your problem in KIIFB where you have profile corrections coming up. We understand your issue. And your second question regarding SAMI, regarding when you could place your SAMI, say an FDR layer, suppose you're actually using a cements or rapid hardening stabilizers, within 7 days itself, your strength is being gained. So you can keep your SAMI after 7 days. Are you getting it? Say it is expected that if you're actually having rapid hardening cements such as an OPC, you tend to get this 4.5 MPa within 7 days. Then you could actually place your SAMI.
My question is, will there be any adverse effects on the FDR surface if
you open that to traffic? If you open that to traffic, definitely your FDR layer is going to crack.
Okay, I think let's stop for the time being. Of course, there will be a lot of questions to be there. And we definitely do have almost 2 hours tomorrow afternoon to have a detailed discussion on whatever doubts people are having. And we will be having a panel of experts to answer on that. So let me come to extend my duty. Again, to continue with that, in one word, I should say thank you to Dr. Vishnu, who delivered a lot of insights into this FDR approach, mixed design sampling, and all those things. And I thank you for keeping the time also, because right now I think back to the organizers for announcing on the future things.
KSCSTE-NATPAC, KIIFB, and everyone present here for delivering such an informative presentation. Now, we request Professor Dr. A. Veeraraghavan sir to hand over the memento to Dr. Vishnu sir as a token of our love and gratitude. Thank you, sir. Autolab and FWD equipments of KIIFB are arranged as part of the exhibition. The exhibition vehicle is parked just outside the entry gate. The delegates are requested to visit the vehicle and the exhibition stalls after lunch. We will now break for lunch. Food is arranged downstairs near the pool side, requesting everyone to assemble back by 2:15 p.m. to continue with the technical session. Thank you.
demands of their customers for quality reassurance. We are Matter Lab. A wholly independent professional and technical services provider for everything concerned with quality and performance of materials and products. What we offer is a bold promise of certainty to those sectors where failure in service is. Our exceptional testing facilities are a testament to our promise. Services offered by Matter Lab cover a plethora of sectors ranging from buildings and facilities to roads and airports, infrastructure to rail and light rail. Our parent company has a very long history and heritage that spans over about 95 years, which we are justifiably proud. We are an amalgamation of its traditional values of top-notch quality, transparency, and engineering leadership. Matter Lab, where quality matters.
Wakameripani Road leads to the capital of Nagaland, a mountain state in eastern India. Its length is 60 kilometers. Every day, thousands of cars pass along this road. Old and broken asphalt had significantly reduced traffic capacity, damaging cars and slowed down traffic speeds. Economic development of the state required the construction of a new modern road. It was decided to build it using A&T Stone Roads technology. Construction work was carried out without stopping any traffic, whilst maintaining high quality using our new technology. The first stage is the creation of a sub-base layer of the road. It requires only 4 components: soil, cement, water and A&T soil stabilizer. Waste from a local quarry was used in the construction, including soil from the surface of the mountains containing clay, sand and stones of various sizes up to 40 millimeters. The ready mix is prepared in a mobile soil mixing plant. 4% of cement is added to the soil. After that, the material enters the mixing chamber, where an aqueous solution of A&T stabilizer is doused onto it. At the same time, the stabilizer composition rate is 0.007% by weight of the soil, and the quantity of water is calculated based on the optimum moisture content during the compaction. The preparation of the aqueous solution is carried out in an additional tank, from where it is pumped into a mixing chamber with a metering pump. Note that the A&T stabilizer is environmentally friendly for humans and nature. The finished material is transported onto the road in order to create a new groundwork base. Work is carried out in lanes, first paving the first lane with a 100-meter overlap. The paver distributes the soil mixture, taking into account the required slopes and layer thicknesses required. Then the roller compacts it into the required density. The density is continuously monitored during the process. Immediately after compaction, a new section of the road can be opened to traffic. It does not require any additional care or adjustment. Then the paver moves to another lane and continues to create the sub-base layer of the road. A&T technology can significantly simplify the construction process and shorten timescales. Here you can see a stone road built a few months ago. This is a monolithic stone slab without cracks or deformations. Sledgehammer hits can fully demonstrate the strength and elasticity of the stone base. The modulus elasticity of the stone foundation significantly exceeds conventional construction procedures. This formation also allows the road to be used for decades.
मारिए एकदम कस के जितना दम है और जितना दम है मारिए अरे भाई और तेज मारिए महाराज मारिए मारिए और तेज मारिए रुक जाइए हो गया बस 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 मारिए रुकिए रुकिए इसका देख लीजिए
The final stage is the creation of a 4-centimeter layer of an asphalt concrete coating and the application of road surface markings. Let's take a closer look at the differences in the technologies. The initial construction of the road was as follows: a sub-base layer made of an optimal sand and gravel mix with a thickness of 25 centimeters, an asphalt base layer of 5 centimeters, an asphalt surface layer of 4 centimeters. A&T Engineering's technology using the new design, a stone slab made according to the A&T Stone Roads technology with a 20 centimeter layer, a 4 centimeter thick asphalt layer. This allows for a saving of more than 25% of the road construction costs by reducing construction time, material costs, fuel and electricity, as well as labour costs. The application of the A&T Stone Road technology made it possible to build a more solid and therefore longer lasting road. The stone base can be used for decades, which means additional savings in the future. In addition, the use of A&T technology has reduced to a minimum the environmental damage to one of the most beautiful places in India. Wakameripani Road leads to the capital of Nagaland, a mountain state in eastern India. Its length is 60 kilometers. Every day, thousands of cars pass along this road. Old and broken asphalt had significantly reduced traffic capacity, damaging cars and slowed down traffic speeds. Economic development of the state required the construction of a new modern road. It was decided to build it using A&T Stone Roads technology. Construction work was carried out without stopping any traffic, whilst maintaining high quality using our new technology. The first stage is the creation of a sub-base layer of the road. It requires only 4 components: soil, cement, water and A&T soil stabilizer. Waste from a local quarry was used in the construction, including soil from the surface of the mountains containing clay, sand, and stones of various sizes up to 40 millimeters. The ready mix is prepared in a mobile soil mixing plant. 4% of cement is added to the soil. After that, the material enters the mixing chamber, where an aqueous solution of ANT stabilizer is doused onto it. At the same time, the stabilizer composition rate is 0.007% by weight of the soil, and the quantity of water is calculated based on the optimum moisture content during the compaction. The preparation of the aqueous solution is carried out in an additional tank, from where it is pumped into a mixing chamber with a metering pump. Note that the ANT stabilizer is environmentally friendly for humans and nature. The finished material is transported onto the road in order to create a new groundwork base. Work is carried out in lanes, first paving the first lane with a 100-meter overlap. The paver distributes the soil mixture, taking into account the required slopes and layer thicknesses required. Then the roller compacts it into the required density. The density is continuously monitored during the process. Immediately after compaction, a new section of the road can be open to traffic. It does not require any additional care or adjustment. Then the paver moves to another lane and continues to create the sub-base layer of the road. ANT technology can significantly simplify the construction process and shorten timescales. Here you can see a stone road built a few months ago. This is a monolithic stone slab without cracks or deformations. Sledgehammer hits can fully demonstrate the strength and elasticity of the stone base. The modulus elasticity of the stone foundation significantly exceeds conventional construction procedures. This formation also allows the road to be used for decades.
एक ही जगह मारिए, एक ही जगह पे। मारिए एकदम कस के, जितना दम है, और जितना दम है मारिए। अरे भाई और तेज मारिए महाराज। मारिए मारिए और तेज मारिए। रुक जाइए, हो गया। बस 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 बस। मारिए, रुकिए रुकिए, इसका देख लीजिए।
The final stage is the creation of a 4-centimeter layer of an asphalt concrete coating and the application of road surface markings. Let's take a closer look at the differences in the technologies. The initial construction of the road was as follows. A sub-base layer made of an optimal sand and gravel mix with a thickness of 25 centimeters, an asphalt base layer of 5 centimeters, an asphalt surface layer of 4 centimeters. ANT Engineering's technology using the new design, a stone slab made according to the ANT Stone Roads technology with a 20 centimeter layer, a 4 centimeter thick asphalt layer. This allows for a saving of more than 25% of the road construction costs by reducing construction time, material costs, fuel and electricity, as well as labour costs. The application of the ANT Stone Road technology made it possible to build a more solid and therefore longer lasting road. The stone base can be used for decades, which means additional savings in the future. In addition, the use of ANT technology has reduced to a minimum the environmental damage to one of the most beautiful places in India.
Today, organizations from various industries throughout the world seek for a multidisciplinary testing facility in alignment with global standards and technology advancements to meet the increasing demands of their customers for quality reassurance. We are Matter Lab. A wholly independent professional and technical services provider for everything concerned with quality and performance of materials and products. What we offer is a bold promise of certainty, to those sectors where failure in service is simply not an option. Our exceptional testing facilities are a testament to our promise. Services offered by Matter Lab cover a plethora of sectors ranging from buildings and facilities to roads and airports, infrastructure to rail and light rail. Our parent company has a very long history and heritage that spans over about 95 years, which we are justifiably proud. We are an amalgamation of its traditional values of top-notch quality, transparency, and engineering leadership. Matter Lab, where quality matters.
Wakameripani Road leads to the capital of Nagaland, a mountain state in eastern India. Its length is 60 kilometers. Every day, thousands of cars pass along this road. Old and broken asphalt has significantly reduced traffic capacity, damaging cars and slowed down traffic speeds. Economic development of the state required the construction of a new modern road. It was decided to build it using ANT stone roads technology. Construction work was carried out without stopping any traffic whilst maintaining high quality using our new technology. The first stage is the creation of a sub-base layer of the road. It requires only 4 components: soil, cement, water and ANT soil stabilizer. Waste from a local quarry was used in the construction, including soil from the surface of the mountains containing clay, sand and stones of various sizes up to 40 millimeters. The ready mix is prepared in a mobile soil mixing plant. 4% of cement is added to the soil. After that, the material enters the mixing chamber, where an aqueous solution of ANT stabilizer is doused onto it. At the same time, the stabilizer composition rate is 0.007% by weight of the soil, and the quantity of water is calculated based on the optimum moisture content during the compaction. The preparation of the aqueous solution is carried out in an additional tank, from where it is pumped into a mixing chamber with a metering pump. Note that the ANT stabilizer is environmentally friendly for humans and nature. The finished material is transported onto the road in order to create a new groundwork base. Work is carried out in lanes, first paving the first lane with a 100-meter overlap. The paver distributes the soil mixture, taking into account the required slopes and layer thicknesses required. Then the roller compacts it into the required density. The density is continuously monitored during the process. Immediately after compaction, a new section of the road can be open to traffic. It does not require any additional care or adjustment. Then the paver moves to another lane and continues to create the sub-base layer of the road. ANT technology can significantly simplify the construction process and shorten timescales. Here you can see a stone road built a few months ago. This is a monolithic stone slab without cracks or deformations. Sledgehammer hits can fully demonstrate the strength and elasticity of the stone base. The modulus elasticity of the stone foundation significantly exceeds conventional construction procedures. This formation also allows the road to be used for decades.
एक ही जगह मारी है, एक ही जगह पे. Okay. मारिए एकदम कस के, जितना दम है, और जितना दम है मारिए. अरे भाई और तेज मारिए महाराज. मारिए मारिए और तेज मारिए. रुक जाइए, हो गया. बस 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 बस. मारिए, रुकिए रुकिए, इसका देख लीजिए.
The final stage is the creation of a 4-centimeter layer of an asphalt concrete coating and the application of road surface markings. Let's take a closer look at the differences in the technologies. The initial construction of the road was as follows: a sub-base layer made of an optimal sand and gravel mix with a thickness of 25 centimeters, an asphalt base layer of 5 centimeters, an asphalt surface layer of 4 centimeters. ANT Engineering's technology using the new design, a stone slab made according to the ANT stone roads technology with a 20 centimeter layer, a 4 centimeter thick asphalt layer. This allows for a saving of more than 25% of the road construction costs by reducing construction time, material costs, fuel and electricity, as well as labour costs. The application of the ANT stone road technology made it possible to build a more solid and therefore longer lasting road. The stone base can be used for decades, which means additional savings in the future. In addition, the use of ANT technology has reduced to a minimum the environmental damage to one of the most beautiful places in India. Wakameripani Road leads to the capital of Nagaland, a mountain state in eastern India. Its length is 60 kilometers. Every day, thousands of cars pass along this road. Old and broken asphalt had significantly reduced traffic capacity, damaging cars and slowed down traffic speeds. Economic development of the state required the construction of a new modern road. It was decided to build it using ANT stone roads technology. Construction work was carried out without stopping any traffic whilst maintaining high quality using our new technology. The first stage is the creation of a sub-base layer of the road. It requires only 4 components: soil, cement, water and ANT soil stabiliser. Waste from a local quarry was used in the construction, including soil from the surface of the mountains containing clay, sand and stones of various sizes up to 40 millimetres. The ready mix is prepared in a mobile soil mixing plant. 4% of cement is added to the soil. After that, the material enters the mixing chamber, where an aqueous solution of ANT stabiliser is doused onto it. At the same time, the stabiliser composition rate is 0.007% by weight of the soil, and the quantity of water is calculated based on the optimum moisture content during the compaction. The preparation of the aqueous solution is carried out in an additional tank, from where it is pumped into a mixing chamber with a metering pump. Note that the ANT stabiliser is environmentally friendly for humans and nature. The finished material is transported onto the road in order to create a new groundwork base. Work is carried out in lanes, first paving the first lane with a 100-metre overlap. The paver distributes the soil mixture,
Good afternoon, everyone. Good afternoon, Good afternoon.
Hello. Excuse me.
is
Manufacturing of the product began in New Delhi in line with the Make in India initiative. So the product has gained popularity across the nation since its launch and has become a go-to solution for payment stabilization needs in various industries. And on behalf of NATPAC and KIIFB, let me introduce Sri G. Chandrasekhar for giving a warm presentation on technology and their promising products. Please, sir. Not more. That was there. I didn't get you. Totally good for you. That's no. Okay. Okay. Good afternoon. Good afternoon. Respect. Good afternoon to everyone, respected dignitaries and all engineers and technology providers. So this is Chandrasekhar, on behalf of A&T Technology. Today I would like to give you some information related to my technology and as well as how it is useful for the FDR works. So as we know that the FDR is that is a recycling of it's one of the rehabilitation technique and that recycling of existing payment trust. And so there are important steps, that is pulverization and introducing some additive and mixing of that particular mix and perfect to required machineries. So this is approximately we will go with 100 ml as the site condition that available crust. So as we know that the AIT is the stabilizer which is developed by Russians. It's a Russian technology. So it is introduced by New Delhi into the Indian market under the Make in India concept. So it is a complex organic product. It's a liquid-based soil stabilizer. So it is a completely safe for the human handling, and it is not having any adverse effect on the environment as now. So what exactly this particular chemical additive is doing with FDR technology? So it is a liquid-based one, and it is going to dissolve in the water. As we know, to maintain the density, like we need to we need to connect the water tanker to the recycler. Okay. So recycler. So we need to add this liquid-based stabilizer into the water tanker as per the mixed design. So that when it is mixing with pulverized materials, what we have existed one, specified by the cement. So this is once you mix it with the recycler, it is going to start redox reactions with granular materials, so that a molecular structure is going to form. So by the way, a monolithic structure is going to form due to this redox reactions happen to the particles. So it is what this organic stabilizer is going to enhance the capabilities of existing materials. It improves a lot the capacities of existing materials. So that whatever the disadvantages associated with conventional procedures, so those are accounted with this particular technology, and it is going to work in molecular level, so which is distributing strength evenly throughout the structure, so that we can get the very stable and a long lasting road. And as well, so it is going to provide the required strength and durability and water resistance. So that particular technology got accreditations for IRC, what you require to use in India. And as well as the construction issues what we have naturally. So that is related to traffic, for heavy traffic. And issues we encountered that is heavy traffic and heavy rains and floods, and as well as we require frequent maintenance and quality control. So for all these issues, like A&D technology is giving you, it is useful for the heavy traffic, it is water resistant, it is vehicle soils alone, and no maintenance required for the stipulated design time, and with respect to quality control, as per the standards what we required, so it is undertaking all standards which is provided by the IRC.
So what advantages we have with this particular soil stabilizer? So this is nominal curing is required for that. So it is going to control the cement hydration. About 5 to 4.5 MPa percentage. So that the methodology, as we know for the FDR technology, as earlier information what we have. So we need to collect sample carefully from the different locations of your designed or decided road. So we need to do the sampling and we need to do the payment design and as well as mixed design also accordingly. And construction methodology that it involves more number of equipments as we know. So that construction, we need to concentrate more about construction methodology. So these are the three parameters we need to look into. Yeah. So we have to take the sampling from different locations. For each 500 meters, we need to collect center and two sets of LHS and RHS. Three locations we need to take the sample for each and every 500 meters of length. So once you collected that, as well once sample we need to concentrate about existing crust details. So we need to focus on that. What is the existing crust? What is the BD? What is the thickness of BD? And what is the thickness of BM? And what is the thickness of existing BM? GS. Whatever the crust we have, we need to clearly observe the thicknesses and as well as we need to record the before doing the system. And as we know that as the process, we need to look into the gradation of that collected materials, and we need to check the OMC and quality of that material. And as well as we need to do the mixture and as well also, and we need to check the purity and the capacity. So with that payment designs and mix designs and all regular parameters. So we need to have advanced measures we have in the FDR process. We need to deploy the advanced measures for the execution of this particular work. So whatever the existing cost we have, that is separated basis. So we need to declare information related to that, and we need to pulverize the critical material, and we need to add the cement and the soil additive, and we need to mix it with the machineries, and we need to go for the surface waste. So for that, the business what we require, that is recycler and water tanker and trucks, grader and the cement ready machine and vibrator roller and tandem rollers, automatic tank roller. So these are the questions we require to execute that FDR technology in reality. So clearly you can observe here that so that liquid gas as per the mix design, we need to quantify that and we need to take the measurable one and we need to mix it into the water tanker. And so here we have a cement spreading setup. So homogeneous is homogeneous means we need to mix the we need to spread the cement. The water tanker which contains any solution. After complete recycling of this layer, and we can allow the traffic immediately when we are constructed with ANT technology. So as we know that Once you completed that recycling and mixing with the recycler, then we need to a sequential order we need to follow with the dollars so that we can achieve the targeted strengths. So coming to that testing, what we need to do, and we need to ensure about that quality of cement and quantity of cement, and we need to maintain that moisture content and the density after compacted layer, and we need to check the UCF values after 7 days, after 28 days, and we need to getting the required thickness or not, whether the recycler is mixing up to desired depth or not. We need to check thoroughly while you are doing this FDR construction. And we have so many checks also for cement content, whether the mentioned quantity, the mentioned percentage, that may be for 4% or that may be 5%. So whether that particular cement strategy is spreading that quantity or not, we can check while you are constructing. And as well as the dosage of this liquid based stabilizer. So whether you design for 100 ml per cubic meter, whether it is going or not. So we need to check while you are doing the execution. So coming to that ANT technology, what exactly we are doing, especially in India. So you know that UP is a milestone for the FDR technology. They come up with 5,000 kilometers. So out of 5,000 kilometers, more than 3,000 kilometers are doing with ANT technology. So that is one thing. And one more thing that one major district roads under R&D Department of Andhra Pradesh. So we have executed 7.6 kilometers as a pilot project. So it achieved good strength and good parameters also. So in Karnataka, so we got it about 15 kilometers. So we completed that 15 kilometers in Karnataka also. So apart from this FDR work, we are also capable of doing CDB and CTSD works in eastern states and all over the India. So these are the locations of the projects which under ANT technology in UP. So this is a map. It is representing that how many roads are with ANT. So these are the district-wise information. The roads kilometers which we have with ANT. So these are the few pictures related to the projects in UP which are executed with ANT technology. So I think you know that the main procedure of all of that. I'm keeping these pictures. So these are the procedures. This is the back. Once go back. Parameters in projects which we have executed in Andhra Pradesh. So this is the R&D. So this is we 2021 2022 we have executed this project, and I'll tell you that how we have executed, how challenges we have faced while we are executing this project. So these are the approvals what we got from the Andhra Pradesh government regarding this FDR technology. So these are the challenges actually. This is the road near to the Godavari River. So it is completely deteriorated pavement. We cannot find PCA layer on that particular surface within the total length of 6 kilometers. So it is there is no maintenance activity from the past 15 years for this particular road. So the department, the road safety department, given the challenge that take this road and do it with the FDR technology and prove it. So that ourselves we have taken that challenge and we approach to CRRI also for the evaluation and all. So that we taken. Yeah. So this is the thoroughly we have gone through the total length and we have collected samples for 3 samples from each and every 500 meters of length. So everywhere we got the crust, it is more than 300 mm. So it is good to recycle. So we have designed for that particular road as subgrade, the effective subgrade of that particular location is about 5%. And we have taken GSB as the 150 mm and the CTB layer for the 300 mm and BC layer for 40 mm. So with this particular, and we have also placed the family layer above the CTB layer. So we have designed and executed with cement content about 4% and as well 100 mm per cubic meter as a stat stabilizer. So these are the pictures. It is that during FDR work in Andhra Pradesh, we have taken this picture. So you can observe that. So in presence of engineering chief, Mr. Naimullah sir, he regularly visited the site and he taken the observations and he given some recommendations. Even one thing I can tell you that we have taken this responsibility in winter, rainy season. So once you done that recycling, immediately we got a heavy rain. So like that, we protected that 500 meters of length in that yellow. So people may call that it is a yellow road, but it is not yellow road. It is we protected our recycled CTB layer with protection. So also we have taken MTech students from Andhra Pradesh AAIT so to evaluate that to understand the process of FDR technology. So under field in laboratory and field testing we have done. We have collected UCS samples from different locations. We have tested in presence of bureaucrats and the department people how the performance is there. So we achieved more than target. So even this is the picture. It is representing that after completion of the space will be like that. So also we have doing FWD test by CRRA. So CRRA team also visited and they have taken that FWD analysis. So to evaluate the past performance of the road. So we got wherever we added few materials or aggregates, we achieved more than 10 MPa. But wherever without adding anything, in situ, completely in situ recycling where we have done, we have achieved 7 to 8 MPa with the ANT technology. So this is the pictures, the similar pictures of similar projects we have also executed in Karnataka. So these are the pictures. It is representing that how we went for that Karnataka project. It is also successfully completed by the ANT. So these are the results what we got from the Karnataka project also. So these are the we are the technology providers. So we have a benchmark at UP as well. We are looking forward to work with Kerala. There is a stall at outside. You can approach us and thanks for the opportunity. Thank you.
Thank you, Chandrasekhar, for giving your inputs. So the session is now open for questions.
Any questions from the audience, please?
Yeah, please.
In your results, you were showing uses about 10, 17 and all. What is the period? Like 28th day, it is solved?
No, it is 7th day, after 7 days.
After 7 days, you have did the usage of 11 and for FDR layer.
When we added a added aggregates into that location, there we got that number.
You have added external.
Yeah, additional external aggregates we have added for some locations where we don't have requirements.
Okay, sir, but what about the mandate? Like, are we concerned about the brittle side of the layer? Isn't it becoming more brittle when you're bringing up the usage above 7, which is the mandatory limiting value?
So it is completely, it is going to vary from location to location. Somewhere we will get only 4.5, 4.7 or 4.5 something. So the targeted strength of that particular UCS is about 4.5 to 7 MPa from 7 days to 28 days. So it is going to fluctuate on an average, we are going to get, without adding any aggregates into that location, then we got around 8 or 9 MPa.
I don't think if you're adding that aggregates or not is a concerning thing. If but all you're not you're adding aggregates, have to limit the UCS in certain limit. That's the mandate. There is steady outputs and plans. Because as it goes up, your FDR layer will be more treated. So letting it go beyond that just because you're adding fresh aggregate, do you think it is like okay, or will the structure be tracked to?
It is completely structurally safe. There is no limit for it. There is no upper limit for the strength. There is no upper limit. So there is a that is the boundary limit they have mentioned in IIC as I know.
0.5 to 7.
There is the boundary one. So if you achieve more than that, it is good only. It is not going to get any structural damage to the road.
Talking about UCS value.
That is UCS only related to strength parameter.
It is making your layer more trivial as
well. When we have a homogeneity, it is not going to. Thank you. Is there anything?
I request you to, because we are UP, he says 3,000 kilometers rapid use times. You can tell your feedback.
Actually, I wanted to comment during my presentation.
Yeah.
The only thing I want to ask one here. Do you have any certification or testing of the road stretch or road where you have not watered or you have not done any curing and you have used only that additive with cement?
Sir. No certification is there, but
just you said water is not required, curing is not required.
Nominal curing is required, I told them. Yeah. So I placed that nominal curing is required in my presentation. Sir.
I'll be answering that during my course. I have everything.
Yeah.
Sir, regarding your dosage, you said that it is almost 110 ml per cube.
That's to 110
ml per cubic meter. So how do you ensure that?
So with respect to physical parameters of samples, what we have collected, so we need to do the similar sampling mixed results with the 3%, 4% of cement.
Sir, that is okay. How do you ensure like that site? 110 ml?
Yeah. For actually, we need to calculate that. We need to add that particular quantity into water tanker, right? So to check the volume of the water tanker, so accordingly, we need to measure the quantity as per the definition. We need to add it to particular water tanker.
Is there any control for the discharge of water from the water tanker?
That's the question. Question is not how do I add incremental. Question is how do you ensure for 1 cubic meter that 100 ml is being added? That's the question. Yeah.
You are adding 100 ml or no?
So that as per the OMC, what we are placing that as per the OMC, when we have got the back calculation, we will get the
Moving.
Yes, sir.
What is spreading into that?
Yes.
Ensure for every 1 cubic meter that OMC water with 100 ml of stabilization is added.
See, since you are not entering, you are getting more strength at some places and less strength at some places. If you ensure one time and one, how you will ensure that you have 110.
So my answer is for that. So the entire quantity of water is mixed with the required quantity of dosage of the chemical. So that you are ensure of water content, then we can ensure of this air content only, chemical content also. So there is no specification for that particular OMC also. The similar way, the chemical also, it is mixing with water. So
how do you know that for 1 cubic meter that OMC is added?
Physically, we cannot measure that.
No,
physically we cannot measure that.
I will cover that in my presentation. I will cover it.
Any questions, please?
Thank you for the presentation from ANT Technologies. So, the next topic for presentation is the role of additive in the FDR, and it should be handled by a representative from LSR.
LSR is established in the year 2005 and is one of the leading road construction and infrastructure development company. They have executed various projects in extremely difficult terrains and hard weather conditions. Some of the projects of laying bituminous layers have been executed at a height of more than 17,000 feet above the sea level. They also worked in projects in Himachal Pradesh where they have executed works in sensitive border areas with extremely harsh weather conditions and access restrictions. So on behalf of NATPAC and KIIFB, we welcome you, sir, for the presentation. So you'll be having 15 minutes for the presentation, followed by a short quiz session, sir. Please.
A very good afternoon to all dignitaries, accommodations, officials of various agencies, and all guests. I take this opportunity to thank P and NATPAC for allowing us to come and put up a stall here and be a part of this presentation and workshop. Firstly, I'd like to start with LSR and FDR. In the FDR that we are doing in road construction using cement and additives. Next. Firstly, I will give you a brief information about LSR. LSR was founded in 2005 with a vision to build trust, strength by connecting humankind. We've used to evolve and transportation and facilities to the normal in the border areas where we were initially working. The quest is to spread effortless connectivity of roads with advancement and technology from impossible altitudes. Armed with passion and equipped with cutting-edge technology, LSR undertakes each project with acute precision. LSR Infracon's substantial fleet of construction equipment includes recyclers, stabilizers, excavators, graders, soil compactors, dumpers, and a lot of other machinery. With futuristic approach to construct technology-driven infrastructure, we are collaborating with all masters in the industry beside having our own extensive fleet of machinery plus high potential teams and their dedication, making us ready to manage challenging and demanding projects with reflects in the quality of the projects we deliver. Now, I will not do the specifics of FDR because a lot of other discussed that. I will simply go into the role of admixtures in soil stabilization or FDR. The 6th page. Yeah. Okay. Now here's a graph with pressure strength. Blue curve you see is when only cement is added. So you see after 56, there is a flat. There is no more UCS that is achieved with only cement. Whereas with 2% all pave and the one is 4% all pave. So you see after 56 days also, there is a steep hike in the UCS values. There is an increase almost till the 90th day when we are adding the mixture in comparison. Next. Now here you see is a scanning electroscope microscopic test. In the, as you see, there are 6 images in this. The first 2 images are with only cement and the other 2 are with cement and fly ash and other 2 are with cement and all pave. Now, firstly, what is a SCM? SCM is a scanning electroscope microscope which scans the structure and the molecular consistency of the entire thing. This test has been done in Australia, and we've just got the reports a few days back, and it shows that whenever all pave is there, the density is much more, leading to a better grip on the surface and compressive strength, yes, naturally. Next, I will not go into the FDR process and all. That's all I think has been discussed enough, and I don't need to go through it. Now we'll go to the works that we've done. Yeah, currently we are doing a lot of works in UP. We've got around 250 kilometers in which we are only providing the technology as well as we are executing it on our own. We are getting very good results as far as the technology goes. Mr. Dubey from UP is here. He'll be able to enlighten you even further. And but we did before that we've done a lot of work in border roads. We worked from the different difficult terrains of Arunachal Pradesh to Leh to the heights of Uttarkashi, where we've done roads beyond Joshimath. I don't know how many of you have heard about Joshimath or not, but it's pretty far. I'll give you a brief background about our Arunachal projects. We've done 4 projects in Arunachal. 2 were TCC Taksing Road, TCC Maza Road, and 1 was Hurli Sapori roads. So, you know, to reach these roads, the nearest airport was almost 2 days drive. And the roads to reach these sites, yeah. So these were the kind of sites that we had when we got them. Can we see the after picture also? Yeah. And this is what we left with. You can see the before and after right on the same screen. The slush, the water, and there was absolutely no aggregate. And we've turned it into, I think, a beautiful surface. And at the end of our work, our chief engineer used roller skates and he went down the entire 32 kilometers on his skates and came down. Other than this, Arunachal, as it is, it's a very difficult terrain. Reaching there is a problem. Every day it rains to the extent that it's beyond motorable. In those challenging circumstances, we did this work in all 4 works in almost 1.5 years, whereas the department took 51 years to do the formation works in these areas. We have almost 7 sets of recycling equipments, one of the largest in India. Our equipment, chain of equipments, plus our additive mix, LSR, and all pay a unique experience for any department to work with. Thank you. Any questions?
Sir, for sharing your inputs and expertise in this particular area. And the session is now open for questions.
It's very clear, I say. Sure.
You have to tell us about the quality control test that you carried out. What is that?
Already told us
No, no, how you did carry it out.
Okay, we can do
How
that.
did you decide this stabilizer for that soil? How did you do the mix design? What are the quality control tests?
Everyone has done the same thing.
Correct, but until your results you show, let us know. Where is
I'll
6
go into-
MPa, 10 MPa, 20 MPa, what is that you got? Let us
Okay, I'll go into the specifics. I was told not to keep saying the same thing again. Okay. So I'll give you an example for Arunachal works. So for Arunachal works, before tendering only, we are given soil samples and we have to collect those soil samples and we have to submit a GMF along with the tender form. Okay, so we submitted a GMF along with the tender form, and then I think it was around 4.5% cement and around 2% additive. The layer was GSP and there was 270 mm of CTB, and on top of that there was a SAMI layer, and on top of that there was 40 mm BC layer. We we started the work, but we realized that there's a lot of problems in the surface because the hills were very hard and we really could not do any FDR per se or CTB. So we had to incorporate additional material from outside and we had to work like CTB, not FDR. So, but additional material was also a problem because Arunachal does not have any granular material or anything where you can really work with it to get a good result. So whatever material was available on the hillside, we used it. We made another JMF again. We got that again passed, and then we did our work. That is why we took around 5 months extra to complete the works. Otherwise, we could have done them in a year. We followed all the test results that are supposed to be followed as per normal moth routines for CTB and CTSB works. And that is how we completed this.
Continuing to what you told, you have done it in Arunachal Pradesh, you are doing in Kerala.
Yeah.
Now, what is the difference between both these projects? What are the problems that you face in Arunachal Pradesh? What are the problems you face in Kerala? Were you able to keep the finished road level same in Arunachal Pradesh and Kerala? Are you able to ensure the geometrics, profile, camber, slope elevation, and curves in Kerala? Are you able to maintain it or not?
Okay. Yeah. So firstly, I'll talk about the problems that we faced in Arunachal. Yeah. Arunachal is our project, all 3 project sites were almost next to the border. They were so close to the border that when we were installing the stone crushers, the Chinese government paid the locals to help to ensure that our stone crushers were not installed. There was a lot of problem in that, and the Indian Army really helped us. Other than that, anything, I mean, any raw material to reach there is a problem because there are a lot of rains and a lot of times the roads are closed, due to which anything, you never know when you want a truckload to come, and it takes almost 10 days for that truckload to come. Comparatively, Kerala is much easier in its accessibility and location-wise. Everything else is okay, but we are facing a lot of problem as far as the geometrics and other to achieve the finished road levels and everything as being demanded by us.
Yeah, fine. I think there are a lot of questions to be answered. Tomorrow we have 2 hours exclusively for discussing about all these issues.
Right. Right.
Sir, you said Arunachal Pradesh. Arunachal Pradesh, you were using CTB or FDR?
CTB. Sir.
CTB, then what was the layer below that?
GSB, sir.
So you remove the material, you put GSB, then you
No.
Then
GSB was done by department. We put CTB on top of that.
Oh, that is no. So what was the layer thickness of CTB? No,
No, sir. I did not do FDR. I did CTB, not FDR. CTB and CTSB.
You said you did CTB.
So that's what I'm saying. I did CTB.
What was the layer below that?
GSB.
So it was not FDR.
No, it's not FDR.
So okay. Now, no. Earlier you said you have used FDR in Arunachal Pradesh.
No.
Actually, it was CTB.
It was CTB. One stretch we did only CTB, and another stretch we did no GSB, only CTSB, CTB, SAMI, and then BC.
But that is different, and FDR is different.
Yeah, that is different in FDR. FDR we are executing in UP. Right.
Thank you, sir. Now I request Dr. Sunita V, Associate Professor, NIT Trichy, to hand over the memento to and technology as a token of our love and gratitude. And technology. Also, I would like to invite LSR Infracont to accept the memento. Thank you, sir. Thank you, ma'am. The next topic for the presentation is the experiences on FDR construction and QC in UP. The session will be handled by an expert who is Brijesh Dubey from Uttar Pradesh Rural Road Development Agency. To introduce him, I would like to welcome Shri Wilson Casey, Senior Scientist, NATPAC, to the dais.
Oh, yes, please. Very good afternoon to all. It is my pleasure to introduce Mr. Brijesh Dubey. Mr. Brijesh Dubey worked as a civil engineer in the Rural Engineering Department of Uttar Pradesh. Presently, he is working with Uttar Pradesh Rural Road Development Agency, Lucknow. He is the State Quality Coordinator for PMJSY in UP. With this, we welcome you, sir, for the presentation. Sir, you have 1 hour, including the question answer.
Thank you. See, till now, everybody has discussed about the technology and their additive application in FDR in UP. In UP, we have taken up 5,500 kilometers. If you count it in numbers, 686 roads. All packages of PMGSY, UP is, I suppose, the highest in FDR work. And whatever results so far we have decided to go further for the same technology, but there are challenges, and how we have come across that, I will just give a brief of it. Why we adopted PMGSY? See, in PMGSY 3, we submitted projects to Government of India. Take next. It was 1,200 plus row packages, but out of that 290 and 299 packages were observed of high rates. In UP, whatever we get material, it is all at boundary of the UP, and cartage is around 300 up to 350 kilometers. So cost goes very high. NIRDA suggested that you change the technology or reduce the rate. Next. See the rates. In India, for 5.5 meter width, the highest rate per kilometer was 135. It is very high, and NIRDA was not able to sanction that. So when they asked us, we started working on this. What we did first, next. We wanted to observe the challenges, what is there in FDR. And what we came across, as you have heard earlier, there is no SOR, so rates were a problem. Then no technology, any defined codes were not there. And experienced contractor, few contractors are there in India who are working on this, but if we are going to have such a large number of roads, then scarcity of the contractor. And what is the role of the additive and what is the role of the combined cement and additive were not known. So what we did, we said, okay, we will earlier sanction of 800 plus roads. We decided 9 roads we will do as a pilot, and we converted that road for FDR, and one of them road is complete, and I just saw photograph there of Chitrakoot. It's a famous place. Problem of availability of machine is also there. Because a reclaimer, when we started, one company said in India there are total around 60 machines, reclaimer. And out of that, 30, 35 or 40 is in field. And today in UP, 52 machines are being used. I suppose I take it as a privilege to inform that when you people will go for FDR, definitely machines will be available. It will not be a problem. Next. We arranged a PMU. PMU for the first job was for preparing DPR because we never knew how to complete the DPR work. So PMU did DPR work as well as field test, and planning and execution was also part of it. Afterwards, we took help in deciding and giving clearance for job mix as well as trial patches. What we did as an intervention next. After PMU, it is not visible from there, it is not visible here also. This is some problem. Okay. Decision of trains, train of equipments were not there. May I take my specs? Yeah, sorry. Train of equipments were not defined. We took help of the papers from outside, from out of India, and we decided train of equipments. Then soil texture and classification, it was different for the whole UP. UP you can decide in, majorly you can decide in 4 or 6 categories. And then availability of aggregates in pavement. The roads which we were converting into FDR, it was of state roads or PMGSY roads, which has completed at least 10 years. And then use of SAMI, because as you heard, SAMI was suggested by us instead of granular layer, because we had one experience of the old road at district Kanpur, and there maybe due to the faulty execution that failed, and it was granular layer was used there. So we decided to go for SAMI. And then pavement design. Pavement design, actually experience was not there. We took help of the SP72, and the chart you must have seen in the first presentation today. We took help of it, and we decided that we fixed the depth of the stabilized layer as at 25 centimeter. Few roads where traffic is less than T5, we have 21.5 and 22.5 also, T3, T45, and T6 and above, we have 25. 3 roads, which is of mining area, is having 29 centimeter depth. It was, we took help of SP72 next. See, the main problem again when you are going to execute is material, machine, manpower, and procedure. Everybody will explain their own experience. We fixed our requirement. Depth is, I'll just put example 25 centimeter. Required UCS 7 days, 28 days, 4.5 to 7. As earlier claimed by A&T, we never got any UCS of 10 in UP, never. I don't know from where he has given that. Yes, okay. Okay. So first thing is material, and in material, if you see, it is CCS, availability of CCR additives. Additives, we have to decide for different soil and composition, which will be applicable. Few contractors have gone for the trial of 2-3 additives. Most of them have approached economical approach, and they took decision on the basis of the cost, but it was a challenge for us to get the result from that additive. And then cement and SAMI fabric. I will first take up CCS. When we are working in government, we have to fix certain rules. We decided that whatever additive will be used, it will be of IRC accreditation. Must be having IRC accreditation. With IRC accreditation, if similar type of any organization is there outside of India, they can also give it. And for that, they can start the work. But in that case, if they don't have IRC accreditation, it will be used only for pilot project and for 10 years DLP. So I can say today 9 additives are being used in UP, and definitely highest is by A&T. It is 2400 kilometers, and LSR is doing, and Base Seal is doing, Stable Road is doing. There are 9 additives. They are major shareholder, where I took the name, but different types of additives are there. We ask them leaching test certificate. It should not be harmful to the soil, man, material, and animals, etc. They provided us, and IRC accreditation is must. And for that, here we did one intervention. We made a committee at UPRRDA, headed by Chief Executive Officer of UPRRDA. Every additive company has to produce their papers to the committee, and if they approve, they can continue with the work. If they don't, it will not be used. So in-house committee is there of UPRDA to check these points: IRC accreditation, their usage, their certificates, etc. And challenges as additives are there for powder form as well as liquid form also. How to use it will be used. Next. I'll just give a brief of SAMI, then I'll go again back to the first one. SAMI, geotextile fabric, and whatever we are having a moat table which has been provided to us, but we have asked contractor to take certificate of the SAMI producer, from SAMI producer, and we can check GSM. It is 140 mentioned here. We check it sometimes, and we have not yet done, but we have planned to take few sample of it, and we will be checked. It will be checked in some approved labs. Next. The second challenge was availability of the machine at site. Contractor mentioned it, so we fixed the machines capacity, like reclaimer 2 meter to 2.4 meter width, motor grader 3.5 to 3.7 and 4.4 meter, computer controller binder, additive and bind cement was made sure that it should be spread with the help of the computer controlled spreader. Pad foot roller 20 ton, single drum soil compactor 10 to 13 ton, water tanker and pneumatic tire roller 10 to 14 ton. Problem was here when initially there was one of our contractors started with the bags. He was debarred and blacklisted for the rest of the work. He did only could do only one work. So we were very strict just because we were new and we never knew what is going to happen. So we made, this was the first effort where we ensured all the machines should be there at site. Next. This is a part of process. We know that in PMJSY, we have to establish lab. Here we have slightly more improved lab where machines and testing equipments are required. So we ask them to establish lab. Manpower is very important, and for that, this work needs not driver. They are operator of the big machines. Engineers trained not only with the qualification but with the experience. Lab, all technicians should know their job. And when we are going to have actual work in field, they all should know what is their job. Because within 2 hours, we are using cement. We cannot give more than 2 to 3 hours to the stabilized layer. Otherwise, it will become hard. So everybody has to do what is required in the field. Next. Job mix formula, as everybody said, is very important. We ask, I'm speaking whatever we have taken in the SBD, our tendering papers. We ask contractor to take help of technology provider, it means additive provider. They can give the job mix formula. IITs, CRRIs or NITs, they were also requested for job mix formula, and it was the first requirement. And in job mix formula, we asked these parameters: gradation of the representative sample. Representative sample is very important, as one speaker has just finished before lunch. Then Atterbach limits, OMC, MDT, and UCS, 7 days, 28 days, flexural durability and residual strength, and percentage of cement and additives. We ask these parameters, the report of JMF should include these details. I'll just give a brief of representative sample as said earlier. We ask every contractor and PIU to take 50 by 50 meter, dig it up to the subgrade, because UP is using subgrade in 100% work. In every road, subgrade is being used. So we ask them, take out, dig it up to subgrade, and by mathematical calculation, you decide 3 or 3.75 meter, when it will go to 5.65 meter, what will be the available crust thickness for that width, and the rest will be subgrade. By doing that calculation, go up to that and take out that sample. Zigzag manner, as explained earlier, and doing test, yes, soil test as well as the availability of the crust. And then you have to decide, as earlier told by Professor Saab also, that what will be the number of the JMF required. And after doing that, only you can go for the final JMF. For one JMF, one trial stretch was required. 100 meter to 300 meter. Most of them have made of 100 meters. Next. When we got trial stretch report, that few of them, because you know the
flatural code says flatural should not be more than 20% of the UCS of 28 days, and residual is saying it should not be less than the 20% of the 28 days UCS. But in most of them, few of them got residual more than 28 days of UCS. It was a problem. And few flatural strength was slightly higher than the 20%. It was around 21 to 24, in between 21 to 24%. And for every step, we consulted few professors, scientists of CRRI and IITs, and we decided the things. Why I'm quoting here? Because we have already done it. And as per that suggestion, we have in, I'll just give an example. In code, the CTB code, it was given, it should not be more than 1.4, and few got 1.6. We tolerated up to 1.6, but beyond that, we took affidavit from the contractor. They will put extra thickness at the BC level on from their own cost, because we are not going to pay for that. And it was required at this. Initially, when we asked JMF from the contractor or technology partner, they gave their JMF, but it was, the lab was not NABL. So we introduced in between the JMF should come from the lab, at least from NABL. IIT fine, CRRI fine, and NIT fine. But other than these three, if you are getting your reports, get it from NABL lab. And it was again introduced in between, and NABL labs, it was not just quoted, it was visited by a team of UPRD, whether it was sufficient to do the work, whether they are record keeping, where they are sample handling, and they are doing the job of the JMF were proper or not. It was done from UPRDA team, including few engineers of the field. Next, mixed design. I'll not quote much because we know what we want and how to do it. So it was explained. So next, take next. How you take next? Go further. These are the few results. If you can see, I have taken the results from pilot project only. And JMF was from IT Roorkee and from additive provider. If you see, cement percentage was 5.445%, and additive was decided, and it was doses. This is just an example how it was used initially. And if you see the UCS, here we have mentioned it, for 7 days 4.77 and then 5.26 for 28 days. It means it is around 4.5 and maximum it is 8.65, 8.77 in one road. As I said earlier, till date, we have already constructed completed very few roads, but BC was done around on 30 roads, and we have stabilized plus 100 roads, and kilometer, you can say we are reaching to 1,000. None of them have any UCS even touching 10. Trial stretch as mandatory, we take doses and same doses as JMF, and then we compare the results, and then we give clearance for the further work of the FDR. Here one thing is important. For trial stage, we only allow reports from IIT or CRRI. And as we know, different tests have been mentioned, but it was very difficult for us how to control the whole process and test in the field. We know
The PMGSY QCR does not have a chapter for the FDR testing. So we as NIRDA has given one book and a few tables were there. We asked them to record the things there. And next. Then we did one thing. We got developed one software and we gave the name of that software is Uttam FDR, where we try to control the whole thing. And whatever we are doing today, we are doing with the help of Uttam. Contractor has to use update on Uttam. Department will see your daily reports from Uttam. And in testing, there are tray tests for validating the defined doses of cement and additives, if powder form, and if it is in liquid form, it will be mixed as ANT said with the tanker. And till date, I don't know how to check in between, but what we are doing the same thing. If you define a tanker is going to cover this much area, 100 meter, and this much cubic meter of the work will be done. So after doing the work, it will be checked again whether the all water or all additive with water has been consumed by the same area or not. This is one. Number two, the speed is defined for every minute 3 to 3.5 meter of the movement of the machine, and we can check there what is the moisture inside. We are doing that, and tray test we are doing for the cement and powder. But we are asking contractor and PIU to update on Uttam portal few tests. We have given two group name of the group, one mandatory test, one statutory test. During construction, OMC, NMC is required, cement quantity and additive quantity is required, and FDD is required. 100% has to be, and that has to be recorded. If it is not, it will be failed. Either JMF has to be revised or trial stretch. If there is any mistake by machine in machine operation or something, he has to go again for the trial stretch. And after statutory test, we have said 7th and 28 days UCS, flexural, durability, and residual test. It will come after a few days, 7 and 8, 10 days. And we control with the next. I will skip this because this I already have given. After doing tests, few tests, we have ensured that because we have observed, we have incorporated in between the use of state quality monitor, Tier 2 quality monitor use in the field for the FDR. And in that, we have started using state quality monitor during operation after trial stage for the rest carriageway. It will be started in presence of state quality monitor. Why so? We know FDR, if we construct the stretch, it will be very difficult to correct it if any mistake is there. Like if you by mistake your super elevation is not there, if widening is required, if it is not there, if you have to construct culverts, you should not leave that space because heavy machines, movement of the heavy machines are difficult. So we ensure that the whole length with the subgrade as well as shoulder should be completed. All the culverts should be completed. And then subgrade density. It is very important. It should be 100%. It will be checked by state quality monitors in every length, every kilometer for the whole length. And then
availability of machine, availability of additive as per the our requirement, IRC accreditation, and then only SQM gives a start to the work. Second, most of the contractors started saying they are using so much money for the stabilized layer, and if you see, they can construct 400 to 600 meters of length, and within 10 to 15 days, almost 5 to 8 crores rupees incurred by them. So they asked us to expedite the payment also, because payment to the contractor is very important, as well as getting the quality work. So what we started doing, we said, okay, after 7-8 days, if you are confident enough that UCS of the core will be 4.5 plus as we require, then we can put one state quality monitor. A state quality monitor will take core of each 250 meters, any minimum 4 cores, it may be 5, and take average. And if it comes within range 4.5 plus, means that stretch is okay. Minimum 7 days curing are there. This test is over. Now they can proceed for the SAMI and then BC. So this, why I explained this procedure, getting quality test and quality work executed, as well as important is paying to the contractor whatever their quality work has been completed. So we match this with the help of Uttam portal. Uttam portal, go to for the slides, 2. See, this is the dashboard which we are having. We can see how many contractors are there, what are trial stretches and job mix, and where how many equipments are there, how many sample collections are there. We control with this, and test reports, as said earlier. Next. Here we also see where job, because in job mix, if you get job mix report as well as trial report of the statutory, it takes minimum 2 months. So expediting the work is also a challenge to us. What we started following the people. If you see, job mix formula is cleared, and I have just given a screenshot here. And 20 days have gone. 20 days means more than 60 they have consumed 20 days, and they should go for trial stage. Maybe they are not ready with the equipment. And let me tell you, there are 79 contractors today in UP, and we identified 16 contractors who are not having machines, and they could not procure it from even any vendor on rent. So we are just following them. Taking work, quality work, it is a challenge for us. And it was 5,500 kilometers. So we started, we took help of this software, and this software, you can see it daily. It will give you the whole picture. Next. This is again, you see, not only for us, for contractor, if they can put their bill here. And if every test is over, we proceed with payment. And we monitor through this. This slide is just an example. So whatever I have given, it was an experience in UP. Initially, we were not having sufficient machine. Initially, we were not having any technology details, additives,
we never knew what they are going to do, but today, at least we have data of all 9 additives, what are their results, how they are performing, how many days they are taking in winter as well as in summer. In winter, we allowed them watering with tanker, but now we asked them to use jute bags. These are the experiences and we are still learning. We are taking help of the IITs, CRRI, even we are learning from the contractors. Because by doing their work, they have improved in so many areas, especially the deployment of the manpower. Again, I will come back. Every testing is defined because I was asked not to elaborate the test. I'll just give few things. Test frequencies are there, but we have made it compulsory for each stretch, either of 250 meter, 150 meter or 100 meter. Core casting will be there. Cube casting will be there. All the tests will be there. It will be recorded and we are checking it time to time. And the parts, even we have kept control on the cement and additive in and out. It is the job of the contractor. But we have, because additive cost is high in our case. Our rate is 360, 3760 rupees. So we control that also. And for this whole work, Uttam portal is giving us help. These two things why I have combined. You cannot complete the work without your test and speed of the work as well as the control of the up to the payment. So thank you very much from our side. These are the pictures from our real projects, which you have already seen. These just stop, back. This is the completed road of the Chitrakoot, which you have seen outside. Next. We have, I can say, our project, conventional project, when we submitted of the same length, it was of 6,600, 6,600 lakhs, yani, sorry, 6 crores. And now it is of 5,300 crores. These is the saving in amount, money, which we have got converting the conventional into FTR. Thank you very much.
Thank you, sir. We can take 2 quick questions. Any questions, please?
Sir, will UCS of 10 be allowed in UP or that road will be allowed?
No, why not? No. 10 and above means we are going towards rigid payment. No, it will not be allowed.
So any remedial measures, sir, or it will be failed?
So far, we have not considered this, and if anything will come like this, definitely we will take help and do the first thing. You have to remove the things. So far, but we have not achieved, so we have not taken any decision on this.
Any questions from the audience?
Okay, thank you.
Thank you, sir.
Thank you, sir. Now I request Dr. Suresha Yasan, Associate Professor, NIT Surakar, to hand over the memento to Brijesh Dubey, sir, as our token of gratitude and love. Also, if Chandrasekhar sir and technologies is there. Okay, sir. Kindly accept our memento. Thank you, sir. The next topic for presentation is FDR technology, KRFB experience. The session will be handled by an expert from KRFB. To introduce the speaker, I would like to welcome Shri Ebin Sam, scientist, NATPAC, to the dais.
The next presentation is by our KRFB executive engineer, Sri Umar sir. He is an executive engineer in Kollam district, and he has undertaken FDR projects in association with KIIFB. I would like to welcome you, sir, to the dais.
Actually, I have a technical presentation as such, and I cannot present here. We are new to this FDR. We have just started this FDR project, and I was just here to introduce the project, as it is the first project. Just to introduce this project and have some some difficulties faced in the site. Just to introduce that, I have come here as it was asked to me to present the first project. I have come up here. Actually, the FDR project under KRFB is a KIIFB project, KIIFB funded project. And in Kollam, the 4 roads are included in this FDR project. These roads are this Pallimuk-Alimuk road, about 14.8 kilometers. Pallimuk-Mukkadavu road, 11 kilometers. Pattanavaram-Enath road, 14.9 kilometers. And Ambalangunna-Poriyadam road, 7.16, about 48 kilometers road. And all the study for these roads were done by the KIIFB engineers. And as an SPV for this KIIFB project, KRFB is has taken up this work. The Pattanavaram-Enath is the first road in Kollam where FDR work is started. The proposed carriageway is 5.5 meter with 0.75 meter interlock concrete on either side. And drain or Irish drain, as the case may be, will be done on either side. The first challenge was to remove the utilities, as many of the departments in Kerala may be introducing KIIFB projects. All the Kerala roads will consist of a lot of utilities. Unlike in the north, here too many utilities will be in the road. KSCSTE post, UG cables, water lines, etc. And while removing, to ensure provision for cross-laying of utilities in future, pipe ducts were first laid at about 250 meter interval. As it will be difficult to carry out rectification works on FDR works, KWD pipelines cannot be allowed under the carriageway. And the KIIFB guidelines also says that pipeline should not be in other conventional roads also. And to facilitate the shifting of utilities, the required amounts were deposited with the KSCB and KWA, and for timely removal of these utilities is a big task in Kerala, as you will be aware. you have to persuade each and every department and continuously monitor to get the utilities shifted in time. It was a big task. And in the first road, a lot of persuasion from the local MLA also was needed for timely completion of the. In Pattanavaram Enath Road, about 11, the FDR is in progress, and as the machineries were reached the site in advance, and to avoid the idling of machineries, the FDR was started first, even before starting the culvert works. That is a negative thing in my mind, but it was we were forced to allow the FDR to be started first. And another thing is, as the KIIFB had proposed the FRL for the final, the finished surface. But while doing the FDR with existing premises, to achieve the same, some difficulties if we are facing, and we may require some additional material. And we were. I came here with the intention to get some inputs from the experts, how this can be met. Whether this will hamper the FDR, the term FDR as such, because it was said that in the FDR, the existing road is, we are avoiding any additional material, and we are utilizing the existing payment. And as per the experience, the ideal condition will be always to do the utility shifting and culvert works to be started. And this is the thing I can just tell to all the Kerala departments which are going to start FDR in their project. And on many of the points, I want some clarification from the sessions. So I'll be here today and tomorrow to get the clarification from various experts in this field. Thank you.
Charlata R, Professor, College of Engineering, Trivandrum, to hand over the memento to Sri Kumar Sir, KIIFB. Thank you, sir. Thank you, ma'am. Now we'll have a short tea break. 15 minutes tea break. Please be there.
ഇവിടെ കേൾക്കുന്നുണ്ട്, എനിക്ക് കേൾക്കാം, പക്ഷെ ഇവിടെ കേൾക്കുന്നില്ല, ഹോളിൽ കേൾക്കുന്നില്ല. ഇല്ല, ഇത് കേൾക്കാൻ എനിക്ക് വന്നിട്ടില്ല. ഇത് ഞാൻ എന്താ പറഞ്ഞേ? വേണ്ട, ചോറ് വെച്ചിട്ട് ഇത് സൗണ്ട് എനിക്ക് കേൾക്കാം. No, no, I can hear it. Like people can hear, but let me check sound.
ഇങ്ങോട്ട് വരുന്നില്ല സോറി.
ഇതിന്റെ സെറ്റിംഗ്സ് ഹെഡ്ഫോൺ അല്ലേ വേണ്ടേ? Headphone or select?
Can we use this one?
Yeah, definitely.
Yeah.
I think it's good. Yeah, fitting the collar mic is only one. So you can share the.
You have the collar mic?
Yeah, you're having the collar mic, sir. So one can, you can both, if both are presenting.
So I'm just going to talk 3 minutes.
Okay.
Once he is done, I will.
Yeah, so you can share the use the podium. So video എന്ത് ചെയ്യണം?
അല്ല ഇത് രണ്ടും കൂടി
ഏതാ?
വീഡിയോ ഇടുമ്പോഴത്തേക്കും അവർക്ക് സ്വിച്ച് ചെയ്യാനാണോ?
ഇല്ല ഇല്ല, അവർ
ഇപ്പൊ ആദ്യം കടാരി കേൾക്കും. ആദ്യം കടാരി അതെന്ന് പറയുമ്പോൾ 10 പ്രാവശ്യം ആലോചന
കേൾക്കാം. ഇവിടെ വന്നില്ല. അപ്പോഴിത് എന്ത് നേരത്തെ വന്നിട്ടുണ്ടായിരുന്നല്ലോ നമ്മളാ പ്ലേ.
ഫോണിന് കുത്തിവിടും നമ്മള് കേൾക്കണ്ടെങ്കിൽ.
ഫോണ്
ഫോണിലത് കുത്തിവിടും.
ഫോണിൽ എന്ത് കുത്താൻ?
ഈ ഹെഡ്സെറ്റിന്റെ കുത്തിട്ട് അത്
ഈ PPT ഇതിലോട്ട് കോപ്പി ചെയ്താൽ മതിയാമോ? ഇല്ലല്ലോ, സൗണ്ട് ഇതിൽ കണക്റ്റഡ് അല്ലല്ലോ.
അല്ല ഇതിനകത്ത് കുത്തി കഴിഞ്ഞാൽ കേൾക്കാം.
ഇല്ല, ഈ ഹെഡ്സെറ്റ് ഇവിടെ കുത്താൻ പറ്റത്തില്ല, ഇത് ഫ്ലാറ്റാ. എവിടുത്തെ സെറ്റിംഗ് ആ മാറി? മ്യൂട്ട് ആണല്ലോ. അതിന്റെ സൗണ്ട് ഇതാണല്ലോ, അതാണോ?
മ്യൂട്ടാണ്.
മ്യൂട്ട് അത് ഇവിടുന്ന് എവിടെയോ സെറ്റിങ്സ് മാറി കിടക്കും. ഇത് ഓരോ പ്രാവശ്യം നമ്മൾ ഈ ടെസ്റ്റിംഗ് ഇനി എല്ലാം പോവും. ചായ കുടിച്ചിട്ട് വന്നൂടെ? ഇവിടെ ഇരുന്ന ചേട്ടൻ കഴിച്ചോ? ഇല്ല, ഞാൻ കഴിക്കുന്നു. ഇത്രയും പേരുണ്ടോ? എല്ലാവരും പോയോ? നമ്മൾ ഓർമ്മയില്ലേ? ഇതിപ്പം ഇത് ചെയ്ത് കഴിഞ്ഞിട്ട് പിന്നെ ഇതെങ്കിലും പോകും. പിന്നെ പോവാം, ഏതെങ്കിലും ഓർമ്മ ചെയ്താൽ ഏത് മൈക്ക്?
The next generation of good roads are critical to support the modern economy, markets, and lifestyle. Globally, high-quality roads use cement soil stabilization to enhance the strength of the soil bases. For sustainability in the 21st century, future green roads would need to
Sir, your just a second.
അല്ല ഷെയർ മറ്റേ ടൈപ്പാണ് അതിനുണ്ട് ഇപ്പൊ കുഴപ്പമില്ല
ഇവിടെ കേട്ടോ ഇവിടെ കേൾക്കാം അത് കേട്ടാ മതി എവിടെയും കേട്ടാ മതി ആരും ഇല്ലല്ലോ എല്ലാരും എന്നെ വീട്ടിൽ പിന്നെ ആരും നിൽക്കത്തില്ല അത്ര മതി എവിടെയും കേട്ടോ ഈ ഹോളില് വരുന്നില്ല അതാ എല്ലാ ഓപ്ഷൻസും വരുന്നില്ല അതാണ് വിളിച്ചത് എവിടെയെങ്കിലും സൗണ്ട് വരുന്നുണ്ടല്ലോ
കുറച്ചുകൂടെ
വന്നില്ല ഒന്നിനും പോലെ അവിടെ താഴെ മോളിൽ തോന്നിയതാ തിരിച്ചിങ്ങോട്ട് കയറുമ്പോ ഇത് മ്യൂട്ട് ചെയ്യാൻ മറന്നു Videos in the
അതെല്ലാം ഷെയർ ആണോ ഷെയർ സ്ക്രീൻ കൊടുക്കണ്ട ഷെയർ വീഡിയോ എടുത്ത കുഴപ്പമില്ല
അത് പവർ പോയിന്റ് ഇടയ്ക്ക് കാണിക്കാം ഇതിന് സൗണ്ട് ഇല്ല ഇതിലുണ്ട്
Today, organizations from various industries throughout the world seek for a multidisciplinary testing facility in alignment with global standards and technology advancements to meet the increasing demands of their customers for quality reassurance. We are Matter Lab. A wholly independent professional and technical services provider for everything concerned with quality and performance.
മൈക്ക് കൊണ്ടുവന്നോളൂ
The next session is about to begin. The next. Hello, mic testing. TV mute. Mic checking. Okay, TV off. Echo. Hello, hello. Okay. National highways in Kerala. The session is handled by Vishwasamudra. In this regard, I would like to welcome Mr. Krishna Ramella, Vice President, Stable Road, Vishwasamudra, and Mr. Nagendra Reddy, PhD Scholar, IIT Hyderabad, and technical advisors of Vishwasamudra to speak on their experience in Kerala. Regarding the Vishwasamudra, it is one of the first companies to start FDR and soil stabilization in road constructions in India with Stable Road, an exclusively German additive that helps in reducing the use of aggregate water and thereby project cost and time. We welcome you to the stage.
Echo. Solve.
Solve now. Okay. Yes.
Hello. Yeah. Good evening, everybody. My name is Krishna Ramella. I'm Vice President, Stable Road from Vishwasamudra. We're based out of Hyderabad. And before starting, I would like to remind my beloved CEO, Mr. Srinivas Vallabhaneni, the man behind this legacy and hello. You want to give that?
Hello.
Yeah, you can speak.
Hello. Okay, fine. Right.
Is it okay?
Yeah.
Yeah, our beloved CEO, Mr. Srinivas Vallabhaneni, is the man behind this, getting this technology into this level. And unfortunately, we lost him while he was at Germany. He's a youngster, he's an entrepreneur, and he's the man behind instrumental in opening up the FDR into the entire country with the support and help of V.R. Raghavan sir, and also my other colleagues, Nitin Manavji and LSR Amit Singla. Himanshu is not there from Zydex. Prashant is there. And other colleagues from across the fraternity. Ridgen, Bomac, Sanjay Bajaj from Ridgen. We all have started our journey very, very long back. And coming to Vishwasamudra, we started our journey 7 years back. Our chairman owns the India's second biggest seaport, Krishnapatnam. Prior to this, we ran pillar to post in India to implement this technology. The first one we approached was V.R. Raghavan sir. And then that time V.R. Raghavan sir was, he was little skeptical about the technologies, etc. But later on, he spoke to the principals in Germany. This technology is engineered and manufactured in Germany, Stable Road. Then Mr. V.R. Raghavan sir immediately he put us to the CRRI Guru Vital, And we started off the roads with the highest traffic, MSA, close to 280 MSA at Krishnapatnam Port. That is right now running into the 6th year with zero maintenance so far. Spanning that, immediately Veeraraghavan sir, after he got the confidence, after speaking to our principals in Germany, he immediately recommended, let's start in Kerala. And that is when we started in 2018, the Anayadi Pajakulam Road. And this is, I think, running into 4th to 5th year, which is going strong. And we have several studies conducted by IITs. And it is really, I think this has opened up the eyes in Kerala too. And today, I would like to say we have already completed around close to 750 lane kilometers, which is close to 25 lakh square meters. The ongoing projects, what we have is around 600 kilometers, which we are doing right now, which are in progress. That is actually 22 lakh square meters. The upcoming, which we already in the order, is going to be around 35 lakh square meters. We have done the Hyderabad International Airport, the main runway. We have completed 2 years, and the taxiways. And in every NOTAM, so far it's zero maintenance. We have the biggest, the heaviest aircraft which landed very recently at Hyderabad. And while this is happening, there were several department, I think when we started the Anayadi, all your engineers from PWD and PMGSO, they visited Anayadi Road, and then we gave the training sessions, workshops, everything. And while that is happening, we also did the Hyderabad city roads, where we recently had the Formula E racing on the stretch, which is right next to the lake. And your high-level committee, which was decided by the then minister, PWD minister and PWD secretary, have visited Hyderabad, and then they again came back and gave a report, and then Kerala government came up with a kind of a government order that we need to implement this technology. Following that, your high-level delegate committee had visited Germany, and then they have visited the roads which were built at Autobahns using a stable road. And then later, during that committee, I think Principal Secretary, Dinky Madam, and others were present. And then they went and visited the Highway Authority in Germany. And then they really put out good words about a stable road. And today, let me tell you, sir, worldwide, we are doing, the last year, stable road has touched 7,000 kilometers. And nobody else in the world have ever reached that kind of a scale. And during the continuous 3 years of COVID, every year, stable road touched 4,000 to 4,500 kilometers. All the works done by the partners around the world. And all this has happened just because the committee, commitment, the quality, the kind of deliverables what we are giving to the world partners. And today, we are trying to scale up the Indian market because comparing to the world, we fall into very, very small number. So, adopting this technology into India is so difficult because of these authority engineers, independent engineers, or consultants, whoever. And that is why Government of India, under Nitin Gadkari ji, General VK Singh, they're trying to give an initiative directions to make sure the technology should reach the best technologies which are present around the world that need to come into India. In that direction, all my colleagues, Nitin from Zydex, be it from LSR, my colleague Amit Singla, and other partners, we are striving to get to that level and then give the program sessions, workshops. And I would also like to say we are partnered with major, almost all the IITs. The research and development is still going on. The kind of amount we put in every year for research and development, R&D, is humongous. And we are taking it to the next level. And with all your support, I wish this is going to go to the greater extent with all your support. Thank you very much. I have my colleague Nagendra, who is going to take over on the technical session. I also have today we will be getting we have 3 HAM projects in Kerala, 8 lane. That is one is in Kannur, Paravur, and then Kollam. And we also have in Jammu. We are doing one greenfield seaport, which is massive port in Andhra Pradesh, and we are doing around 5 fishing harbors. And we got recently 2 projects in Mumbai Metro in the heart of the city. And I have my colleague Deepak Pandeji, who is heading the complete UP project. We are doing around 300 kilometers. He'll be able to answer if you have any questions. He's there tomorrow also. My other colleague is coming down from Kollam to give you the complete gist of what is happening in Kollam, Kannur, how we are doing, how we are adopting international highways. Thank you very much for the opportunity. Nagendra, please take over.
Good evening, everyone. Myself, Nagendra Reddy. And I would like to introduce myself as a student into the research since 3 years on this technology. So before going into the presentation, a small corporate video.
Next week.
Next week. Those, all the case studies, whatever we have done across the our country. So you can go for the next one. Yeah. It has been defined what is full depth reclamation or full depth recycling in the morning sessions. But I want to define soil stabilization as well. So soil stabilization is a process where only soil without any aggregates is used to form a stabilized base layer. Whereas in the case of FDR, we'll be using the existing pavement crust materials to form the stabilized base. So in both the cases, the process is similar, except that the material going to be used is soil in the case of soil stabilization and the existing pavement crust material in full depth recycling. So in both the cases, we use cement along with stable road additive. And it was a question since the morning, what is the role of the additive and what CCATs would do. Before that, this additive is a natural mineral additive. See, what happens if we do only with cement? Just imagine the specific surface area, what we consider while calculating the quantum of cement in the case of a concrete. This is a different case. I can call it a semi-bounded, not a complete bounded, because the percentage of cement is going to be used as 4 to 6%. So that is not in the case of a concrete. So with respect to time, the loosening of particles may happen if at the cement percentage of 4 to 5%. With respect to time, the loosening of particles may happen. What this additive, particularly stable road, does is there will be formation of extra CSH gels. So you might be aware of CSH gels during the pozzolanic reaction. Basically a civil engineer. So during the pozzolanic reaction, there will be formation of CSH gels. With this additive, there will be extra CSH gels, which will refine the pores such that particles are bonded together and resist the weathering actions and retain the strength with respect to time. So that is the major criteria. Getting an UCS of 4.5 or more than that, 9, 10, doesn't matter. Retaining that strength with respect to the weathering actions is the primary criteria, and the additive does do this. Next slide, please. So I will quickly run through this because all the advantages have been discussed in the morning sessions. Next. So this product is based off Germany, and it has been used in more than 20 years across the world. Next. And these are the approvals and validations what the product has. These IRs accredited, and various IITs have conducted research, and present research is carrying out at various IITs. And this is a process. I will skip this as well. Next. Yeah. So these are the brief of projects what we have executed with this technology. Coming to the ports, we have executed at Krishnapatnam port. This is a pilot project. I'll be discussing in the next slides as well. And other is Katupalli port at Chennai. And regarding airports, we have done for main runway and taxiways at Hyderabad International Airport. And we have already executed a national highways of 2 and state highways of 3, which one including UP and one in Kerala. So, and for city roads as well in Hyderabad. And coming to rural roads, we have done in UP and Andhra Pradesh as well. Next. Yeah, these are the gist of projects which I was talking about. Next. And these are the ongoing projects. Pertaining to Kerala, we are doing 3 packages for a National Highway 66. One is in Kannur, other in Kollam, other in Paravur. And also in Jammu, we are working for a National Highway 244A with this technology only. And for one in Manipur. And we are doing around 300 kilometers in UP RRDA in batch 1. And this is the summary of strength parameters, what we have achieved, the UCS or moduli value, and right side column is the aggregate quantity, what we have saved in the percentages. And before you question me, I will clarify. You may be surprised of the strength like 9 MPa, 8 MPa, and someone is asking like, won't it be a brittle if it goes high? Yeah, this is not a 7-day strength. Whatever the projects we have executed, we have been evaluating seasonal wise or the duration wise over a period of time, 2.5 years, 3 years. That was what I am speaking about. So with FWD, we have done performance evaluation studies, and one more thing is that modulus. Modulus is the main criteria which we are taking into the design. UCS is a parameter which is related to the modulus. Modulus being tough to evaluate in the laboratory. As a part of this, we have selected UCS as the criteria, which would be easy to perform. But I prefer the modulus evaluation would be the exact criteria to say whether the pavement has achieved what we have considered in the design or not. My question is, we are taking a modulus of let me say 1400 to 1700 as Professor Vishnu was telling, or it may be 5000. There is a question in the morning session. So based on the performance studies, we can go for a 5000, right? Or if you have considered a 1400 moduli, you should be able to show that moduli value in the field. How to show that? With non-destructive testing only. Because UCS is one of the criteria. UCS is one of the criteria, which again is related to modulus. So we'll be using an equation of 1000 into UCS so that the modulus is so and so. But the exact way is to perform FWD or LWD, lightweight deflectometer. And I'm proud to say that VSC holds 5 LWDs and 1 FWD machinery, and we have been continuously evaluating whatever the projects we have executed on behalf of various IITs. Next, please. So these are all the ecological benefits what we are able to contribute to the environment. So we have saved almost 7,300 tons of carbon emissions for the executed projects. Next, please. Yeah, I will just take 10 minutes, please. Yeah. Next. So this is the pilot project which we are talking about. We have first executed at Krishnapatnam port for berth roads. So where the traffic is more than 200 MSA, and it has been studied by CRRI for a period of 3 years. And as of now, the age of the pavement is 6 years. Next, please. So this is a comparison of a conventional crust against a stabilization crust. In some of the stretches, we have done full depth recycling, and some stretches we have done soil stabilization. So you can see the surface at present as well. So after 3 years, there isn't any distress observed. As a pilot project, we have tested with a thin bituminous layer and without BT as well, how the stabilized base would perform. So next, please. Next. These are some of the pictures of the pavement over there. Next. Yeah. And this is the core. On the right side core, you can see a thin bituminous layer of 10 to 15 mm. Yeah, the right side picture. So on the left side picture, you can see without BT as well. And this for another port at Chennai, where we try to maximum utilize the locally available material. So there dredged sand was available in more quantum, and we blended with carted morum in order to achieve the physical properties as per our requirement. And this is the stabilized base right side picture. This is a finished road. And these are the cores. Yeah, coming to airports. Yeah. We have executed main runway and taxiways with FDR technology, outside full depth reclamation only. So these are some of the figures, what we can see in the slide. The beauty is that we are able to complete the runway, main runway stabilization portion in 39 days. So this is one of the credential. And next slide, yeah. So you can see the crust here. Actually, the proposal was that they wanted to reconstruct from the GSB layer. So GSB over that FCR, if it is like a WMM only, fine crushed rock, and over that BT. What we have proposed is, we'll leave the GSB as it is, that would be a residual GSB, and we will mill the BT surface and recycle the FCR layer in order to form the stabilized base. This is the FDR. And with this, only aggregate we used is in BT layer of 125 mm. So we have saved a lot of aggregates and a lot of time as well. Next. These are some of the execution peaks. Yeah. And these are finished main runway. Yeah, this is right. Here the criteria is not a UCS or modeless. PCN would be the payment classification number is criteria for evaluation. And design value is 71. We are able to achieve a PCN of 118. I would say it is a record as of now. So you can see the comparison of PCNs as well, with that of the conventional and with that of the stabilized portions. So these are the cores. And for city roads, we have done for NTR Mark, as Krishna sir was telling, like F1 racing was conducted over this stretch. This is the stretch. Next. Yeah, next please. And this is one of the road, city road in Hyderabad. Similar thing. Yeah. Next. Coming to national highways, we have done in Andaman. As you know, that is a different climatic zone where we have used existing soil with a blend of 30% of aggregates. Next, please. Next. Yeah, this is the condition of road after 2 years. Next. And this for North project in Bihar. Even Bihar has a large scarcity of aggregates. Even in the recent time when we visited Jharkhand, they are also willing to go with FDR technology. Next, please. Next. So in the left side picture, you can see laying of geosynthetic paving fabric, which is used as a SAMI layer. And one more thing regarding this SAMI layer, actually, I prefer to go with a geosynthetic paving fabric or a chip seal. So again, aggregate interlayer, as per my perception, this is my perception, aggregate interlayer is a weak layer which would be sandwiched between the two strong layers. Because over the aggregate interlayer, you will be laying a bituminous layer of 3000 modulus. And underneath we have a stabilized base, which is having a modulus of more than 3000. So in between a thin or 100 mm of aggregate interlayer would get sandwiched, and if there isn't any lateral confinement, it would disperse, leading to the cracks in the bituminous layer. That was the case which happened in UP, which Dubey sir was telling about. Yeah. Next. And for Purvanchal Expressway Service Road in Uttar Pradesh, we have done FDR. Yeah, next please. Next. Yeah, this is the Anayadi Kudal Road which we have done in Kerala. This is also FDR. What the problem we faced is oversized material, because if you see the size of more than 80 as well. So next please. So this is the distressed pavement before taking up of the work, and this is the execution peaks, and this is the stabilized base, and this is the finished road which we have been studying. After 6 months we have done FWD, and after 1 year, and after 2.5 years. Next please. This is after 2 years. So we conducted FWD surveys and evaluated the moduli value. And the thing is that the moduli has increased with respect to time due to the lateritic and the primary pozzolanic action. Next please. And this for one of the road in Punjab. You can see the distressed pavement condition before execution, and right side picture is after completion. So that is the case what we have dealt with. And in some of the cases, we may require borrow material, particularly this type of cases. So that is partly FDR, and I can say partly soil stabilization. FDR means exactly utilization of the existing pavement crust material itself without bringing any borrow material. In the soil stabilization, we'll be getting soil from the borrow area and doing stabilization. So if it is the case, we'll be getting some borrow material. I think someone was asking in the morning how to maintain the FRLs. It would be tough for KIIFB or KIIFB who are handling the projects. In that case, borrow material may be required to maintain the FRLs, whatever you design for. This again for Punjab, yeah. Yeah, this for rural roads in AP, in Vijayawada. This also has completed almost 5 years. Yeah, next please. Next. These are some of the execution peaks in AAB works where we have executed more than 500 kilometers in Andhra. Yeah. And these are some of the execution peaks at Kannur for a national highway where we have used only soil without any aggregate. So you can see rightmost bottom picture that the core is of 24 hours. It's not of 7-day or 28-day. After 24 hours, as a research activity, we have tried to extract a core and how it looks like. That is the core. And particularly here, the soil is of lateritic, and with a minimum dosage of cement content, we are able to achieve a targeted UCS value. And we have been executing in Kollam and Paravur for national highway projects, almost package and NATPAC.
Thank you. Thank you. A quick 2 or 3 questions from the audience, please.
Hi, sir. Thank you for the explanation. And then I'd like to know whether you have used any drainage layer in the national highway projects in Kerala.
Drainage layer?
Yeah.
For national highway?
Yeah.
Yeah, we are providing.
How much thickness?
So 150 for the service road, and it's 170 for the main carriageway. As per the design only, as per the design. See the thing, one more thing I would like to say, even the design of GSB is a question mark because apart from the structural satisfaction, if I say that even if I remove the GSB layer structurally with SSB and the bituminous layer, it would be satisfying. But functionally, we are providing a GSB layer for the drainage purpose. Even in that also, as code says that it should be designed for a construction traffic or 10,000 ESAL, whichever is maximum. So according to that, we are getting a thickness of 170 for this national highway.
You use this stabilization only for
Base layer.
Base layer.
Yeah.
Okay. And then design, have you considered the GSB modulus also?
Yeah.
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 Thanks.
Thank you. Any other questions from the audience, please? Okay, I think there are no more questions.
I also wanted to ask the same question which Arun asked. Like,
Okay.
Suppose if you remove that ESB layer, what is that the effect you are expecting in that?
Meaning, sir?
Like, suppose if you are not.
If I remove also, even with the stabilized base thickness being increased by 20 mm, structurally it would satisfy.
But functionally, like
Functionally,
the drainage layer will.
Yeah. Even in some of the cases, we are going to try with geocomposite in place of GSB.
Okay. My question is like, whether that you said for Kannur stretch you used only the gravel and
Only the soil. Yeah.
Gravel and
Exactly.
cement alone. No chemical you used.
No, cement along with chemicals, sir.
Chemicals.
Everywhere.
Do you expect that that will the arrest the water flow to the bottom?
Yes, sir. Exactly, sir. It will refine the pore and make it impermeable such that water won't penetrate. Yeah. And one more thing is that
in that case,
Coming to that point, sir. When we are able to provide the subgrade top above 500 mm of groundwater table, there won't be any capillary action from the bottom. So there will be water seepage from the top. Even that we are arresting with this base layer. But due to some circumstances like authority engineers, as you know, they will stick on to whatever written in the code. It's there in the code, you have to provide that. So we are trying a lot to eliminate that and provide
okay, that's clear.
Yeah.
I have a second question is,
Yeah.
Your targeted UC system is 5.5 environment, right?
Yeah.
Some of the cases.
Yeah.
In most of the cases, it crossed 7.5 or 8.
7, 8, yeah. It is not a 7 day or 28 days, sir. It is over the period. For some of the values, it is after 2.5 years. After 2.5 years.
But you are not expecting any difficulty with the higher?
No, sir. No, sir. There won't be any, cracking or so.
So far.
But we have to see if it exceeds 10, what happens is a question mark. Because as of now, we didn't exceed any such a value. That is also a part of, again, research activity. So, and one more thing, being a cementatious base, cracks are inevitable.
Correct.
And we can just postpone the cracks with a crack relief layer. That's it.
And you are showing only the savings of aggregate, okay? It is 70%.
Yeah, in percentage, yeah.
Percentage. What is the overall cost reduction you are expecting?
If it is the FDR case, sir.
Convention, compared to the conventional?
At least 80%, sir. At least 80%.
I'm not talking about the aggregate cost.
Cost perspective, initially maybe 5 to 10% less than that of the conventional. But if you see the life cycle cost, it may go up to 20% because the maintenance would be reduced.
Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Vishwasamudra, for the exciting presentation.
Yeah, and tomorrow we'll have our entire team, NH and then UPRD. We have the team, so we'll have a lot of question and answers answered that time.
Okay.
So
okay, there is an open forum also. We can interact.
Yeah, right. Yeah.
Thank you.
Thank you.
The next presentation is by SIDEX regarding the role of additive in FDR. The presentation is handled by Mr. M.G. Prashant, Vice President, Roads Division, SIDEX Industries Private Limited. SIDEX is established in 1997, specialty chemicals company with the purpose of innovating for sustainability. SIDEX is deeply committed to the sustainable chemistries that ensure greener future for everyone. Over to you, sir.
I can see from here. Good evening. How many people are from rural roads? Could you just raise your hands, please? How many are from PWD? Thank you for your attention. I was under the impression that you guys want to go home soon. Coming back, Zydex is a patented nanotechnology chemical. It is patented by Dr. Ajay Ranka, who is the owner of this company. It's a made in India product. And we have our operations in 40 countries worldwide. And we take pride in telling this on every platform. So we are a made in India company for the world. I'll just go around a couple of slides. Everyone knows what an FDR process is. Lot of people have already talked on this. Let me just get down to the brass tacks of what the additives, role of the additives is on the FDR basis. I'm talking about not only on the FDR basis, but also on the layers at the top, which is the bituminous layers. Next, please. I'll be talking on Zydex product line for FDR, prime coat, and the bituminous layers. I'll be talking on the basis of our mix design for the National Highway, State Highway, the quality control tests which go with this, the execution methodology specifically concentrating on the prime coat and the SAMI layers, a typical case study photographs on the kind of works that we have been executing in India, and the conclusion. Next. Since morning, Dr. V. Raghavan was saying water, water, and water. Water happens to be the biggest admixture during construction, but it is the biggest cancer post-construction for all our buildings or roads or any of our structures. So how does water actually cause destruction in a pavement? Water settles down, goes through the side drains into the subgrade. It goes through the cracks opened up by the hardening of the asphalt into the subgrade, washes off the fines, thereby leading to consolidation of soil, leading to potholes. So the slide speaks everything by itself. Next. Zydex comes out with 5 different chemicals, which is essentially silane based and polymer, acrylic copolymer based. First one is terracil, which waterproofs soil at the molecular level, leading to soil stabilization. Zycobond is an acrylic copolymer, which binds the soil particles together, leading to soil stabilization and preservation of the pavement. TerraPrime is an admixture which we use in prime coat, which reduces the curing time of the prime coat and thereby reducing the cost for the layer. Nanotack also is used in tack coat, whereby it enhances the bond strength, leading and also gives savings to the contractor. And Zycotherm is an admixture which we use in bituminous layers. I'll come down to the each level of each layer of these chemicals in the next few slides. Let us look at today nanotechnology is supposed to be the buzzword across the world. What is nanotechnology? At what level are we operating upon? And how does it suffice us in our construction activity? Now, if you look at the left side of the slide, you see the first one is a water molecule, which is H2O. Essentially, it's got a molecular size of 0.18 nanometers. Your coronavirus today, which has affected all of us, is about 80 nanometers in size. Just to give you a sense of what we are operating on, a human hair is 100,000 nanometers in size. Now, if you cut a human hair, one strand of human hair, to 1 lakh pieces, one piece is 1 nanometer. And we at Zydex, we operate between 2 to 4 nanometers in size. Now, what happens in our construction? Let us do a small chemistry. Soil aggregate, they contain SiO2 as its primary molecular structure. 80 to 85% of any soil or aggregate is called SiO2, silica dioxide, and that's what we name in our chemistry. Now, silica dioxide reacts with water, and on the top of the right-hand side, you see the reaction, which is SiOH. That's why soil absorbs moisture, aggregate absorbs moisture. Now what we do is at 2 to 4 nanometer size, we hive this covalent bond of SiOH and form a much stronger bond of SiO-Si, which is essentially an organosilane or siloxane bond. In other colloquial language, I can talk to you as this is an SiO2 bond. Now, SiO2 is silica dioxide. It is Mother Nature's strongest bond. It cannot be displaced or replaced. And at this molecular level, we are hydrophobizing the soil particle. So, how does this hydrophobizing of soil particle at the molecular level change the way we are looking at civil engineering construction is followed up in the next couple of slides. Next, please. The most important thing in any soil is its swells. When it swells, it reduces its strength. And today we are designing all our pavements based on the soaked CBR. That means when the soil has attained its full swell potential, we are doing our testing and designing our pavements on the soaked CBR. What does a waterproof soil give? It brings the unsoaked CBR conditions in soaked conditions. That means we are reducing the swell by 90% of its original capacity, thereby making it as a filler material. An unsoaked CBR condition is, suppose it is an unsoaked CBR is about 20, your soaked CBR is somewhere around 4 or 5. So we are trying to give you a bridge the gap under real-time conditions. Next. The next most important thing is percolation of water. So what we are doing is we are actually reducing the permeability of the water by this particular thing. And one study which CRRI has done and which we have replicated across India on different kinds of soils, on different kinds of materials, is we have been able to reduce the permeability from, say, a normal 10 power minus 5 centimeters per second to 10 power minus 7 or 10 power minus 8 centimeters per second. Now, what does this mean? Suppose I lay a 15 centimeter thick soil, compacted soil layer. For a drop of water to travel 15 centimeters, it will take 2 to 3 days at a permeability of 6.2 into 10 power minus 5 centimeters per second. That means in 1 second, 1 drop of water will travel 10 power minus 5 centimeters. So for 15 centimeters, it travels around 3 days. What we are bringing onto the table with our chemical is, when we reduce this permeability to 10 power minus 7 or 10 power minus 8 centimeters, the time taken for 1 drop of water to travel that 15 centimeters is around 1000 days. That means even during your rainy season of 3 or 4 months, we are keeping the base dry. Next, please. Let us look at, this is as far as what the chemical is doing. Now, where does the strength come from? The strength comes from your cement. We are using cement also as an admixture in the base, whether it's an FDR, whether it is a normal national highway, greenfield highway that we are working on. We take cement also as an admixture to the tune of between 5 to 6% based on the classification of the soil and the aggregates present there. Cement, when you have cement stabilization done, what happens is cement bonds degrade over a period of time due to ingress of moisture inside the specimen, leading to carbonation and weakening of the cement bonds. Thereby, what happens is your shrinkage cracks start moving onto the top, leading to failure of the cement stabilized base. What we here at Zydex bring is, when we use terrasil and Zycobond as an admixture in the cement stabilization, what we do is we repel the water at the top itself. So what happens is the durability of Zydex stabilized bases is enhanced further because permeability of water is completely reduced or cut off. Second, and most important, Zycobond, which is an acrylic copolymer, gives an additional flexibility to the pavement. This is very essential when you are designing for a flexible pavement. Not only does it provide an additional flexibility, it also cuts off the propagation of shrinkage cracks to the top, thereby increasing the durability of the pavement and preservation of the pavement for a longer time. Next, please. Let us come down to the prime coat. Now, we all know if you have a WMM or a WBM surface, it is essentially a water-loving surface. Now, on a water-loving surface, your prime coat is supposed to be a bond coat which binds the water-loving strata at the bottom to the bitumen-loving strata at the top. Are we doing this? The answer most of us know is no. Reason is when you are spraying a prime coat at 0.7 kg per square meter or 1 kg per square meter, we are assuming that the prime coat emulsion layer transfers 10 mm, 8 to 10 mm inside. We are allowing it to cure for 24 to 36 hours. And during this curing time, we are unable to stop the traffic, due to which you have tire pickups onto the surface. So the very fact of using a prime coat is gone. What we bring onto the table here is when we mix our chemical Terra Prime with 100 kg emulsion with 200 liters of water and we spray it at 1 kg per square meter. Now within 45 minutes or 1 hour, wherever the water is going, our chemical goes and hydrophobizes the entire surface of 8 to 10 mm. Within 1.5 hours, what happens is your surface is dried up because of the sunlight and your surface is primed and ready for the next surface, for the next layer. So we can actually crush time between the prime coat and the remaining bituminous layers in this. The second most important thing, the contractors normally add additional water because there is always a nozzle clogging. So this is eliminated by using this. At the same bond strength of 0.7 MPa, we are able to reduce the emulsion from 0.7 or 1 kg per square meter to 0.3 kgs per square meter. Next, please. The same with nanotech. Well, my 10 minutes is over, so I guess I'll have to rush up. Same with nanotech. We'll be having a cost saving with reference to nanotech as a tack coat. Next, please. Bitumen. Aggregate is also a water-loving substrate. So what we do here is we make the aggregate from water-loving to water-hating or oil-loving. Thereby, the maltines come and deposit themselves. So instead of a mechanical bonding, we are having a chemical bonding which is almost 20 times stronger than what we are having now. So instead of a 30-minute boil water test, which we do for anti-stripping, you can actually do it for 1 hour or 1.5 hours to test for yourself what is the kind of durability this chemical has. Second, it is also higher moisture resistance, higher fatigue resistance, and higher oxidation resistance because we eliminate the pinholes completely. Next, please. My suggestion to all engineers here is we are not following the BIS 14982 test properly. If you do a simple boil water test and ascertain for yourself on the field, you will understand what is the kind of durability that these pavements are having. Next, please. What is the basis of our design? This is for national and state highways. FDR is a straight form because all you need to do in FDR is scarify, put some cement, put some chemical, and then you compact it. But in national highways, if you look at the left side of the screen, you have a cross section of concrete. Now in concrete, you have aggregate, 20 mm down size, you have sand, you have water and cement. Now both aggregate and sand are non-swell materials. They are filler materials. And water cement is a binding material which binds, thereby providing the strength required. The same thing we are translating into pavements. With terrasil and zycobond, we are creating a non-swell material of soil and aggregate. So When we create a non-swell material of soil and aggregate, this becomes a filler material. Water and cement will become the binding material to bind it and give you the strength which is required for bases, which is 4.5 to 7 MPa, and for sub bases, which is 1.5 to 3 MPa for national highways. Next. And herein what we are doing is, we are reducing the quantity of the aggregate by almost 70%. In one of the tests that we had done in Kerala for one of the projects near Trivandrum, we had actually used 70% soil, 30% aggregates, and 4.5% cement to give you the strength of 4.5 MPa on the field. Previous slide, please. A lot of talk has been given on gradation. Now, there are two types of gradation which has been mentioned in IRCSP 89. On the left-hand side is table 1. On the right-hand side is the gradation which is being proposed for cement stabilization, which today FDR is being used. One of the points to note here is if you look at a sieve of 4.75 on both of them, grading 2 aggregate on the right side and the recommended table 1 on the left, you have passing 4.75 mm as 50% on the left and 40% on the right. So in cement stabilization, where you are using only aggregates as your model of construction, what we have done is we have taken soil where it can be divided as gravel, sand, silt and clay, taken 4.75 mm as the barometer. Above 4.75 if you have 50% or 60%, and below 4.75 if you have 60%, 40%, that means it is a good mix for your MDD. This is a thumb rule that we have adopted, and we have been fairly successful where our combinations vary from 70% soil, 30% aggregate to 60% soil, 40% aggregate for the worst conditions. Point to be noted here is we reduce the swell completely to 90% of its original capacity. Next point, please. Test done for mixed design, it is the same whether it is an FDR or whether it is for your national or state highways, which is essentially gradation, mixed design, Atterberg's limits, your OMC MDD, cube molds, UCS, durability. These are some of the tests that has been defined and we adhere to it. Next, please. Field testing, we have the gradation, UCS, same as per MORTS specifications. Next, please. Let me come down to this prime coat distribution. For a quick priming, as I have already mentioned, we have done more than 300 kilometers of prime coat applications in Uttar Pradesh, where the soil is essentially sandy silt soil with no cohesion. So that kind of a WBM surface also we have done about 300 kilometers. 2 areas in Jammu and Kashmir till Nagapattinam down south, we have done a lot of work on prime coat, and essentially we are mixing 1 kg of Terra Prime with 100 kg SS1 and 200 liters of water and spraying it at 1 kg per square meter. And this will dry up within 45 minutes to 1 hour, depending upon the external climate. Next, please. One of the most talked layers in FDR or in national highways is about the SAMI layer. Now, we have worked on a project in Tripura where the rainy conditions is similar to what we are experiencing in Kerala. That's about 2,800 to 3,000 mm of rain per year. Now here, what happens is, we are using a geotextile as per the specifications laid out in MORTH. Now the MORTH specification says you need to put 1 to 1.2 kg of bitumen, hot bitumen. What we have essentially done in Tripura, and we have been successful in that, we have converted this 1.2 kg of bitumen into RS1 emulsion, which is essentially 60% solids. That means 1.2 kg of bitumen translates to about 1.8 kg of emulsion RS1. Now here what we have done on the primed surface, 1.8 kg of RS1, we have divided it into two parts. 0.9 kg of RS1 emulsion we have sprayed at the first instance on the primed surface. While it is still in the tacky condition, we have laid the fabric on top of it. We have ensured that there are no warping or air bubbles in the fabric by cutting it and sticking it onto the surface below. We have run a PTR to ensure that the adhesion is proper. We have taken an overlap of about 4 inches outside so that this sticks onto the main carriageway. And on top of it, we have again covered it with 0.9 kg of RS1 emulsion. Now, essentially, this does two works. Number one is it acts as a stress absorbing member, which is why it is being laid. Number two, it also, by sandwiching this layer, we are protecting the geotextile membrane. We are also ensuring that the rainwater doesn't penetrate to their stabilized layer below. So that means, one, we have reduced the permeability of the stabilized layer. On top of it, we have given a sandwiched layer of geotextile where the water doesn't come inside at all. And this has been very successful, and I would like to advise or plead with you guys to use this as a model for your construction activities in Kerala. It is very good. I have already witnessed 2 seasons of rain on this. Next, please. In the bituminous layer, all you need to do is add our admixture into the hot mix plant, and there you have a black. Here in the bituminous layers, what happens is it also works as a warm mix asphalt. That means, you can actually reduce the temperature of a hot mix plant by about 15 degrees, thereby leading to a saving of 0.5 to 1 kg of fuel per ton of mix. And you can compact this bituminous mix at about 100 degrees. So this not only leads to optimization, reduction in carbon footprints, it also leads to savings for the contractor. Second, your bitumen optimization can also be done when you know that this is a chemically bonded surface rather than a mechanically bonded one. Next, please. This is a site which I wanted to show you today. It shows this is one of our first sites in Kargil, which is about 15,000 feet above mean sea level. It's a hilly terrain. You have snowfall of almost 8 to 10 feet. On the third photograph, you see a JCB. The snowfall is above the JCB. The JCB is clearing the snow there. This is the 5th season running, and there is no damage on the surface. In fact, if you look at the 4th one, you have half of the snow which is melting and the water running into the paved surface, and still nothing is happening. So this is a stretch which we have just cleared off this year, and it is up for the villagers to commute. Next, please. This is something similar to what Kerala is facing today, 2,800 mm of rain. We have done 2 projects, one in Andaman and Nicobar, where it has got a rainfall of 3,000 mm. In Andaman and Nicobar, we were handed the worst stretch where you have volcanic ash. So mining was banned. It was in the Jharwa region. We had volcanic ash as our soil, and we also had to make do with some cement stabilization which the contractor had done on the subgrade, just above the subgrade, because of want of aggregate. So we used 20% of virgin aggregates, 15% of essentially CTSB material recycled, and then with volcanic ash and some borrow material, we were able to do it. This is past 3 seasons of rain, doing good. The second one is the NHAI project, which we have just concluded in Tripura, where again it's a 2,800 mm of rain. Working good. All we need is how do we take this on into your land of Kerala. Next, please. That's the conclusion. I would just like to move 2 slides further. Next, please. Next, please. Next, please. For all the PWD engineers, in case you don't have the wherewithal to go for a recycler and other things, you can go with the WMM plant. And for keeping the soil aggregate mix green for at least 3 hours, we have actually used a retarder to bring this green material to the site and lay. So this is an option where you have a cheaper alternative for the regen recycler machines. Thank you. That's about it. Thank you.
Thank you, sir. Thank you for the wonderful presentation. Question from the audience. 2 or 3 quick questions, please.
No, not quite.
Okay.
We are here till tomorrow afternoon, evening. So our stall is there, number 4. Any of you guys have some questions, please come down to our stall and we'll be ready to answer it. Thank you so much.
Thank you, sir. Thank you for the wonderful presentation. The next presentation is the role of FDR additives in FDR technology. It's handled by Mr. Nitin Manawat, who is the director of VV Autotest Systems Private Limited, Mumbai. He has led a team to successfully reclaim the state and national highways by the FDR technology in Maharashtra since 2018, which includes sections of Mumbai-Agra National Highway during monsoons for a traffic up to 250 MSI at Ahmedabad bypass for subsequent applications of PQC or DBM/BC over reclaimed base. His team is now currently working on stabilization of BCS to minimize replacement of subgrade soil and minimal or no aggregate requirements for base construction. Over to you, sir. Sir, you have 10 minutes.
Good evening, everyone. And I'm the last presenter, so I appreciate a considerable number of you. I will not be taking much time. I will be taking maybe 5 to 7 minutes. And I will be talking less on theory, but more on practical, what works we have done, and would be willing to answer all your questions. Because I have been part of each and every project which is being displayed today in my presentation. I had been on the roadside and have done the work myself. So the role of liquid additive base seal, the name of the product is base seal, and it is in liquid form. And what role does it play in full depth reclamation? That is what is the title. So as you see, base seal liquid soil stabilizer is for last 37 years. It is being used in US since 1986. It is now being introduced in India since 2015. The government is after it. It treats all soils to sands. It has been implemented in US, Europe, South America, Asia, Africa, Australia. And we are also now into rammed earth housing. That projects are being done in US and in African countries. Here we have not yet decided that we will be getting into rammed earth, wherein we mix base seal into earth and make the house. At present, we have reclaimed more than 250 kilometers, including National Highway, State Highway, and MDRs in the state of Maharashtra. Next. So this is what I would like to show you a picture. We were being approached in August 19 that there is a 14-kilometer stretch if you go to Shirdi from Mumbai. So this was in this bad shape. And we were asked that in monsoons, can we fix it? So we as a company have got this specialization that we fix damaged roads during monsoons. You can apply the wearing course subsequently, post monsoons. So during the monsoons, there will be very minimal or no rutting because the rains would be curing it or keeping it wet throughout the season. So this particular section receives 3,000 mm of rainfall every year. Ghoti Shirdi, and it is a national highway. And we did this, the stabilization, the reclamation was done to the depth of 300 mm, and over which 25 mm of PQC was directly applied. So no DLC. Reclaiming of the existing crust, stabilizing it, and then putting PQC over it. Next. This is another road which has 6,000 trucks per day. It's Bangalore-Delhi connecting bypass for Ahmednagar, a city in Maharashtra. And the traffic is up to 250 MSA. We did 5 kilometers into 2 lanes in January 2020. So first one was in 2019. Now it is 2020. What I'm trying to tell you is that for last 4 years, 5 years, they have seen the rains and it is performing very well. Next. This Mumbai-Agra National Highway. The moment if you ever have been to Mumbai and gone to Nasik, to Trambakeshwar, you cross, you climb Ghat. And immediately after that Kasara Ghat, this section is there and there are several such sections. Here on the right, there is a hill, left there is a valley, and then there is a gradient. This entire section was damaged. And during monsoons on the left, what you're seeing is stabilized base on which traffic is running. So we fixed it in October and they applied the wearing course in the month of January, February. So for 4 months, the stabilized base took the traffic. Next. Now, what happens what happens? So the chemical reaction which the base seal does is it encapsulates the soil particle. So each soil particle is being covered with this chemical, and we are using a dry additive, which can be cement, it can be lime, it can be cement kiln dust, CKD, it can be LKD, it can be type C fly ash. We don't get type C fly ash in India. So with the calcium and this chemical, it forms a gel. So we basically eliminate the soil type. The soil type can be black cotton soil, it can be red soil, yellow soil, sand. We are bonding, we are covering the soil particle with the chemical, the gel, and doing a mechanical bonding. So we are changing the property of the soil, and therefore it becomes water resistant base. So there is no surface water penetration, there is no capillary rise. As the mixture becomes progressively more viscous, the chemicals, soil particles, and additives adhere to each other and form a flexible water resistant bond, and it keeps on maturing. So what I was in the previous speaker has mentioned in Stibble Road, that those EMPAs were of 2.5 years, 3 years, 5 years. We can show roads in Florida which receives very heavy rainfall, 20 years and nothing has been done. Next. So this was the original condition of the road. What we did was, next, used a motor grader, leveled it, next, spread the cement, next, and then this recycler. Now here one question was there, which was asked from the audience to one of the speakers. How do you ensure that this dose of 100 ml or I use 650 ml or 750 ml is going there? The width of the machine is 2.4 meters. The speed of the machine is around 7 meters per minute. And the depth of cut, say it is 300 mm. So you know 2.4 meter into 7 meter into 0.3. That is the volume of the soil you will be milling in a minute. This machine recycler, there are other machines as well, like asphalt zipper is a small machine which is on a loader, or there is a stayer machine. But why we are recommending these recycler machines, and we own 3 sets of such machines ourselves, that you can have a control on the flow rate. So I know what is the dilution ratio, by what dilution ratio I have mixed water and this base seal into the tanker. Say the dilution ratio can be 1:30, 1:60, sometimes 1:100. Depending upon the weather, we vary the dilution ratio so as to maintain the OMC. So that solution at what liter per minute, that is on us. So this volume per minute and that liter per minute, we match it in such a way that we give the exact dose to the soil. So this answers your question when you ask, how do we ensure that exact dosage has been given to the soil? So this is the, next. So this is the way the machine leaves the mixture. Now this is an old crust, base seal, cement. Next. So on the left and right, you see the treated and untreated sections. Next. And then we use PTR, and this is the final finish. During monsoons, we leave it like that. We release the traffic after 3 hours. So whatever section we have taken in the morning, we complete it by evening. 5 o'clock, we finish it. 8 o'clock, the traffic is released. So we release the traffic within 3 hours. Next. And this is the PQC done on that 14-kilometer section. Next. We can bind sand as well. This was evaluated by IIT Guwahati. This we did in 2016. We don't need aggregates. So the answer is we do not require aggregate. If it is there, it is fine. We do not need large size also. So it is zero aggregate technology. Next. This is the finished, what you saw from previous slide. That, no, the previous one. This sand was converted into, yeah, next slide, this road. Next. Yeah, this was the condition of the highway. They had black cotton soil on both the sides and we tamed it. This is Ahmednagar bypass. Next. Yeah, it was transformed into this highway. Next slide. Yeah, submergence and rushing of water. Now, if there is a submergence of the stabilized base, water level is going up and water level is receding, nothing will happen to a properly stabilized base. I am talking about myself. Next slide. Next slide, please. No. The previous ones. So after the receding of water, the base and the bitumen both are intact. Next. There are several examples to go and fix it. So this is an advantage of FDR or a stabilization of base. Next. There are examples in US as well, like the hurricane had come and it took away 1.5 feet of soil, and the Federal Emergency Management Agency of US has recognized base seal as a mitigation technology for the road works. Next. This we did in Bhiwandi, inside the city. There was hardly any drainage and we were asked to fix this because it is a very, very densely populated area. Next. In such a situation, we had no other choice because of the movement of the traffic during the day. It used to take 4 hours for a kilometer many times. That used to be the traffic jam in this area. Next. We worked at night. So we started work at 10 o'clock at night, completed it till the morning and released the road for the traffic. Next. Yeah. So 6 o'clock in the morning, the road is ready for the traffic. So we just changed the scenario of the entire section which we take over. Next. This is last I would like to say about the black cotton soil, wherein we are trying that there is a 15-meter black cotton soil strata. And how do you attend to the swelling and shrinking of such a strata? Next. So we did this last monsoon, and we have mixed weathered rock and black cotton soil 50-50, and we treated it with base seal, and we left it without any wearing course for the traffic to pass over it. Next. There was a flooding. So the difference between water rising and flooding. So there was a maximum rainfall in last 17 years occurred last year. And because of the terrain, there was a huge flood, and this was not only submerged, but it has a high gush of water. As you can see, the shoulders have been washed away, but the stabilized base of black cotton soil is still there. So that is what is stabilization. So whether you have only soil, you call it soil stabilization. You reclaim an old road, you call it FDR. But this is what the chemical brings into the picture, which cement alone cannot do. So a good chemical and a good execution process would give you such wonderful result. Next. Yeah, this is another view of a stabilized section. The shoulders have been washed away, but your road is still there. So you will not lose your road. It will be there. Next. Yeah, this is the last slide. What I would like to say here is that when you're going with such high technology and such high technology machines, and where the manual intervention is minimized, the quality parameters and the quality checking has also to go up. So nuclear density gauge or non-nuclear density gauges and FWD. So with this, you can be 100% sure that a good road is being constructed. That's all from my side, and thank you for your patience.
Thank you, sir. Thank you for the informative presentation. Any questions from the audience? 2 or 3 quick questions, please.
Hi, sir. At one place, you told that the PQC layer has laid
Yes.
for heavy rainfall damaged roads. So what is the total composition of the structures?
Yeah.
Have you provided any DLC layer below that road?
No. So it was 300 mm of reclaimed base, whatever was there, the old BC layer and the old WMM, WBM, whatever was there, and over it directly PQC. So no DLC. So the fundamental advantage is you don't need a GSB and a DLC. And for bituminous layer, if you're talking about a highway, say your typical cross section is with 90 mm of DBM and 40 of BC, so that 130 gets reduced to 50 and 30. So if you're talking about rigid pavement, no DLC required. If you're talking about flexible, you don't need a GSB and a WMM. You reclaim the road and you apply DBM and BC. As far as MDRs are concerned, 40 mm BC, you don't need DBM or BM. 40 mm BC is good enough. For very, very low, less than 1 MSA, I would recommend 2 layers of surface dressing should be good enough. The fundamental is you make your base strong. If your base is strong, that wearing course should only be wearing course. Entire load should be taken care of by your base. So your base has to be strong.
What was the traffic over there? Is it
70, I've written, I think it is 70 MSA. 70
So
MSA.
my question is like the rigid panel that will be 4.5 by 3.5.
Beg your pardon?
The PQC panel will be the size of 4.5 by 3.5, right? The size of the panel. So when it the function of DLC is to support the PQC layer, the uniformity. So when it comes to the bituminous surface, base layer, if there are any undulations comes in the future, so the PQC, there are chances of break when the traffic higher loads like more than 50 MSA.
Undulations won't come in future, because what we are doing is we are, as I have shown you, a very smooth surface after the PTR is being moved. So the PTR is moved, and that PTR is moved for 3 days over the finished base. And while we are making your camber, your super elevation, everything is being taken care of. And with that PTR, we are ensuring that those minor crackings. Another advantage with this particular product is that it retains the moisture. So hydration cracking are virtually nil, zero. So there are no undulations unless there is a rutting. And even if there is a rutting, what you can do is, it has got a self-healing property. Someone asked a question that, what if I apply a wearing course after 7 days or 10 days or 28 days or 2 months? Yeah, you can, if it is a rainfall area, you can live without applying a wearing course for a year. If it is wet, but the moment it gets dried up, the loose stones will come, and with the vehicle tire, there will be a grinding effect and it will wear off. And to answer your question that I'm eliminating DLC, and DLC gives you a smooth surface, and what happens if there is an undulation? Nothing will happen to this. It will be as good as DLC, if I can say. I will say it is more, but it serves the purpose of DLC. Same strength.
Thank you.
Yeah. And to answer that question, that what happens if I don't apply the wearing course, and if rutting will happen. If the rutting happens, you apply moist it, shave it with a grader, roll it, and then apply the wearing course. If it's a good stabilized base, nothing would happen.
Sir, you were talking about the black cotton soil.
Yes.
So black cotton soil, you have used it for soil stabilization or as FDR, base layer?
No, here I used soil stabilization as a stabilization project. It was not an FDR. There was no old road there. It was a greenfield road.
What is the difference between what is the difference in dosage of FDR and soil stabilization?
The dosage difference happens with so what we have done is base seal over last 37 years has evolved and have developed their formula such that we are selling it into different countries, and it being an expensive item compared to cement in any country. The dosage are between 650 to 750. You vary the quantity of cement or lime for the activity or the chemical reaction to happen. Now, a black cotton soil will have a large surface area, fine particles to attend to cover them fully. Wherein the percentage of cement on a regular basis, it can be 3%, 4%, there it may be 5 to 6%. So, but here again, I would like to say, we are not using cement for cementatious property. So let us not get into that, that cement will bring in hydration cracking. We are using cement as a feeder to the chemical base seal. I'm looking for calcium oxide. So that not necessarily, because cement is at the same price as lime, and I don't have lime kiln dust and cement kiln dust. In US, they sell cement kiln dust at $10. Whatever is the waste from the kiln is not mixed into cement. It is sold separately at $10. Their cement is at the same price, 7,000 rupees a ton as in India, but the cement kiln dust is sold at $10 per ton. So they use CKD or LKD for stabilization to bring down the cost.
No, sir, actually, if you're using 4% cement with 4% admixture or 1% stabilizer, the cost goes to around 3,000, 3,500 kg, rupees per MQ. So it's better we will replace the material with GSP or other.
I don't think so. See, the intent of why government is pushing for such soil stabilization FDR, why are we having this workshop, and why are we being forced to have this workshop is that in 2015, the government saw all over as a country that we have depleted our natural resources, we have cut our hills, this environmental imbalance. UP is right now having monsoons like it has in June, July. We are facing it in month of April and May, wherein these are the peak season for road construction, but the work is being stopped because of monsoons. So all this imbalance is happening because we have depleted our aggregates, and they're looking for green technology, wherein we don't have to use stones and we can recycle whatever we have put into the ground, and we don't have to bring in new. And what we heard from the chairman or the MD of Kerala Metro, that he was more happy that those the truck movement, vehicle miles traveled in the truck movement from the quarry to stone crusher to the site, congesting the road will not happen if I'm reusing, recycling whatever is available in situ. So these, when you look into the total holistic approach, where see right now what you're doing, you're trying to say comparing cost to cost, but if you take into account that those quarrying to crusher to site, those many movement of trucks on a good road, which you're damaging by, and you're removing that unnecessary trips. You are also saving the fuel which you're importing, and all these trucks are overloaded, so they're polluting. So you're saving the environment. So government at its level is taking into consideration all these aspects and promoting this. And in 2017 December, there was a conference in Lucknow where Mr. Gadkari had called ministers from 18 states and their secretaries, and they were asked to go back to their states and start using FDR. And therefore, this FDR has come into place. And we could do 250 kilometers ourselves, and some other people have also done.
Stabilizing, you are using it for subgrade or sub-base material.
It is
and over that, again, you are going to use base material.
Sir, it is a single homogeneous layer. Like in Ahmednagar bypass, where we did 250 MSA traffic, we did stabilization to a depth of 400 mm. 400 mm in one single stroke. The machine has the capacity of doing 500 mm. And 400 mm we could do, and we could compact using the 20-ton pad foot by more number of rounds. So we are the only company which has done, in fact, in Mumbai, we have done some state highways, SH76, which we recently did, again for 400 mm. So the thickness, when you verify stress strain with IIT PAVE calculations, and you do 400 mm, your wearing course reduces drastically. It comes down to 50 dBm and 40 BC. So to answer your question direct, subbase and base is one single homogeneous layer, and the thickness of the wearing course goes down. So in the long run, for the long life cycle, less maintenance cost and ease of construction, saving of environment, it is much economical compared to your conventional construction. Time, the project which takes 18 months, we can complete in 3 months. Imagine the overheads, the ease, why we are making roads for the use of public. If public gets that road in 3 months instead of 18 months, why not? And why they have to face the obstructions and the road closures. I'm opening the road every day in the evening, and every day I'm moving 500 meters. They would be happy. A man who goes into pothole-ridden road in the morning, and when he comes, he's driving at a speed of 80 kilometers. He's a happy person.
My question is that soil stabilization, if you do soil stabilization, you are using that layer as sub-base.
We're not using it as subgrade. We are using it as a base.
Then it is the same. Means FDR also you are using FDR as the base only.
FDR and soil, see, as explained by the speaker from Vishwasamudra, there is no much difference between the FDR. FDR is where there is an old road and I'm reclaiming it. We are calling it reclaiming. Where there is only soil, I'm stabilizing. Same chemical, same process, same machine, two terminologies given. When it is pure soil, stabilization. When it is an old road, reclaiming of the old road. That's it. Okay. And one more thing which I want to add, if you are interested, look at IRC 120/2015. It explains in more detail recycling of the bituminous pavements. IRC 120/2015. Have a look at it. It gives the description of the machines as well.
Thank you. Thank you for the interaction.
Yeah. Thank you very much for your patience. Thank you very much.
I request Sri Arun Thomas, Senior Project Examiner, KIIFB, to hand over the memento to Mr. Nitin Manawat, VV Autotest Private Limited. Now I invite Mr. Krishna Ramella, Vishwasamudra Private Limited, to receive the memento. I invite Mr. M.G. Prashant, SIDEX, to receive the memento. Thank you, sir. With this, we have come to the end.
In fact, very energetic sessions. And more than that, like many audiences at 45 is it is very encouraging. Tomorrow we will start our session by 9:30. Okay. And we would like to complete all the presentations in the morning and probably middle after the lunch. We would like to have way forward. So many technologies we have seen today, and the lessons learned also we have listened from the experts. So tomorrow probably for the lunch we will sit and decide what we should do to move forward. Okay, and I know that when there will be more questions, people are reserving the questions for tomorrow. We'll have interactions tomorrow, more interactions, and probably we'll listen from the experts, from the industry, from the practitioners and all. Okay, thank you all for your the presence here. And lunch, dinner is also arranged here. We invite all of you to join for the dinner here at around 7:30. Right? Okay, thank you.
Once again, thank you all participants. Participants, please make sure that you have signed your attendance that has been circulated.